Good morning, everyone. Good morning. Welcome to another edition of the Zak World of Façades conference series. My name is Ahmed. I'm part of the organizing team here. This is our third edition in Jakarta and our 130th global edition. Thank you all for taking your time to be present here. I'll take a quick 3-4 minutes, introduce the event to you as we have people coming in, and then we'll get straight into the presentations. Can I have the screen switched off? Turned on, sorry. So we started the Zak World of Façade conference series in 2012. We started it as a small networking event. We've been all across the globe, completed around 129 editions in almost 38 countries. This is our event map for 2023. So well spread right from New Zealand up until Canada. We've got events. So it's been a great journey for us. Indonesia was one of our few early countries which we came back in 2017. That was our first edition. Then 2019. Then, of course, we had a slight break, and now we are here back after 4 years. It's been an interesting growth for us in terms of taking this event to different countries. Facade engineering is getting complex. No more the buildings are glass box, so they need to be engineered efficiently. So there's been a lot of interest and demand for facade engineering. Facade engineers itself as a profession is also increasing. And plus, if you add sustainability and other climate change challenges, the facade plays an important role. And events like ours, I'm sure, gives a platform or gives ideas for people and creative designers like you to think a little out of the box. I hope you take that and go at the end of the day. No events possible without partners. I'd like to start off by thanking our event partners with our presenting partner first, Schuko. Schuko is a global leader in aluminum door, window, curtain wall systems. They have a strong presence here in Indonesia and growing year by year. They are our presenting partners for this event and excuse me, and all our Southeast Asian events. We'll start with our associate partners, China Southern Glass, again leading value-added glass fabricator out of China. Dow, one of the world leaders in silicon bonding and joining solutions. Elval Color, Greek manufacturer of non-combustible composite panel materials. Jotun, a leader in powder coating solutions for aluminum profiles, doors, windows, facades. Kurare is the leader in laminated glass interlayers. You would have known their brands as Trocifol and Sentry Glass SGP. Orga Data, a German manufacturer, a German software solution provider of estimation for doors, windows, and facades. Serge Ferrari, French company, they've got fabrics. Fabrics are generally used for tensile application, but now it's being used on facade, for new build, for renovation. Again, interesting product. Sri Reborn Industries from Malaysia, along with their partner Breezeway. They have interesting louver window concept. 2960, distributor of a lot of materials, sealants, fixing systems, railings, and many other products, originally from Singapore with international distribution partners. Vector Foil Tech, German manufacturer of ETFE. I'll let them explain what ETFE is later, a lightweight solution for roofs and facades. And of course, our supporting partner is the IAI, the Indonesian Architect Association, and of course, Perafi, which is now the leading voice for facade engineering here in Indonesia. So these are our supporting partners. Our next few events, just quickly run through. So our next events in Seoul in Korea. We've got Sydney. We've got Jeddah in Saudi Arabia. We've got Mumbai in India. And in the region, Vietnam is the last event for the Southeast Asian region. So these are the events we've been, these are few of the upcoming events. Of course, we've got more in the US, in the UK, in Europe. I just thought I'll give a glimpse of our upcoming events. So this is what we've been doing. We intend to keep doing, spreading awareness about good technologies, good practices in facade design and engineering, and then you'll be hearing from all our speakers today, which is a mix of architects, facade engineers, consultants, product manufacturers, and we've got two interesting panel discussions, one on sustainability, which is the global topic and the global theme almost everywhere. Climate change is real, our temperatures are becoming hot, we're having extreme weather issues. So climate change is important. So our first panel is on sustainability, and the second one is more to do with the regulation here with the projects in and around Jakarta. So that's what I have in store for you here. But before we start the event, I'd like to call upon the chairman of Perafi, Mr. Fibra Reelianto. He'd like to make a presentation about Perafi, their activities, and he would quickly introduce Perafi. Please come over. And then I will introduce you to our event host, and after which we can get the program starting. Just to let you know, we will not take any Q&A due to time shortage. So we will have only the presentations. Any questions you need from the speakers, you can approach them in the networking breaks. Please meet them. And also don't forget to meet our sponsors. Don't be shy. Our sponsors are very interesting companies outside. They've got good solutions which would be helpful for your projects. So once you have your tea, coffee in the networking breaks during lunch, please do drop by the booths. We've got around 13 booths outside. It would be very interesting for you to have a look at them. So Fibra from Perafi, he's going to be taking over to make his presentation.
Terima kasih. Ladies and gentlemen, Bapak dan Ibu, selamat pagi, salam sejahtera. Allow me to introduce myself. My name is Fibra Reelianto. I represent Perafi, Perkumpulan Ahli Fasad Indonesia, Indonesian Facade Association. Expert, enthusiasts, and distinguished guests, please accept my warmest welcome to this prestigious facade engineering event, Zak World of Façades 2023. My sincere gratitude goes out to our excellent organizing team, Mr. Ahmed and the team. This conference would not have been possible without your tireless effort, planning, and commitment, and all the partners as well. Here is the remarkable story of how vision ignited at Zak World of Façades in 2019 led to the formation of Perafi, Perkumpulan Ahli Fasad Indonesia in 2020. This journey is a testament of the power of collaboration, inspiration, and the commitment to drive positive change in the realm of facade engineering in Indonesia. Since our establishment, Perafi has achieved a milestone that underscore our commitment to this vision. We have not only united professionals from diverse background, but have also facilitated a platform for them to share insight, experience, and groundbreaking idea through our program. And today we have the Zak World of Façades. It's not just a platform of dialogue, but it's a launch pad for innovation and knowledge of sharing as we come together to share insight, challenges, and breakthrough. Today, Perafi has honor to be requested by IAI, Ikatan Arsitek Indonesia, and through our collaboration with other governmental bodies, policymakers, and industrial stakeholders, we would advocate to regulation that address the key aspect of facade engineering in Indonesia. By offering our insight, conducting research, and providing technical expertise, we believe Perafi can actively contribute to the creation of regulation that ensure not only the safety, but also environmental responsibility to our built structure. Ladies and gentlemen, the future of facade engineering, design and engineering is woven with the challenge and the opportunity presented by green building issue, BIM, digitalization, and AI as well. As architects, engineers, and visionary, we hold in our hand the power to shape the future of our built environment. Let us embrace sustainability as our guiding principle, leverage technology as our ally, and embark this journey with the unwavering commitment to create facade that transcend expectation, minimize environmental impact, and contribute to the well-being of our planet. Thank you for being part of this transformative experience. Let us embark this journey together as ambassador of innovation and advocate for more sustainable and beautiful future. Welcome to Zak World of Façades 2023 in Indonesia. Sit back, relax, and enjoy all presentation. Thank you.
Thank you, Fibra. I think it's interesting to have an association for facade design, facade engineering in a country, especially when facades is still in a very nascent stage. It's good to help to get regulations going to streamline systems in place. So I wish Parafi all the very best, and we at Zak are always happy to support such kind of initiatives. Okay, we'll get straight into the event. Our role ends here. I'd like to call upon the event host and convener, Ms. Putri Anindia. She's the head of planning and design at AstraLand Indonesia. She will be hosting the event today and taking you through until the end of the day. So, terima kasih.
Okay, thank you very much, Ahmed, for setting tone of the day for us. Very good morning, a very warm welcome to everybody, ladies and gentlemen. Before we go into today's program, may I inform you that we will not be taking questions for the speaker during or after their presentation, but the speaker will be around. Please do approach them with your question later. So, all right, I think we are now ready to welcome our first speaker of the day, Daliana Suryawinata. She's the founder and director of SHAO. She will be sharing with us the topic of performative social climatic facade. Please, a warm round of applause. Welcome for Daliana.
Selamat pagi, Bapak dan Ibu sekalian. Good morning, everyone. Ohayo gozaimasu for our Japanese friends. It's a great pleasure to be here today. And I do like the word envelope because it's protective. It protects what's inside, and it has the duty to perform. And that's what we think facade should do on all sides, not only in front. So facade should be all over surrounding. So today, this morning, I have the opportunity to represent SHAO to talk about our approach and how we use facade to cool the building in this tropical climate. So with that, we will show our little projects, micro-libraries in Bandung, in Semarang, but also our recently completed creative center in Tasikmalaya, and there is a sneak preview of a collaborative project we're doing in Jakarta. I would like to introduce to you Florian. He's not here today, but he's always with us at SHAO. So our background has always been Indonesia, Germany, Netherlands, where research practice is kind of intertwined as well as with education. So we try to see what's in practice to bring to the education and vice versa the other way around. Our mission is performative architecture. So in any project that we do, in any scale that we do, we'd like to have it contributing to the livable cities. So the idea of a livable city, Jakarta is not livable yet, we all know that. But through architecture, we want to make it as a device to sort of improve public life whenever possible. So with that, facade comes as a part of being performative that we'd like to see in all our projects. So this is an overview of the projects that we have at SHAO. At the moment, there is more. And it is a range of different scale, from a super small library to a concert hall to public space designs, which is in West Java, in IKN, and so on. We have a specific approach towards how we are responsible to the people, the neighborhood, the users around us, as well as addressing environmental concerns. So our team at SHAO is working hard on this for every project. We try to induce this notion of social climatic design. So it's like useful for the people around, but also climatically performative. That it cools the building, of course, in the sense of being in a tropical region, such as Indonesia. So the first project I'd like to showcase is this microlibrary Bima, such a small project actually, also even a community project, which says that not all projects have to be high-end projects that uses interesting facade. This one we use 2,000 ice cream buckets. So, in Indonesian weddings, there's always ice cream for dessert. And so what happens to these buckets after the wedding is over? Actually, it's not thrown away. They're collected. And if we are diligent enough for over 3 weeks to collect 2,000 of them, we could even position them as walls, as building facade, which when we perforate some of them, it could let the airflow, so the cross ventilation, as well as being white and sort of light emitting. It's helpful for the natural daylight as well. So this is the simple, super simple building with reuse facade, bucket facade, and there is a stage underneath which responds to the community programs. So we believe that when it looks nice from the outside, it should feel good in the inside too. So it happens to be that this unexpected material, so cheap, so used, it works very well with natural daylight. So you don't have to turn on the light during the daytime. And for the programmatic responsibility on the ground, under this, on the stage, under the volume, a lot of different activities happen. And this is the beauty of practicing in Indonesia. This will happen to most of the projects. And it is nice to include public life into the design of a building. So this is how it looks like in the evening. It's like a lantern that lights up the neighborhood. It's a kampung neighborhood, so it's not a high-end residential neighborhood, but somehow these people, they appreciate it and they become part of it. And it's nice as architects to see that happen. And an underlying concept behind the facade is that we work together with someone who coded this for us. So the opening, the perforation of each bucket is coded into a binary code, like 0 and 1. And if you read it through, the message is, buku adalah jendela dunia. So it's actually Ridwan Kamil's message as a mayor of Bandung then, when this was built. Moving on to also another small project, all in wood. This one is in Semarang. And we collaborate with Kayu Lapis Indonesia and its foundation and the city of Semarang as well. So it uses all FSC certified wood, and there is a curtain behind the wooden brise soleil. So when it's heavily raining, you have to put this curtain down, and it's a hospital grade curtain, which is used to blood splatter and could be used to rainwater as well. So in the evening or during the daytime, when it's not raining, the curtain is open. So there is a kind of transparency, facade as a breathable skin, which in this tropical context is helpful with the cooling. So definitely no air conditioning is needed. Although in the context of Semarang, it's a hot city like Jakarta. I mean, Bandung is easier, it's slightly chiller, but Semarang, Jakarta, Surabaya, they're hot cities. And it is important for us that not only the facade is interesting, but it's integrated also with the different transparencies and porosities and playful space that goes with it. This is a library, and libraries are not popular in Indonesia, so we would like to get kids on board, to get the young at hearts to also enjoy the space, use it as a slide. And going up the library, there is a staircase. And I would say this kind of architectural oblique surface, it goes with the facade as well, because it's not vertical, it's not horizontal, it's somehow the stairs. So it is interesting to to use stairs as an extension of the facade as well, if you like, and different kind of surface which can be used for seating. So sitting down doesn't have to be on a chair. It could be on the floor. It could be on a net while relaxing, and bisa tidur-tiduran juga sambil baca buku di situ. And the facade story goes also hand in hand with the cultural icon of Semarang. So if you're from Semarang, you might know a mythical creature called Warak Ngendok. And this is a dragon, a short dragon actually, a compact dragon if you like. And it is a symbol of unity of Arabic, Javanese, and Chinese cultures. So it's beautiful. It's nice to have that story underlying the Zollinger facade construction, which is a 1920 construction system from Germany, adapted and use it as a performative facade, while it happens to be that it's metaphoric enough to go with the Warak Ngendok skin, dragon-like skin. So it filters the sunlight, and it filters light rain, but we do need the curtain when it's heavy, when the rain becomes quite heavy. So these are some kind of community activities that happens there, and it's being run right now by a local community in Semarang. Next on, recently opened, this is a West Java province project. So this is not the only creative center but there is one in Cirebon, there is one in Bogor, and so on. They're done by our friends. And it wants to have this creative factory feeling where creativity is part of the making, the producing, the workshopping. It's not a clean thing, but it's a factory thing. So ini di Tasikmalaya gitu. Terus it has this kind of open, welcoming stairs for all to be, because cultural centers are not a common thing in Indonesia. It's regarded as maybe you have to pay to enter, and people should not think that. I mean, culture should be free, right? Jadi ada tangga-tangga bisa buat duduk kalau sore-sore, walaupun tidak berkegiatan di situ, tapi bisa masuk juga. And the context is that it is a sports field, a sports complex actually, yang mana ada parkir tuh di bawahnya. Dan parkir tuh di Indonesia penting sekali, nggak bisa di-erase begitu aja. Jadi kita coba integrate, we try to integrate the existing parking, which the land was for, because there is like a famous sports stadium around. So people actually go there, people need to park. And then we elevate our program on top and make it a kind of flow and function shuffler. So that's basically the architectural idea behind it. And it contains one auditorium for watching movies, and as well as an exhibition space, indoor and semi-outdoor at the same time. So in this case, yes, we use air conditioning when it's needed, but not when it's not needed. So Tasikmalaya is famous with its anyaman, weaving craftsmanship, and we think it would be interesting to see how this could be part of the facade solution, or actually in totality, we would like to bring this local reference in, but with the material which is of course more durable, because this is a government project. This is not a private project for Tasik. So it has to be easy to maintain. So the weaving concept, we have different openings, porosity, enclosure, that is related to the program behind it. So when it's an auditorium, it does not need that many opening. When it's the exhibition space, it can let a filtered opening, so some natural sunlight can pass through. So that's the design as we had it before the realization. And the next slide is how it was built. So it's not so different from the rendering. We are quite happy with it. As in government project, I told you there's a lot of problems all the time. So we never expect too much, but this one came out quite all right. So the front yard is used and landscaped, and people can can play there, the stairs as well. But I think the facade performs in a way that it does filter and give transparency to the whole building, that it's not heavy, that it's kind of light enough, and it's tropical enough in a way that it has balconies. Kan kayaknya perlu dibedakan kalau bikin cultural center di Jerman atau di Belanda, di Jepang versus di Indonesia, kayaknya perlu lebih tropis kita. Jadi mesti banyak ruang-ruang antara luarnya, in between spaces, which is saying that we're tropical. There is no winter here. Okay, so kayak gitu. Jadi the facade wants to also have this possibility of you can open the whole glass facade inside, glass wall inside, that you can let it cross ventilate. So then you can turn off the AC. But when it's a serious exhibition and you can't let any air from the outside flow, then you close it off, put on the AC, and that's fine. So it looks like this. From one side, it's a long building. We like that facades could be viewed from like a different perspective, sort of a different angle, have a different effect. Ini parkirannya di bawah. And beauty about Indonesia is that the plaza is always used by different users, and so we have different appreciation towards the building itself, as well as from the building towards the outside. So I think that's the beauty of having a porous city kind of facade, which can still relate the indoor and the outdoor. So some of these projects brought us to our most favorite project right now, and I'm happy to preview this with our collaborators, Shimizu Corporation, who are here, of course the Shao team, but also Meinhardt Facade Engineering and Nagata Acoustics, and so on. So this is like a big collaboration, and this is going to be in Jakarta. We cannot tell you where exactly and who is funding it, but it's going to be done. So this is the aerial view of, we call it Rumah Budaya Indonesia Kaya. So I think from the name, maybe you know who's making it, but it's all right. Jadi 1,200 seats of multi-purpose theater with different facilities. So the concept, it is important, we think, that facade is always go in line with the whole architectural concept, the landscape concept, as well as the urbanistic concept when it's possible. So the kind of and it's important for us to set the context that this is a tropical cultural center. So it is, we went through many iterations before we got this really approved. So the rice field sets the context that the building is not a monolithic, huge volume, but more separated into different bands, different terraces, like the rice field, also with the landscape as well. And that there is a semi-outdoor space where it's a kind of like cave hidden garden. And the facade in this case is super important because that gives the feeling of a kind of Nusantara kind of facade, which is important, that this is an Indonesian cultural center. Jadi bukan di Mars, bukan di Jerman, bukan di Belanda, tapi dia itu di Jakarta, di Indonesia. And pucuk rebung is an important pattern because it's widely used and interpreted in different cities in Indonesia. So it's not only a Jakarta thing; it's a Nusantara thing. Nusantara by Nusantara I mean the whole Indonesia. So the concept, multi-purpose theater above. We have other functions like black box, different classrooms even for the choir school, etc., music school. There is also a cafe and souvenir, but it's bound by this void, which is a semi-outdoor lobby. So this is where everybody comes in. There is an amphitheater and a garden and so on. So the close-up of the aerial view and what's inside. So that's the multi-purpose theater hall. There are a lot of facilities for artists. So it is known that artist performers, they're usually underserved. They usually have to just sit around at the backstage before the performance. But this building wants to provide more like a Japanese standard, European standard of also appreciating the artists, so that they have their own rooms to do makeup, to do shower, to do practice before the performance, and so on. And this is the facade. We think it has this kind of abstractness, but also very contemporary look of the pucuk rebung pattern that we adapt to this to the design, and it gives a different perception, feeling, views, whether on different times of the day. So when it's morning, when it's noon or afternoon, and at nighttime, it lights up. And we work with, oh, we forgot to mention that Pak Davi Sukamta, structural engineer, is in the project, but also Pak Hadi Komara, who's the lighting designer. So we're working all in all in a kind of choreography of so many engineers. So this is the visualization of the facade. And please bear in mind that this is a schematic design stage. So we're still studying this together with our partners, how to do this best, because we want something light, something floating, if you like. But I mean, architects always have vision, and then engineers have to work it out, and contractors have to deliver it, as well as suppliers. So it's a collaboration. So we will see what we'll get. So we're thinking about a possibility of cable structures. So looking forward, if you all have anything to share about that, or light frame structure. We're still in between. So with that, we need to emphasize that facade really should be performative, and maybe we can calculate this further by doing, for example, a solar radiation analysis. So we have this in-house. Florian happens to be a professor at NUS studying this aspect of the design of the light. So we try as much as possible in our design to work through this by means of analysis, so it could really be reducing the heat. So this is almost the last slide, and to remind that of all of our projects, we try to hit one or two or more those SDGs goals. They're great goals, they're quite amazing. So if possible, we try to incorporate that into the design, such as this theater design. So terima kasih, thank you very much, hatur nuhun, for everyone who has come, and thank you for making Xiao part of the Zak Facade conference.
Thank you, Daliana. It was very inspiring to hear what Shaw is actually brewing in their office, and then it's a very touchy subject for me. As Indonesian, a lot of the public spaces, public buildings are far from, like great design, but Daliana and her office is putting a lot of effort celebrating our own culture, Indonesian culture, and thank you for that. We are going to welcome our next speaker, John Stanlake. John is the Regional Director of Inhabit Group. John will be sharing with us the topic of facade beyond glass and aluminum. Please join me in a round big applause for John.
All right. Good morning. Selamat pagi, everyone. I'm going to talk about sustainable design in general, but a little bit beyond just glass and aluminium, and how we come about it. This talk, if I did this talk 10 years ago, I probably would have nothing much to say. 10, 15 years ago, sustainable activities would have been put the paper in the bin, recycle your cans, and do your glass bottle. But today, very, very quickly, the world is progressing on because we need to save the planet, basically. I think everyone in this room would agree. You look at North Jakarta, it's sinking slowly into the ocean. You go outside, the air we're breathing is getting worse. So there's examples of what we need to do or how we need to fix it. So the topics I'll talk about are sustainable design, high performance envelopes, compliance, building analysis, environmental analysis, building physics, and carbon engineering. So what is sustainable design? We get clients come to us saying, I need a sustainable building. Okay, what do you want? Sustainable building. A lot of people don't have an idea of what sustainability is and what you can design. So it's broken up into a few areas. You can have sustainable design itself, high performance envelopes, compliance, building analysis, environmental analysis, building physics, and carbon engineering. So one of the later speakers will talk about carbon engineering, so I've taken a few of the slides out for that one. Sustainable design, let's not kid ourselves, is money. We have to spend money in order to do a more sustainable design, but how much money and how to do it smartly. And a lot of it is in small details. So a lot of it is not monumental changes to your design. It's just small details as you go through. The sectors for sustainable design is everything, okay? Other than perhaps someone's private house. So what we learn from one sector will apply to another. Retail may be similar to mixed development. Residential, for instance, is quite similar to the hotel sector. So all of them we learn from each other. And surprisingly, the industrial sector is actually going quite fast because they have a straight dollar line advantage of building a sustainable facility. So when we go through sense, we look at sustainable design. There's a lot of different marks out there. So obviously in Indonesia, we have Green Ship, BCA, we have WELL, we have LEEDs. So these are quite clear what you need to do to achieve the different levels. So for these ones, I think most people would understand to get platinum, gold, silver, etc. And there's a very clear definition of how to go about it. But let's get down into a little bit into the nuts and bolts. So building physics is your building. So in some countries now, you can't build a facade without doing a thermal analysis. So some countries are already setting a limit. So your facade must be designed to a certain U value or whatever the ETTV is required. But how do we go about that? So we have a lot of tools now to analyze the building. We can analyze through condensation, we can analyze to stop mold, we can analyze thermal growth, thermal transfer. So all of this exists. And a lot of the technology came from Europe because it's obviously cold. They want to keep the warm in. And everyone says this is a tropical country. Well, we have exactly the same problem in reverse. We're trying to keep the aircon in and we're trying to keep the heat out. So a lot of what was developed in Europe over the years is applicable to Indonesia and all the tropics. Now, the next section that I want to talk about is the environmental analysis. So one is analyze your building. Two, where is your building? So the building analysis can be done through things like CFD, there's wind studies, there's glare studies, etc. And this is very important because as the climate does change, winds get higher, temperatures get hotter. And there's real life examples of what's happening. For instance, next to our Singapore office, there is a massive canopy. And no one will go in this canopy because it's just under this canopy. It is so hot. So no one's done the proper analysis to see whether the wind can come up there and move around. In our Melbourne office, there's another example, the opposite problem. There's two very tall buildings and there's literally a wind tunnel between them. So they've built a nice area to put cafes and things. No one goes there simply because the wind drives between the buildings. So it's extremely important to understand finally building physics, and two, where is your building sitting? Is there a tall building shading it? Is there going to be wind blowing through there? Are you going to have a level 50 restaurant that no one can go to simply because the wind is too strong? So these are some of the tools we can use. Okay, the next one I want to talk about here is high performance envelopes. So as we develop along, we can do a standard facade, we can do high-end facades. One of the key criteria these days is a thing called passive house. So passive house is a high-level facade. So again, technology or the design exists, but does the client have the appetite to pay for it? And can the industry build it? So these are the questions that we technical people need to give the tools to the client so they understand what the costs are and what the benefits are. Okay. Again, some more of the analysis here. This is the building analysis itself. And these are unfortunately a little bit individualistic. They're not, when you say I have a sustainable design, that doesn't necessarily mean you need to do a glare study. It doesn't necessarily mean you need to do individual studies. But these are some of the studies that can be done to help you along. And the greenhouse gas is one, carbon is another one, which I believe one of the other speakers will talk about. So these are the sort of things we need to start looking at. So as I said, carbon engineering will be talked by someone else later. But if we don't do something now, the world is going to get worse, okay? It's as simple as that. So already we have clients. There's a client in Singapore that's put into their requirements 70% recycled aluminium. The cost came back and they very quickly said, how about 30% aluminium? But 30% recycled aluminium. So that's a great start. So we've gone from having no recycling. This client's had high ambitions, realised the cost, but at least now 30% of the aluminium in that building will be recycled from recycled aluminium. So this is what we've got to aim for. We start with 30, in another few years it might be 50, it might go to 70 eventually. But we need to start now to understand the implications. So how do we do this? So the old cliche is reduce, recycle and reuse. So one of the other speakers later will talk about reusing buildings, basically recladding them, which is a great thing. Pardon me. There's other ways of doing it through, these are design things, and actually they're just common sense. So as much as we say sustainability, it's actually about being cost effective, and it's just about smart design. So these are some of the ones I'll have a look at now. Okay, this slide I'm not going to go through point by point, but it has an architect, it has a facade consultant, it has a contractor and suppliers. What I'm trying to show here is that everyone's involved in the process. The architect must design something realistic, something. The engineer, facade engineers must make that into a usable design. People must procure properly, people must install it properly, and people must use and maintain it properly. So everyone from A to Z is involved in the process. Now, this is always a fun one, ratios, building ratios. So if you look on the left-hand side, the circle and the square, or not quite circle, hexagon, and the square are the most effective building shapes, down to the odd ones. Now, good luck getting the rock star architects in the world to come up with a square building for you. They're still going to come up with odd shapes. But these are real buildings and the ratios and how effective they are. So again, we all want signature buildings, but at some stage we've got to balance that signature shape with something that's more effective, which tends to go to the left, which is circles, squares, rectangles, and not all the odd shapes. And that is part of what sustainable design in the future will be. Not just I have a magnificent building, but it's completely ineffective. It needs to have a realistic shape to it. The next one is dimensions. A lot of projects we get architects coming. I want 2.4 metre panels. I want them to do this and I want them to do that. The reality is there is an effectiveness in design. So once you go beyond certain ratios or certain sizes, buildings become more expensive. And they also have more carbon in them. And they're also not so sustainable. So they're all linked together. An interesting trend going on in Australia at the moment is the floor-to-floor heights in buildings is actually going down. So the old days where we went up, 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 sometimes up to 4.5 metres, the building heights now are coming down to 3.8 metres. Raised floors is a classic example. Raised floors are great. You can put all your cabling underneath, very easy to maintain. But a raised floor, 500 mil, all the way up a building, substantially makes your building higher. So if you don't have raised floors, you can lower your building heights. So the trend as clients want to become more green is to reduce the floor-to-floor height. And that's just not facades, that's also the M&E. The ducting has to be done in the core a little bit more effectively than it would be over the floor plate. So all the players are involved in it. Features is a cut back on features. When we design buildings, we like it to look the same on 4 sides. Why? Because it looks nice on all 4 sides. There's a very nice building in Singapore, Capita Springs. It has fins as its feature, which is great, but you go to the laneway in the back that no one goes to, and the fins are all the way down to ground level. Why do we need all this aluminium sticking on a laneway? okay? It's a laneway that everyone uses as a shortcut. No one cares about that. So we need to start thinking, do we have different glass on different elevations? People will say it looks different, but I would actually challenge you to see the difference between the glass, because most people only ever look at a building from one direction and then they'll look at it from the other. So I'm sure the architect and everyone worked on it could see the difference in colour, but most people will know no difference. Same with sunshades and things. Put them on the side that makes a difference. So we've got to get out of this mentality of same, all over the place and design it to the environment. This is a very interesting one. I used to work for a contractor and we always measured our facades by how many kilograms per square metre the facade was. The less, the more efficient. The less carbon in the building. So governments are already starting to control thermal, ETTV or OTTV, wherever you come from. What about if government suddenly said you're only allowed 14 kilograms of aluminium per square metre of your facade? That's one way of dramatically reducing carbon. So, but this is a very contradictory thing, because I'm going to tell you here on this slide to reduce aluminium, and then on another slide I'm going to say put some sunshades in to provide better thermal performance. So on one hand, reduce aluminium, on the other hand, put some back in. So a lot of sustainable design is contradictory. So at the end of the day, there's a thing called full life cycle analysis. That's the important one. I put more carbon in my sunshades, but maybe that reduces the operating cost of the building over 30, 40 years. Therefore, I use less carbon over the life cycle of the building, but I use more initially. So that's where a full analysis is very important. Recycling I mentioned before. So this is just some of the figures. Eventually, we will be forced as an industry to recycle more. It's as simple as that. Efficiency in design. This is one that I find amazing sometimes. We all work for a business. What a business is about? Making money. Yet time and time again, we see inefficient designs all over the place. We see a 30-storey building with the same curtain wall all the way up 30 floors, designed for a wind pressure that's in one corner at the top. We need to design, and we have the tools, design much more efficiently. So we're not wasting money, we're not putting more carbon into our buildings and making our buildings more sustainable. But time and time again, it's not like that. This is the contradiction in my talk now. Sunshades. So I just told you, get rid of as much aluminium as you can. Now I'm going to say, well, sunshades do have a use. But again, this is a design parameter. Sunshades of a certain size are effective. We're designing a, can't say which building in Singapore, where the client is insisting on 2-metre sunshades. It's just ridiculous, okay? But the architect and owner want these massive 2-metre sunshades. And that same owner is in the newspaper saying, we've gone green, we're sustainable. Well, you're not really if you're putting 2-metre sunshades in your building. So again, it's a matter of, do we have the techniques? Yes. Can we analyse it? Yes. What is the end cost of money? What is the end cost of carbon we're putting into our building? And what are the sustainable pluses and minuses? This next one is just about thermally efficient design. Unfortunately, in Asia, it hasn't really taken off because everyone thinks it's cool inside and hot outside, whereas Europe, the other way around, have a lot more thermally efficient design. But as I said, now in different jurisdictions or different countries, the world is starting to change where you have to do some form of thermal design into your facades. Glass build-up. Now, lots of architects will hate me, and I probably would put myself out of business very quickly if I said, don't do shadow boxes, get rid of glass. And again, this is a contradiction in real life. So many of the tall buildings we've done around the world, they're all glass boxes, they're lovely, we all think they look great. But on a lot of jobs, the client's project managing team will go, we'll put in a higher wall, less glass, more effective. Tick. The client's owner comes out and says, the owner of the company, the big directors, why not? Good idea. Less glass, more efficient. And then the leasing people, who are the most important people in the company, will go, full height glass can lease. This one I can't lease. End of story. So full height glass comes back again. It's a commercial reality. So again, it's a balance between sustainable goals and commercial reality. Nearly every office wants floor-to-floor glass. So this is, again, talking about spandrel zones and materials. So we've got to start making our spandrels more effective because they are a substantial part of the building. This is a little bit about the embodied carbon in materials, and I'm sure the other speaker will go into more detail. But if you have a look at the different materials here, there's one that says precast, okay? Precast concrete is one of the worst materials for carbon embodiment. Now, if you know there's a small country just to the north of here, Singapore, gone green, correct? We're going to go green by 2030. How do they build all their HDBs? In precast, in Malaysia, drive them over the border and install them. So again, are we going green or are we not going green? So everything's in precast concrete, built in another country, driven over the border. That's not exactly what I would call a green methodology, okay? So again, these things need to be looked at. What materials are we going to use? Masonry, I probably won't go through too much here because it's not overly used in Jakarta. But again, bricks are another one that need to be looked at more, probably for residential houses. So I'll skip masonry. Now, again, I mentioned design, the whole building life cycle. This is what this comes into. You need to look at, as you design, where you procure, how you build, how you service your building, and then how you demolish your building. Okay, eventually at some stage in theory, it will get pulled down. So this is the whole life cycle analysis. It's extremely important for understanding how to make correct decisions. Okay, shadow boxes, again, coming back to shadow boxes. I'm not anti-shadow box, by the way, but it's one area that really needs to fix up. The inside temperature of a shadow box in Jakarta or in Singapore and that gets up to about 100 degrees. So can you imagine you have your nice air conditioning on inside at 22, 23 degrees, and you have this shadow box outside that's generating 100 degrees. So these are the things we need to start looking at. So we're not transferring that heat into our air-conditioned spaces. Okay? And again, being smart about how we do things. And I know why contractors do this, and I sort of agree with it as well. But you put a curtain wall up, then you put some stud wall up, then you put the wall in. Or you put the curtain wall up, then you put the pelmet box in later. It's a duplication. So again, we need to get smarter. How are we going to build this thing so it's more efficient? Okay, not two trades coming in doing the same thing. Dark, there's a thing called solar absorption, which we all know. You wear dark clothes outside, it's hot. You wear white clothes outside, it's not so hot. It's exactly the same for buildings. But we are seeing more and more buildings in black in colour. Why are we building black colour buildings in the tropics? It's just going to absorb more heat. Okay, solar panels. I think someone will talk about solar panels later. They're another interesting thing. Everyone just says, put solar panels in, great, I'm being green, I'm sustainable. But you've got to do the life cycle analysis. So industrial buildings, brilliant, flat roof, you can put solar panels everywhere. But we've done some of the analysis in different cities around the world, and solar panels may not return your money for 20 years. Therefore, to me, it's not an effective thing. It's a nice promotion, it's a marketing thing, but it's not actually really sustainable design. Another one with construction and facades in particular, we bring the facades a lot from China, some locally produced. They come in containers, they have packing materials. We go to site, and then what happens? We give it to the Garanguni guy, and he recycles it. So we've got to start looking at that whole supply chain. Can those things be sent back and reused? All right, so that's just, I'll show you some of the green buildings that we have worked on. Just to give you an idea, it does exist. Unilever, just down the road here, is a great building. Unilever has some great features. For their town hall area, skylights. Skylights are great. They let in natural light. Okay, their sunshades were designed based on proper analysis. So all the sunshades are effective design widths. And then the architecture followed that. That's what we need to do. Timber's fashionable these days, particularly more in Western countries. So this is a job in Australia where timber design is good. This is a job, and you'll find a lot of these examples of green buildings are coming from countries that have been doing sustainability design longer than Asia, unfortunately. So again, in Melbourne, this is Monash, a university, and the sunshades are designed to maximise the light in during winter, but not in summer. So they've been designed primarily on a certain angle based on a sun glare analysis. This is a job with a dual skin, so it's a shopping centre. So it has a normal facade on the inside, and then they decided to put a skin on the outside architecturally. But being a shopping centre, of course, they don't want you looking out. It's all about keeping you in there. This is a job done by one of our sister companies in Paris. Again, timber design. Timber design is coming more and more. This is the university from the US, and they always make sure their buildings overseas are designed sustainably and with timber. This is some of the other things we do is, this might look like a park, it is a park, but we make sure that the park has the wind analysis done properly, there's no glare coming down, and people can use the buildings. This is, if anyone here has a super penthouse somewhere, I don't unfortunately, but we did an analysis for penthouses in China so that you can sit out on your balcony and enjoy the view without the wind. So this was analysis done because obviously if you're paying millions of dollars for your penthouse, you don't want the wind ripping through there. So they had to change some of the orientation and some of the screens in order to make it workable. Industrial, as I said, is big in sustainable design, and they have the perfect thing, big flat roof. Therefore, solar panels work. They're a business. It's all about money. So they will put the money in if they can justify it. Airports is another one again. As you see, airports are growing to become more and more sustainable. They have big glass areas. They have problems with glare in aeroplanes, but beyond that, they have to make sure that their airports are sustainable now. So this is in Cambodia. This is some of the analysis we can do. So architecture doesn't have to be limited by sustainable design. The blue there is water, and we've done an analysis, a very big flat canopy in Singapore, and we've done an analysis to make sure it drains out. So there's functional things behind sustainable design as well as normal things. This is the first passive house in the Southern Hemisphere. So again, the design's coming. It's the first, it won't be the last. So slowly we need to upgrade our buildings. Like the guy with his 70% aluminium recycled ended up with 30. It's the first step. We take the first step and then we get better at it. This one I just like to show people because it looks like something out of a James Bond movie. So this was a Sydney development. It was 20 overstories. The council did not approve the plans because it cast shadows on a playground beside it. And someone a lot smarter than me decided to put a heliostat on top of the building. So a heliostat takes the sun rays and points them down. So in winter, the heliostat works and it stops the building from casting a shadow. Okay, case studies, again, we need to look at buildings split up section by section so we understand and design to their abilities. That's it. So thank you very much.
Okay, please welcome our next speaker, Arun Madappallath, General Manager, South Asia of Search Ferrari Group. So from Facade Beyond Glass and Aluminium, he'll be sharing fabric as a facade solution.
Good morning, everyone. Really happy to be here. I'm coming from Delhi. General Manager myself, General Manager of Search Ferrari Group. I'm working with Search Ferrari since past 20 years, and this year is a very special year for Search Ferrari Group because we are celebrating our 50 years of existence in the manufacturing of flexible composite materials. I would also like to introduce my colleague who is in charge for Indonesia, Territory Manager for Indonesia, Mr. Galu. Okay, we have a booth and you can meet him in the booth as well. Yeah. Okay, so to start with, I will run a small video, a corporate video about Search Ferrari Group. Okay, so that's about our company. And yes, we are, our CSR approach, Search Ferrari Group has developed a recycling system called Polyloop, which recycles the membrane, the flexible composite membrane made of high-density polystyrene and PVC. It separates, and these separated products can be reused for other applications. Even we have also started introducing recycled fabric made of recycled items. We already started introducing for the blind system and for the sign application. Okay, so we are strategically present in 4 key markets. Solar protection, it's internal and external solar protection, can be used as a blinds or awnings or canopies. Then we are into modular structure, wide span structure for halls, warehouses, fabric solutions. Furniture and marine application, we also have the range of fabrics for that. And then the key market is tensile architecture, and Façade is part of the tensile architecture market. So today I'll be covering mainly on the tensile facade applications. So why fabric as a facade? As you can see, the fabric can be used as a secondary skin of a building. The advantages is that the outside, because of the 30% openness of the fabric, outside visibility will be really good. Thermal control, it blocks the heat outside, glare control, and natural light inflow. So World Green Building Council study states that if you have to work in an office building or stay in a building, natural light is really a must resources to save the energy. So the second step is unique identity for your building. So fabric can be used as, you can apply LED lightings to the fabric facade, and then you can also have 3-dimensional structures because it's a flexible composite material. You can create shapes using fabric facades. Then printing possibilities also there in fabric. So we can print and keep a unique design, or your company logo can be done in the fabric facade as a printing solution. Okay, so the other chapter is energy savings. So there are 2 possibilities of fabric can be used in the building industry. One is the roller blind screen, and then fabric as an external facade. The advantages of having the fabric as external facade is that 80% of the heat is cut outside the building. Okay, so only 20% is transferred through the glass to the building. So you will have more energy saving, and HVAC can be designed based on the data of the fabric with the glazing system, how much energy is coming inside. You can design your HVAC system based on that. So you can reduce a lot of cost in your air conditioning system or heating system when you are using fabric as an external facade. Okay, so we have some case studies also to confirm that. So this is South Bay Realty offices in US. Okay, initially the building was designed, as a glass facade and the fabric as a roller blind, but they were facing a lot of issues in terms of heat, and they are facing a lot of issues in terms of energy consumption for the air conditioning. Then we have come up with a solution as a tensile fabric facade as an external application. We have a very simple system, not a complicated system, simple system using aluminum profiles. We have designed the building. You can see that facade as a secondary skin for this building, and you can see that the energy savings for the whole 3 years they were able to recover the cost of the facade by putting as a facade, and their occupancy has increased. The electricity bill has come down drastically because of the secondary skin applied in this building. So this is a real case study which we have done. So before and after, you can see the difference in the building. The whole aesthetics of the building also changed. Okay. Then it's very important following of international fire standards. So in Search Ferrari Group, we have 2 types of membrane. One is high tenacity yarn coated with PVC and PVDF, and the second one is glass yarn coated with PTFE fabric. So both the fabrics complies all international standard. PVC fabric, it's a flame retardant material. The Euroclass rating is BS2D0. B stands for burning. S2 is smoke index, medium smoke index. And D0 is no drops. So if there is a fire, definitely it will catch the fire. It's a self-extinguishing material. The fire will stop by itself and no drops and no harm to the people in the building. So that is PVC. Glass fiber PTFE is a fire-resistant material up to 450 degrees. It's a non-combustible material because the glass yarn is non-combustible and PTFE coating. So it's BS1D0. Smoke index is low in PTFE materials. So these two fabrics we have and both meet international, all international standards of fire properties. Okay, then, so fabric versus solid material, conventional material. As you can see, when you're using fabric as an external facade, your outside visibility is good. You can see clearly comparing to the conventional materials and the noise reduction properties also there with facade fabric mesh materials. Okay, so different possibility of constructions possible with fabric facade, cassette panel construction, three-dimensional structures, monolithic structures. This is Airbus restaurant in France. As you can see, the outside visibility is really good, and at the same time, natural light coming inside. And this saves a lot of energy during the working time, morning time. And this is another example of a plain membrane. It's a PTFE membrane, Burj Al Arab. As you can see, the facade of this building is made of flexible composite material, glass fiber PTFE. It's constructed more than 25 years ago, and it has passed through a lot of harsh climatic conditions, and it still exists in a perfect condition. As you know, in Middle East there are a lot of sandstorms, etc. But still the fabric is perfect, and after 25 years. So this is exceptional longevity of the membrane. This shows exceptional longevity of the membrane. Okay, and this is monolithic construction, Germany. This was Expo, Shanghai Expo. We have done this project, and this fabric, after the exhibition, it was recycled completely and used for some other secondary materials. Retrofit possibility and renovation. As you can see, the complete dynamics or the aesthetics of the building is completely changing before and after construction fabric as a facade. So you can see the beauty of the building after the renovation part. Some crazy designs also possible with the flexible membrane. This is a stadium completely wrapped with fabric. We have 4 types of fabrics. One is 100% breathable mesh, which has got a range of 14% to 50% openness factor. Depending on the project, you can decide what openness you need for your projects. This is the standard material used as a secondary membrane. And opaque waterproof material can be used as a primary facade itself, because it's a plain fabric. You don't need any window for that. You can completely wrap the building with this fabric. It's opaque waterproof. Then we also have highly translucent material. If you want more light to come inside, plain membrane, light transmission, up to 41% light transmission possible, 55% light transmission possible with high translucent waterproof material. Yeah, it's transparent single skin, which is STFE, a real innovation from Search Ferrari Group. Okay, it's made of polyurethane yarn coated with fluoropolymer. The advantage of this fabric is that UV passes through this fabric, and you can use it for green construction, greenery, aviary, etc. And more than 55% of light transmission possibility with this fabric. And it acts as a glass. If you construct it above 7 meter high, it looks like a clear glass material. So we have innovation at its best. We have many applications possible and low maintenance and cleaning, design support from Search Ferrari Group. And these are few ranges of the fabric mesh we have in our kitty. Versadag range is completely glass fiber PTFE material, and Search Ferrari is high tenacity polyester based material. Okay, and design support. Search Ferrari Group is now offering a design engineering support whenever a client or architect or consultant have a project. We have a software and we do the design of the building and give to support our customers as well as architects by rendering, offering GS drawings and the construction details, etc. This is an interesting product, FTI system. We are associated with FTI system, and they provide the complete aluminum solution together with our fabric membrane. So we can have a big panel, up to 60 square meter possibilities there with a single panel system. And it's available, it's actually made in, it's a UK-based company, but we are working together with them. But not only FTI, we can also use some other conventional material for the fixing of facade with fabric. EPD, product declaration, certificate, green card certificates, REACH, LEED building certificates. So all certification is available with Search Ferrari Group. And a few of the projects, key projects, hotel projects done across globe using facade membrane. This is office building. As you can see, different flexible solution possible with membrane. Completely building is wrapped, a glass building is wrapped with fabric possibilities. Multi-story car parks, culture centers, education, and I would like to show a few of the projects what you have done in Indonesia as well after this. Stadium, we have done 5 stadiums in Al Bayt FIFA World Cup 2022. Possibility of multi-story car parks. Then this is Gbk Stadium in Indonesia. We have made sail-shaped structures. Then we have Kerta Jati Airport, again sail-shaped mesh fabric. Then we have done office facade in Jakarta. You can see, you can create a unique shape for the buildings. This is also another project, an office facade, an art gallery facade, printed one. Art gallery facade in, again, Jakarta. Yeah, and we are represented, we are present worldwide. Search Ferrari Group, subsidiaries, representative offices, distribution system, factories in Europe and in Taiwan. And we almost everywhere, almost all the country, we have the sales representative offices as well. Yeah. Okay, so that's all. Thank you very much. Hope it's interesting. Please visit our booth, and thank you, Zak organization, for this meeting. Thank you. Bye-bye. Thank you.
All right, we have one more speaker before we go off on our networking tea break. Please join me to welcome Mathieu Penrose, the Executive Vice President of Vector Volytech. Big round of applause, please.
Thank you. Selamat pagi. Good morning. So I'm going to talk to you about ETFE. ETFE is the lightweight alternative to performance glazing systems. So what is ETFE? ETFE, ethylene tetrafluoroethylene, is a fluoropolymer. It's not a plastic derived from petrochemicals. Fluoropolymers do not have problems with sustainability, UV, longevity, or fire. So ETFE has been around a long time, developed 80 years ago by DuPont, used in multiple industries. And 40 years ago, our founders took ETFE to the construction industry. Now, an ETFE system consists of 2 or 3 layers of ETFE welded at the perimeter and filled with normal air. That air gives shape, strength, very high thermal performance, and of course, very lightweight. Now, looking at the underside here, you can see that ETFE cushion is fixed into an aluminium perimeter frame, very similar to if you had double glazing fixing into a mullion. Now, the only difference is a small pipe in the corner. Now, this view from above, you can see the aluminium perimeter frame is fixed to steel cleats, which are welded to the structure, and that gives it its structural stability and connection with the building. Yes, ETFE is lightweight, but it's airtight, watertight, allows for large thermal movement, plus it has a secondary drainage channel.
Never done this. It isn't part of the standard
now,
building.
ETFE is very strong. This is a video from over 23 years ago.
Quite a lot of money, probably £6,000–7,000.
And you can see that the ETFE can sit, the car sitting on the cushion. And ETFE can bear 4 times its own load. Now, selected track record, probably our most famous project in Asia, constructed for the 2008 Beijing Olympics, is the Beijing Water Cube. Currently the largest ETFE structure in the world, 100,000 square meters of ETFE, each cushion averaging 7 meters. Now, what a lot of people don't know, it's double skinned. You have the ETFE as the building envelope, protecting from the harsh, polluted environment of Beijing, but you also have the ETFE acting as a ceiling and an interior skin protecting the building from the harsh chlorine environment from the swimming pools. Now, the largest building in the world in ETFE is under construction now, King Abdullah's International Gardens in Saudi Arabia. It's about 120,000 square meters in one of the harshest conditions in the world. This is a photo from site, and it's so hard to give you a scale, but those little dots at the bottom are excavators and lorries. We literally go around the site on motorbikes. Now, Hudson Yards was the biggest private real estate development in US history, and the vessel and the shed are probably some of the most trending buildings at that time. The party trick of the shed is it's a movable shell that doubles the footprint of the exhibition space. And it's the lightweight nature of the ETFE plus its allowable flexibility that makes this happen. We don't just work with engineers and architects, we work with people like Disney Imagineering. This 6,000 square meter canopy at Shanghai Disney, what else could do it? What could be lightweight, large span, waterproof, have a daytime identity, and at nighttime come to life? What else could do this? Now, what's nice about the ETFE, during the day, it's going to protect you from the sun using prints. Those same prints become projection screens at night. Simple lighting makes the building glow. So have we done projects here? Our oldest building is Trans Studio Mall in Bandung. I think this is at least over 10 years old. It's a beautiful canopy designed by DP, and it's a sort of drop-off canopy, but also it's quite a light print, so the people sitting in the balconies in the restaurants can have a good connection with the sky. We also did skylights at Q Big, and a project I want to talk a little bit more about is Rasinda Park Mall. It's developed by the neighboring Grand Mall Indonesia group, and it's 6 20 by 20 meter tree canopies lined up in a row. It's quite hard to see, so I thought I'd show you this. It's the first high-end mall in Karawan City to have sort of international luxury brands. Now, we worked heavily with the local steel fabricator. We gave them 3D models. We gave them all the set out. We went to their factory, checked their tolerances, and set out. And the ETFE is delivered to site fully prefabricated. Everything's made and shipped, even the extrusions are cut to length and pre-welded. Now, when you have a very steep angle, scaffolding's useless, boom lifts are useless. We have our safety net system. And what that safety net system allows us is to work very safely at high level, but at the same time, everyone can work below us in safety, and so you can have very fast construction. Now, once the steel is fully painted, our ETFE system's installed, and then the extrusions are installed. And even our extrusions have waterproof expandable joints. And then the prefabricated ETFE cushions were installed and inflated. Now let's talk about different sectors of the construction industry. We do a lot of work now in facades. This is a 15-story showroom in Singapore wrapped in ETFE. And of course, we have amazing sculptural roof-cum facades across London. We do exhibition centers, giving you that nighttime identity, a daytime identity. And we also can do accents in large buildings to make them come alive and give shards of light, like here at the Pavilion in Birmingham. Or you can wrap the whole building in ETFE. And of course, this again gives you that daytime and nighttime identity. We do a lot of work in high wind load areas. So Hong Kong, Macau, Philippines, Taiwan, etc. And we also do a lot of design and build of the steelworks. In this case, we were also doing all of the, helping to do all the wind models to get the most efficient structure possible. And even though the loading on that roof is 500 kilograms per square meter, we could do 40-meter spans, no trusses. Moving on, we do a lot of airports. And again, Cebu Mactan was the winner of the World Architectural Festival airport. It's also, again, exposed to extremely high wind load and seismic activity. But the 3,500 square meter drop-off canopy still had 3-meter wide by 20-meter long cushions. The famous Jewel at Changi connecting all 3 terminals. Right at the center is the world's largest indoor water fountain. And in the middle is a 12-meter diameter ETFE cushion, making that beautiful shard of light. Even the drop-off canopy at Jewel between Terminal 1 and Jewel, all ETFE. We do a lot of campuses. Now, this is very interesting. This is the new headquarters of Sabana Jurong, designed by Safdie. There's no steel structure. It's a cable truss, really pushing the next level. So you've got 20 mil diameter cables forming a truss, and the ETFE is secured to the top. And it's the lightweight nature and flexibility of the ETFE that makes that possible. We do stadiums all over the world. This is in Dunedin. This is the first stadium to be fully enclosed, but still allow natural grass to grow. We also, of course, did Singapore National Stadium. This is the world's longest span dome, 310 meters. We have a 20,000 square meter roof that can open in 20 minutes, integrated with 20,000 LEDs to become Singapore's largest flag. We also do a lot of retrofits. So this is a famous stadium, the largest in the Netherlands. And we've done a retrofit. We've changed the facade from concave to convex, kept the stadium open, minimal structural reinforcement, and added 2,500 square meter facade that gives a viewing platform over the city. We do a lot of public spaces, a lot of skylights, areas where public are going to want natural light. And of course, the $5 billion resorts world is covered with almost 30,000 square meters of ETFE. And it's there to allow people to walk around fully protected from the sun. And even the Universal Studios had themed ETFE. Do a lot of education buildings. This is the largest preschool in the world. 2,100 pupils go here. And all the play areas protected by ETFE. And it can blank out all of the UVA, UVB that is harmful to children. And transportation, this was the USA Public Building of the Year. Combines 8 different types of private and public transportation, but it's the first lead transportation station in the world, and the ETFE was a big component of that. And again, you're seeing in the day, the ETFE is protecting you from the sun, and at night, the building becomes transparent and a beacon of light. Probably shopping malls is one of our biggest markets. This is in Kuwait, probably the harshest conditions in the world for sun and sandstorms. And you have 117,000 square meters of ETFE protecting everyone inside. And last one on malls is the pavilions, a 7,000 square meter outdoor event space for everything a shopping mall could want to do, from car launches to fashion events to brand openings. Now, how does it work? We have that little box there, inflates everything in the picture. The inflation unit uses the same power as 2 light bulbs, about 250 watts. It's fault tolerant, it's very German. If anything goes wrong, there's a backup system. It's quiet, it's waterproof, and it's probably only on 20 to 30% of the time. ETFE is naturally transparent. We use prints to give thermal control, and our prints are quite unique. This is the same skylight from above and below. Above, the prints are reflecting the heat and giving shade, and on the underside, you still have the connection with the sky. Different intensity and geometry of prints allow us to have all of the thermal data architects and facade engineers would need to design their space. And we can change the number of layers of ETFE. So 2 layers is typically the same as double glazing. 3 layers the same as triple glazing for U value, but 95% less weight. You can color the ETFE, and that's one of our first projects on the left. That's 40 years old now. We've took samples. There's no mechanical or chemical change in 40 years. So 100-year lifespan expected. The surface is non-porous and will self-clean under the action of rain. And in fire, fluoropolymers are fantastic. They create smoke vents. The ETFE will move away from the fire, self-extinguish, no smoke, no drips. You can look up 40 years, 0 problems of ETFE and fire. And we have all of the certificates, and one of the hardest things to get onto is the Singapore product listing scheme. Again, we're certified for roofs and facades. Finally, this is the most sustainable and recyclable material of all transparent materials used in building envelopes. We have all the certificates to back it up. Now, quick case study for you, the shed. So the shed in Hudson Vessel was one of the most trending projects since its opening back in 2018. The shed is a 16,000 square meter visual arts and performing arts center. The wraparound shell is an exposed diagrid shell weighing about 3,000 tons, covered with 4,000 square meters of ETFE. The shell can close within 5 minutes, and it can even do large-scale performances up to 500 people. So the shell retracts on 8 bogies, about 1.8 meters high, and they only use 6 15-horsepower motors. There's 146 cladding panels on the ETFE. They're about 21 meters long, that's the length of this hall here. And they're installed and not on scaffolding. We have our safety net systems on the roof and boom lifts on the side. And the ETFE even turns 90 degrees. Facade becomes roof. That's it. Thank you very much.
Okay, so we're now going off on our networking tea break. I do encourage everyone to visit the booth and approach our morning speakers for any questions. Welcome back, everyone. I would like to welcome our next speaker, Pak Timothy Soebroto, Regional Director of Meur Facade Technology. This morning, he will share about environmentally conscious building facade. Please join me on stage, Pak Timothy.
Good morning, everyone. Selamat pagi and salam sejahtera. Firstly, I would like to thank the organizer, Zak World of Façades, especially Ahmed, for inviting me to speak in this conference. Allowing me to introduce myself, my name is Timothy. I'm from Meur Facade Technology, where I have been with for the last 17 years. Meur Facade is part of Meur Group, and this is some of our portfolio, mainly in high-rise building. But we not only do high-rise building, we do a lot of low-rise as well. This is our portfolio. We did, as I did mention, high-rise, but we also did a concert hall, airport, resort world, and this our project in Jakarta. Quite a number of projects in Jakarta. Recently, we are involved in IT, Bank Mandiri IT in Sleepy. This one in below. We also have done some project like airport, IKN, and many more. So, yeah, since couple months ago, actually we experienced heat wave. This one is in Europe. In Spain, the heat reached 45 degrees Celsius. Independent reported that in UK endured its hottest June since report began in 1884. And this one is happened 3rd July, which is 2 months back. So this one is become very commonly seen in Europe. People try to cool down themselves in the public water feature. How about in Southeast Asia? Last year, actually, the Straits Times reported that Singapore can expect frequent heat wave in coming years, also in KL. And this one is recently come. Happened same again. In Singapore, on May 13, reached 37 degrees Celsius, which is never happened before. How about Indonesia? Di Indonesia, there are 7 areas yang reach very extreme, panas sekali. So you can see in this news, itu retak-retak. That's what happened recently. Climate change influenced July heat wave in Europe, China, American, and so on. As the heat going up and up, the energy consumption to maintain the comfort level also become very high. This is as a report, energy used for the building contribute 36% from total energy, while the emission result is 37 degrees, which is much more than the transport and other industry. So, according to the World Economic Forum, the reducing carbon output from building and construction is important, so we can prevent the global warming. And as a facade people, what we can do. So this morning, we would like to explore the environmentally conscious building facade. Have you seen this movie? Last year, I watched this movie with my daughter, actually. Doctor Strange is Multiverse of Madness. And in this movie, we can see this episode where the building is fully covered or partially covered with a landscape. This is when Doctor Strange went to multiverse world. So in my imagination, in the multiverse world, most of the building will be covered by the landscape, which is very, very good. And this one also commonly happen few years back, 10 years, starting 10 years. and now become more and more popular. So the first thing that we would like to discuss is the enhancements of the facade landscape. This is one of the most famous building in Europe, and according to the World Green Building Council called Bosco Verticale, one of the most recognizable building of the last decade. Also, they call the architect Stefano Bori is one of the most famous name in green architecture. And another famous building in Europe, Düsseldorf, Germany, designed by Inghofen architect, is the largest building with the landscape, covering with landscape in Europe. In Asia, especially in Singapore, landscape on the facade become and more popular as well. This is one of the example when we involved in this building, the Eden Residence. This building was designed by Thomas Hedderwick Studio, owned by Swire Property. They have bespoke hanging garden, something like this, and become very prominent in the city of Singapore. And they have equipped the very large sliding door or folding door, so we can enjoy the outdoor view from the internal side of the building. How about the Indonesia? Unfortunately, in Indonesia, we don't have yet building with extensive green roof or facade landscape. But I was informed that there will be one project coming with the facade landscape, which is very big, very prominent, very in the city of Jalan Tamrin. Probably we will shoot with. Integrating the landscape to the facade is just simply putting the building wall partially or completely covered by the landscape. The benefit will be absorb carbon dioxide, minimize urban heat island impact, which is currently become a point from IAI Jakarta, provide natural cooling, reduce energy consumption, help to clean the air, and the last and not least is host a variety of plant and animal if we have very extensive green roof. But nevertheless, there are few considerations that if we want to study or if we want to implement facade with a lot of landscape, we need to consider structural integrity. Landscape is not light, it's heavy. That's why the weight have to be considered carefully by structural engineer. Irrigation and drainage certainly, maintenance, because plant need to be maintained. So the BMU should cover, the BMU is building maintenance unit system have to cover how to maintain this landscape. Safety, we don't want to have a plant or branch drop from certain level to the pedestrian level, right? And the last not least is facade material. We have to be carefully consider the facade material. We have to find the facade material with easily maintained characteristic. And the facade have to be durable as well. Second advancement is the advancement of BIPV facade. This is the largest solar thermal collection in Southeast Asia, located in Waduk Cirata. And this is a good example for having solar energy, which have a huge and long-term benefit. The benefit will be increased country energy security, enhance sustainability, reduce pollution, and lower the cost of mitigation of the global warming. Traditionally, the solar thermal collector was installed on the roof. But for the high-rise building, there is a limited because we only have a small area of the roof area. And in addition, normally on the roof of high-rise building, will be fully occupied by MNE, BMU, and so on. As the amount of the solar thermal collector is small, the energy also become very small as well. But the current approach they put the BIPV not only on the roof, but also on the skylight, cover walkway, canopy, including the facade. This could be one good example, which is, I like this building very much. In Korea, they put BIPV on the spandrel level. And by doing this one, actually, they not only putting a BIPV, but also reducing the daylight. You can see this one, the vision was angle 15 degree towards the ground, so minimizing the direct daylight, while the spandrel angle 30 degree towards the sun, maximizing the thermal collector on the spandrel. Unique exterior, this one, maximize access to the view, energy efficient strategy, and energy generation technology. The result is a unique folded exterior texture that is both purposeful and visually distinctive. Another thing, this building also having expansive rooftop, so will be maximize the thermal collection as well. Another example of this one, this building, RMIT Design Hub, demonstrate how the architect creativity is important. BIPV, who's normally is not really very attractive, they use something like a disc and they integrate it with BIPV. Another example also, this building is named Hikari in Lyon, France, designed by Kengo Kuma architect. In here, the BIPV pattern is used something similar to the glass pattern or fritted pattern. So in here, we'll study that the architect creativity is important to integrate BIPV on the facade. Recently, or currently, we are involved in this project named Sinarmas Tower. The client is Sinarmas Mining, designed by Anggara Architect team. In here, the client have intention to have BIPV on the facade, and they really want to spend the money for this project. The BIPV only installed on the facade because the footprint is very small and there is no way to install the BIPV on the rooftop because the rooftop is very condensed. There is helipad, BMU, M&E equipment, and so on. So we managed to find the BIPV can be installed on the crown area, which is not hindrance to the vision, and also on the spandrel area from level 3 to level 25. The first thing that we study is where we put the BIPV panel. We managed to find 6,800 square meter BIPV. The second, we conduct the shadows analysis in order to understand the impact of the efficacy of the BIPV. This project, unfortunately, located surrounded by giant project. If you see the two tower is 50 towers, the red one is Sinarmas Tower, actually only 25. The next one is double than Sinarmas Tower. The third study that we did is irradiance analysis. In here, we will understand the applicability of BIPV panel. Power generation analysis for each area. In here is we study for the spandrel from level 3 to level 24. This for the crown area. And the last, we have to understand the financial issue to ensure this one is feasible enough or not. So Sinarmas Tower, based on the study, the total power contribute approximately 750 to 800 kilowatts pascal. The reducing carbon dioxide emission by 300 tons per year, equivalent to plant 17,000 trees, and reducing so many SO2 by 75 kilogram per year and so on. Traditionally, we always have in mind that the photovoltaic has affected the aesthetic of building negatively, something like this. The pattern is not really very nice, a bit ugly, but thanks to the major research, the industry made a huge process. The integration quality improved a lot as well. So for the project that we are doing now, Sinarmas Tower, this is more or less the BIPV. The below one is the stop ray 40T, is the fission glass, while the top one is BIPV panel. We can see the color for fission and spandrel with BIPV is quite close. Another technology, the BIPV can be something like this with a lot of pattern, batik, and so on, and with a lot of color, can be utilized or used as a building signage. This is another example in building in Netherlands, Shell. They use BIPV on top. There are 8 glass panel, actually signage of the building. And here they use this concept. This building is finished 2019. How about in Asia? This project just completed in Malaysia, probably 2 months back in University Kuala Lumpur. This one considered net zero energy building. In here, BIPV was installed on top of the roof or skylight, and also installed in this signage and on that wall. Also, these 2 wall actually is BIPV. We never imagined that BIPV and can be as good as this one. This kind of material have been going and are very common in Southeast Asia. You mean rattan, woven, and they have a different level now. It's produced very nice on the right side. Then the next one, also by Dior, costs 6,000 Sing dollar or USD, probably something like that. This handicraft start very humbly, but now become very nice product used for interior. If you can see this one is the Toyota Astra showroom in Menara Astra. Also now expanded globally like this one. And this one is Bloomberg office in Middle East. So the next one that we would like to discuss is woven material for the facade. And this one is produced by some Indonesian company initially, now produced also globally in China, but the pioneer is Indonesian actually. And this material is commonly start to be used in facade as a sun shading. This is one of the housing, and they use this material as a sun shading. Another example is this project was designed by my friend actually. They use this one as a sun shading. And according to the client is very happy with the performance of this one because this building is provide the shading, and behind is also feel very cooling as well. This is another thing that this probably the first commercial project using this material. 4 5-story ruko, shop houses using this one. And for me, this material is very unique, very nice, cultural, traditional. But from the internal side, you can see on the right side, this is very nice. And this material start to be explored for the high-rise building. One in our project in the Middle East, in Red Sea, designed by Norman Foster, also use this kind of product. But before we use, there are several things need to be considered carefully. One is the structural integrity. If we want to use this building for the high-rise, we need to consider the wind load, because if we have a high-rise, wind load is important, and any other load. Second is installation detail. The third one maintenance, how to maintain this material. The last is fire safety issue. Currently, we are working with them to support them in terms of installation detail and for this product. The next one is recycle facade material. One of the extreme example is this building. The building located in Czech Republic. The owner is furniture factory that use unused chair as a sun shading, which is something that really out of the box, which is one of the good example where we can use recycled material to the building. When I was in Bali, I came here and in the Potato Hut designed by Oma. I think Ahad also here 2 months ago or last month. And the one that really impressed me is this one actually. This they use some material as sun shading. And after some research, I studied that actually this one is woven material from garbage. Certain area they use a blue from aqua. On the other one, the green one, they use Sprite. But this one could be very good example how we use the garbage to the new facade material. However, for the massive product, for this material, we need to have deeper R&D. Thank you very much.
Thank you, Tim, for the very insightful presentation. Next, I would like to welcome Yosuke Takahashi, Principal of Mitsubishi Jizo Design. This morning, he'll be sharing with us beyond design aesthetics, the building facade design approach through international projects. Please join me with a big round of applause.
Good morning, everyone. Selamat pagi. Nama saya Takahashi. Saya architect Mitsubishi Jizo Design. So my bahasa is just 3 words. So, so today I would like to introduce our building facade design. So at first, I'm talking about our background. And Mitsubishi Jizo Design, it means Mitsubishi Estate Architectural Design Firm. So we have the architectural experience for more than 130 years in Japan. And in addition, just a moment. Storage. In addition, we have the expanding our business to the Eastern Asia in this decade, from based in Tokyo, Shanghai, and Singapore. So in the process, we have felt different in background in each country. Our career as a design architect and start from the Marunouchi building in 2002 in Tokyo and Mitsubishi Trust Banking headquarters in also Marunouchi and onward building in Sendai and Tokyo Toyosu Front building. And for the overseas project, I have participated in the Ant Finance headquarters and the Chongqing Foodie building And here in Jakarta, the Trinity Tower. And today I would like to share with you what I have learned through my experiences. Facade. Facade originates from the French in its mean front. The impression of the facade changes with the materials and the shape and the exterior cladding. And also the facade impression changes with the sunlight. So as a result, facade is a representation of the impression and the present performances. Sunlight reflects the impression, it's like the impression out. For example, in the headquarters of the United Nations, designed by Corbusier, and it's not the lapping on the building form. He set the base tone with the color of the grass and by adding the black spandrels. So to create the horizontal expression facade in the here. In Seaground building, and designed by Miss van der Rohe, and the I-beam made by bronze on the facade gives the building the striking appearance, and they also reflect the intensity of the sunlight, changing to the expression. So traditionally, Japanese architecture has the beauty of the roof shapes. Japanese architecture is expression in the strong horizontals, and the depth of the eaves line reflects the intensity of the shadows cast by the sunlight. And the impression changes with the time of the day and the season. Furthermore, the shape of creates the depth eaves line and have the effect the environmental performances. Shadow of the eaves control the sunlight and the temperature of the by air windows. The shape of the Japanese architecture and the eaves, it's called the Engawa, and it's a Japanese brand, and especially effective to create a cooler environment on the sunlight and the summer times. And also the contemporary architecture, the eaves are attached to the facade at the variety of expression and through the size and the intensity of the shading. And at the same time, the shadow helps to reduce the environmental impact of the interior perimeter zone. So the Marunouchi building aimed to the 100 years architecture, which lasts for the long times. By attaching the vertical ribs and the eaves on every 2 levels on exterior, we realize the facade with a variety expression and will be never grow old. The PC panel, which is 2 floors, as a 1 unit, are bent outside of the corners from vertical ribs in order to maintain panel strength. And here is a Mitsubishi Trust Banking headquarters. It also consists by the 3.9 meter wide and 4.5 height aluminum unitized curtain wall. In addition to the 300 mm depth vertical ribs, which also served as a gondola lift, and the 500-meter depth eaves were designed to give the building a variety appearances. The spandrel section, which is 1,500, it's a little high. So it's a single sheet of the glass, it would be like expression. So I founded it Lake Shared Drive apartment designed by Miss Manderoy. It's a spandrel. It has the one transom, and so it makes functional senses, no functional senses. So we adding the one spandrel panel transom here. And here is a night view, is the right side. So in onward design building in Sendai, we create also deep eaves on the facade. Facade consists of the double skin curtain wall and inside is a sash, aluminum sash. It's allowing outside air in the heat of the air out. Also here is Ultimate Financial Center. It's called the Grand Cube. It also have the double skin curtain wall. The building also have the double skin, and which allows the heat air to be released to the outside. Each span of the building has a window to let in the outside air. In order to outside air into the interior, it's necessary to create a path for air to pass through. Because the office area is a Grand Cube is very deep, it's 20 meters. So we have designed the atrium around the core, and with openings that exhaust air from the rooftop. That we call it echo void. So columns of the outer perimeter are located within the double skin. So by doing so, we are able to create a flexible pillar and free open office spaces. And here is a Trinity Tower. Our position is the design architect and collaborate with the Shimizu Corporation. And here, this building in the building height is 247 meters. It's not the tallest building in Jakarta, but we aim to express the symbolic presence that is not depending on the building height. So tower is designed with a simple form consisting of glass facade with aluminum fin. And we believe that this tower will have the strong statement and become the iconic presence in Jakarta. Trinity Tower is aimed use project consists from the office tower and the annex of retail and the car parks. Office tower is positioned at 45-degree angle to the street. Create the specialist on the site and emphasize the symbolic presence of the tower. The typical floor size in the set to the 45 by 45 meter and the square corner and used for the emphasize the homogeneous office spaces in the all four sides. And this is the exterior view of the outdoor spaces. Tower is located 45 degrees, resulting in generous spaces relative to the site boundaries. This is from the view from the looking down to the entrance areas. And here is the annex. And here is the entrance hall, entrance lobby, and the ground floor. It has the metal panel. It's designed by the batik pattern and installed on the wall to create a richer environment. And for the design process, firstly, we aim to the timeless design and decide to create a simple overhaul shape. And secondly, we consider the compatibility of the functionality and the design. And at last, we decide to locate it the tower design the 45 degrees to create the space around the tower. After the several schemes with different concepts was present to the client, we choose the facade design concept of the tranquility. Tranquility is translated to the beauty design of the calmness and the peace. By the cutting off the four corners, it gives the effect of each facade to become an independent floating plane. Here's a detail in facade systems. The fins consist of the different widths. The dedicated combination of the different fins will show various impressions from the different angles. Wow. We realize a timeless design with the simple shapes. Here is a mock-up, and we designed the glass colors. Next, I would like to introduce the MAI project in Hangzhou in China. And it's Ant Finance headquarters in Hangzhou. 11 buildings are located on the site with a 20-meter elevation difference from the front load. And here is the entrance area. For the front load, we designed a view corridor through the piloted spaces to the courtyard to the far end of the site. For the office spaces, it's facing the surrounding tea plantation. We provided active terrace spaces to provide the outside workplaces. And each building is connected by the sky deck. And the facade design and the concept is based on the image of the terrace rice field in a rich nature environment. So facade design consists with the horizontal row of the window and the aluminum panels. This depth is like eaves, also creates a various expression and helps control the sunlight. And aluminum panels are randomly embossed with the image of the cloud and add the tone to the facade to the less susceptible to the stain. And the white color of the panel, which is inspired by the cloud, it's a slightly little grayish white color. That is white, but does it not show stain? And this is a view from the building from the tea plantation. And here is the Chongqing project. It's a 200 height building. It's a face to the bridge in over the river. And next to the temple, historical temple, it's a face in the crystal historical temples. So lastly, I introduce our Shanghai project. It's called the Longqiao Center. Its developer is a Chinese-Indonesian company. So it has the historical building in the center of the site. And in the front road, it has the pavilion and the open spaces. In the back of the historical building, we designed the 3 towers and the 4 independent annexes. So it's a movie of this project. Pavilion is designed by the Nishizawa Ryue and Sana. Thank you. Terima kasih.
Joining us next is Mathieu Meur, Director of DP Facade. He'll be touching on a very interesting topic, enhancing existing assets through facade upgrades or recladding.
Good afternoon, everyone. Last one before lunch. I'll do that quickly for you. We're all talking about sustainable buildings today, which is quite interesting because if you are standing in the front row, you're probably as frozen as I am. And I think we should shoot that mechanical engineer who designed that. But anyway, today what I want to do is talk about recladding and upgrading of building facades as an alternative to demolishing the buildings. And that's a way of improving the value of the building and improving the performance of the building. If you look at the value of or the cost of your building assets over time, you will see that it starts with the original construction cost, it ramps up slowly, you spend on maintenance as you go. Interestingly, we see something outside this building today we rarely see. People are actually washing the facade. It's rare. So I wanted to congratulate the owners for doing that, because that helps increase the lifespan of the facade as well. Typically, people ask, how long is the facade going to last? We say around 30 years with proper maintenance. And the previous speaker actually interestingly mentioned they designed their facade for 100 years even, which is very, very impressive. But the caveat is always with maintenance. And this is why that line is rising. And when you reach the end of the lifespan, the end of the usable lifespan, there's a big spike, the building gets demolished. But if you just change the facade, you keep the bones, you keep the structure, the slab. Actually, you save an enormous amount of cost, but you can transform your building completely. And that's what I will share with some case studies in a short while. And since we're talking about sustainability and all that, actually the cost in terms of carbon, life cycle carbon that's consumed by the building actually follows a very similar curve. So it's not the case that you need to spend more money to be more sustainable. In some cases, you can actually spend less money and still be much more sustainable. And this is one way you can do this, by just recladding instead of demolishing, because most of the embodied carbon in a building actually comes from the structure, as much as 80%. The facade is actually a tiny, tiny part of all that. So just changing the facade improves a lot also the performance of the building. This is one quick example. This is a building that's in Singapore called Republic Plaza. It's a very prominent, very centrally located building. This is how it looks. It was completed about maybe 15 or 20 years ago now, 20 years ago probably, early 2000s. Very classical looking building, but at ground level, not very engaging. So people are not drawn to the building. They don't want to go inside. And consequently, inside the building, the podium, you can see here, you don't want to get into that building. You know, it's the cafes, the restaurants, all the activities at the ground floor is not engaging with the public. So the idea was, I don't want to change the whole facade. I just want to change what's important for me, which is, in this case, the podium area. And so we changed it to this glass box, very light, very engaging, a lot of view towards the inside. It's no longer this black box that people don't want to get into. When you see from the inside, it's a lot of light coming through as well. And that draws the public. So what it means is that the revenue for the cafe, for the restaurant is also getting higher. And as a landlord, the owner can actually get more revenue. So they spend a little bit more on the facade, but they increase the value of the building and also can command higher rental. So that's a very, very good outcome for them. And this is the final building. We managed to blend in the new and the old quite nicely. It doesn't look like it's two different buildings, and this is always what we want to achieve when we do these kind of things. Another example, you will see some similarities. So this is not far from the other building, and the design dates from the 80s, around 1984. You can see both of them have a lot of stone, very classic materials. but again, a little bit heavy, a little bit not so nice looking at ground level. And they wanted to have, again, better appearance, better performance. The original facade looks like this. So it looks like the podium is all like a big lump of rock. Very heavy, not so engaging. And what we wanted to do is to change it to something lighter to make people want to get into the building. And we created a connectivity through the building as well, which allows, so it's no longer walled, it's actually open. It creates a path through the building, and all the shops, all the restaurants, all the cafe actually get a lot more passage and a lot more customers. So this is the facade after the renovation, after the recladding. And again, the whole tower was not touched, only the podium. So minimal expense, but very big visual impact, very striking. When you're when you're walking in the street at ground level, you rarely do this to look at what's happening on top. You tend to see what's at your eye level. And in places like Jakarta or big city centers where all the buildings are actually quite close to each other, that's what you're going to see. And the outcome is quite good. You can see this is the other side. One side is street side, one side is river side, and you have a pathway in between. And this actually created a double skin facade, a little bit like what was presented in the previous presentation. And so the thermal performance of the facade was also improved a lot. Energy consumption, at least for the podium, was also improved tremendously. Night view, very nice, very clean, very minimal structure. This is highly, highly optimized. So we see like a glass sheet that is folded, like origami. We don't see so much the structure itself. And this is the passage in between from street to river. The ceiling is actually flat. It looks folded as well, but we have height constraint. So we use quite an innovative technique, a special kind of, let's call it half perforations in the material to make it look and reflect light differently, make it look like it's folded. But this is completely flat, very interesting design. Another example, even more striking transformation is International Building. And for this building, this is how it looked before. This was built in 1970s. It's on Orchard Road, so very, very central, like Jayrold Bautista here, very central, very prominent building, but you can see very old. Why does it look very old? 40 years, never cleaned, not one time. So it looks terrible. The dirt, the dust is encrusted in the facade. It's very difficult to remove. You cannot just go with soap and squeegee to remove it. It will not go. And also a little bit dated, okay? So what was done here is we wanted to first, again, engage the street level by changing the bottom facade and clean and renovate the upper facade. So what was done for this building is basically, and you can see the entrance is also quite old looking, this is very old design. So what we've done is as I mentioned, we've changed the face of that building, just the podium, by creating deep volumes to create some interesting perspectives in the facade, and to give it a more modern, more interesting appearance at ground level. Big canopy, very light looking, a lot clearer and nicer compared to what it was before. So different views to show you how that building went from very old and dirty looking to new. And the upper part, which is maybe a little bit hard to see, was cleaned and renovated using a very special technique and very special technology. And this is now protected and can last for a very long time. So the whole upper facade was kept, but used a deep cleaning to make it look like new. So this is where you see the old and the new together. They actually marry quite well. They don't fight with each other. This is a building that some of you would know. It's in just a few kilometers from here. This is dating back, the first one from 1970s, 73 or 74, if I recall, and then more and more buildings were built around it. And what happened was, on this one, it was not just a case of renovating the bottom, but the whole tower needed to look the same, old building and new building. Interestingly, new building is also not clean and a bit dirty, but never mind. This one is using metal panel. The other one is concrete and paint, but with some clever ideas on how to deal with it, you can actually make it look very similar, but spend very little money. And you lift the whole value of your asset. You can command better rental, better income, better returns. And the whole compound looks much more integrated, even though actually one is almost 30 or 40 years older than the other one. So different views to show how the different buildings, the different blocks. The two on the left are old. The one on the right is actually newer. And the two at the back, the blue towers, are, of course, the latest additions to the compound. Another example, so I talked about 70s to 2010s, 2020s, now even older, something even more interesting. This is HSBC headquarters in Singapore. This building was built in the late 1880s. And so that headquarter has remained at the same location since 1880s until today, so almost 150 years. And over time, it has evolved. Why has it evolved? For the same reason I mentioned, to increase the value of the property, increase the rental, increase the profits eventually, but always making the building look better and better and perform better and better. So let's see those phases. 1880s, 1890s, a bit of additions and alterations. Already back then, they're thinking I keep the structure, but I just change a bit of the roof, a bit of the windows, but the building stays the same. 100 years later, or 50 years later, maybe, also evolved, but the style remains still quite heavy, a lot of stones. Unfortunately, it has been demolished and rebuilt like this, same location, in the 90s. Now, in the 90s, this was maybe top of the line, best facade possible, but maybe single glaze, low performance, tinted glass, stick system curtain wall, which is very reliant on workmanship at site. And so the quality tends to be very bad. And the performance also very bad. You see problems like water leakage, tenants complain. Here it's even worse because it's their own building. So they need to make sure their employees are efficient and work well, comfortable, and are not dissatisfied by the facade. So the first change that was made after this 1990s is what you see at the bottom. Maybe not so clear, but the bottom part, oops, it's there, the bottom part. The podium was changed. So for the same reasons as what I mentioned before, just to make that building look better from street level. And so the upper part of the tower is still the old part, and the bottom part is changed to this new podium, double skin facade, 2 layers of glass, very highly efficient thermally, and it looks very good. At ground floor, it looks excellent. It looks very, very beautiful. But of course, on top is still the old building, so it has not yet improved the performance and solve the water leakage issue for the upper floors. So a few years later, the upper floors were changed using modern technology like unitized curtain wall, double glaze units, low-E coated glass. And what it means is that the thermal performance of the building improved dramatically. And there were a lot of savings realized on air conditioning, and also the people inside the building are a lot more comfortable. They're not feeling so hot, even when they are very close to the facade. So this is not just a case of I modernized the building just for the look, but as was rightly mentioned before, the look and the function also must be there. So the two must work together. So this is form and function. Very similar situation here, very similar reasons for doing recladding. PIL building, so it's a shipping company. They own the building, and this is the building in the late 80s, early 90s. You can see the entrance is non-existent. It's black. It's like a black hole. It doesn't, you don't want to get into that building. The top part, very dated, square grid, really looks old. The glass is just solar reflective, so it's tinted with a reflective glass, quite commonly used in Jakarta, maybe at least buildings until about 10 years ago. Most of them use glass like this. It cuts a lot of light. It doesn't cut a lot of heat, so not very thermally efficient. The facade was changed, so all the structure remains, all the inside remained. What was interesting here, and same as for HSBC, the client don't want to move out of the building, okay? So the whole facade was changed with the people inside, the tenant inside. And what it means is, as an owner of the building, they did not lose revenue. They didn't stop operation. The building was functioning. They were still collecting rental for those floors that are used by other tenants. And so this is very, very important to be able to do these changes, to upgrade the building while minimizing disturbance to inside. That means the building continues working normally. And look at this, the outcome is like, you wouldn't even know it's the same building, but actually it's exactly the same building. And again, the podium receives a special treatment because it's eye level and you want people to engage visually with the building and make the building more inviting, more interesting at ground level. So very, very good outcome, very satisfying for everyone. The last case study is Lazada One. Lazada One in Singapore was an insurance building initially. It's called Manulife Building, built in 1989. And this building was kind of iconic in Singapore, very recognizable. But after 30 years or 40 years almost, it started to look quite old. And a new client bought the building and wanted to increase the value of their asset. And so this shows you how the building looked like before the renovation. The ground floor also, all the shop fronts, the canopies, quite old looking, not very interesting. Different ideas were discussed, were put forward on how to decide what are we going to do with this building. One of the main things the client wanted, again, is don't get my tenants to leave. I want the tenants to keep on giving me rental money while I'm doing the works. So we wanted to keep the existing glass facade. We did not touch the glass. So if we don't touch the glass, but we make the building more efficient, that means we need to create some sort of shading element. And so different versions of that were calculated and simulated. And finally, we chose the most thermally efficient, which is the one you see on the right. And these came in the form of a series of vertical sunshades and horizontal sunshades, supported from only those columns, the white curvy columns. We are not touching the rest of the facade. We cannot attach big sunshades to the existing curtain wall. But the columns, yes, the columns are very strong. So this was designed in a very interesting manner. We suspend everything from the roof and we tie back to the column. It's a very, very effective and cost-effective and practical way of solving this problem. And same building after 2 years. Took 2 years. It should have taken 1, but this was in the middle of COVID. And so it took a lot longer than we thought. And the fins, they're a mixture of aluminum and glass. And so we're using glass fins also in the fins to stiffen the fins and support the fins and to make an interesting appearance at night. Now, the interesting thing for this building is that the client bought the building and started discussing with big international organizations. Lazada, maybe everyone knows Lazada nowadays. Lazada was so happy with the design and the performance of the building and everything, they actually took a substantial, they became major tenant, and the building was actually named Lazada 1. So very good outcome for the building owners. That shows it's not theoretical increase in value, it is the real increase in value because you can command this kind of premium rental, premium customer like Lazada. The curved columns cladding were changed to square one, which is a bit more modern appearance with some interesting re-entrant corners. You can see here the mixture of materials in the fins between aluminum and glass. And we even had the visit of a monkey on this building. Sorry, I see everyone leave the head when I say that. So this was a temporary art exhibit where we actually managed to suspend a monkey sculpture on the building, but it was just for promotion for a while. But the facade is very, very effective, and we validated through checks on the energy consumption of the building. After we added the new facade, the energy consumption reduced enormously, even though actually this is still the original glass and the original facade curtain wall behind. The entrances were also very elegantly redesigned with very large glass panes and minimal supporting structures. And again, you can see, I think everybody knows Spotify. So this is another one. There's many of these tenants, high-tech, banking, finance sectors, all want to be in this kind of renovated buildings where you spend a little bit more of money, but you get a very, very good outcome at the end. And this shows you side by side the 1989 version and the 2023 versions. So it's really a major transformation and a very, very positive outcome for the building owners. So these are some of the different ways that either partial recladding, partial transformation, or even complete change of facade can be achieved and to derive energy saving, more efficient facade, more modern look, and overall better value for the building. Instead of demolishing, it's much more cost effective to do that by just changing the facade. Thank you very much. Bye-bye.
Our last session before we break for lunch is moving on to a panel discussion. Allow me to introduce the moderator, Dion Andatio, Sustainability Leader, Asian and East Asia from Mott MacDonald.
Hello, just testing. All right. Hi, everyone. Thank you for the organizer for the time for us to have this discussion today. Maybe I'll start first with an introduction to the panelists. So for the first one, we'll have Pak Aditya Fitrianto, Project Director from Alien Design Consultant. Pak Adit, can you come to the stage? And for the second one, we have Pak Werison Wijaya, Associate Architect from UNA Architectural Design Group. Yeah. And we have Pak Tio from PDW, representing GBCI. And we have Pak Iklim Tan, Principal Architect from Auresia Design. And last but not least, we have Pak Hendra Maulana from MNC Land. All right, so thank you everyone for joining me today. I think the topic for today, maybe I'll just use bahasa if it's easier. Jadi topik pembicaraan hari ini kita diskusi santai aja. Topiknya tentang facade performance dan emisi karbon. Mungkin agak-agak berat ya untuk topik pembicaraan sebelum makan siang, cuman kita coba bahas pelan-pelan. Di panggung ini udah ada ahli-ahli dari perencanaan fasad, ahli-ahli bangunan, ahli bangunan hijau juga. Jadi kita akan coba mengulik tren terbaru dari facade performance and dari emisi karbon juga. Coba saya minta klik-kira dulu dari panitia. Ya mungkin saya set konteksnya dulu kenapa kita mau ngomongin soal emisi karbon. Jadi sebelumnya kan pembicaraan tentang fasade itu biasanya berawal mula dari fungsi fasade yang pertama, memberikan proteksi kepada penghuni bangunan. Lalu kita mulai beralih dari pemberian proteksi, kita beralih ke estetik. Kita mulai ada pertimbangan bentuk bangunan, architectural intent, space requirement, apakah kita ada cantilever atau tidak ada cantilever. Lalu beberapa tahun belakangan ini kita mulai melihat fasade bangunan dari sisi energinya. Ada requirement untuk penggunaan OTTV, mulai ada pembicaraan tentang cooling load reduction untuk mengurangi beban AC dalam bangunan, pengurangan beban pencahayaan artifisial dalam bangunan juga. Lalu sekarang udah mulai nih pembicaraan tentang emisi karbon. Jadi apa efek dari fasade bangunan terhadap emisi karbon dari operational carbon dan embodied carbon juga. Lalu yang terakhir ini yang sedang jadi tren di luar negeri juga, itu pengaruh fasade terhadap climate positif. Jadi gimana fasade bangunan bisa menambah biodiversity dan juga bisa dimanfaatkan sebagai urban farming. Jadi saya mau buka topik bahasan hari ini dengan coba tanya ke masing-masing panelis, apakah ada pandangan dari bapak-bapak di panggung ini terhadap perkembangan fasade sekarang, apakah konsiderasi kita sekarang di Indonesia tentang fasade bangunan untuk penghematan energi sudah cukup, apakah kita sudah siap untuk melihat ke tahapan selanjutnya untuk emisi karbon, operasional dan embodied carbon, atau ada contoh-contoh proyek yang Bapak tangani yang bisa dijadikan contoh yang bagus di Indonesia. Mungkin saya mulai dari Pak Adit dulu. Ya, silakan Pak.
Terima kasih Mbak Dion ya. Maaf, in bahasa ya, oke ya for everyone. Yang menarik adalah sekarang perkembangannya adalah kita tidak hanya membuat fasad secara estetik ya, tapi juga gimana bisa memberikan nilai lebih terhadap penghematan energi atau tadi energy reduction ya. Jadi juga itu yang sangat menarik, apalagi secara peraturan juga sekarang diarahkan Jakarta, nanti mungkin Mas Tia bisa lebih menjelaskan terkait dengan green building. Hampir di semua building, public building kita juga sudah diharuskan memiliki OTTV yang sangat baik gitu ya. Jadi itu otomatis ada gimana kita menstrategikannya gitu ya. Dan satu sisi juga sekarang tadi ada contoh bagus ya terkait dengan existing building ya. Jadi juga itu juga menjadi tidak hanya fasad tidak melulu kaca ya gitu ya, tidak melulu glass, but just not only the glass, tapi gimana how to make secondary skin. Nah itu juga sangat menarik tadi yang presentasi sebelumnya di Facade ya tadi ya sebelumnya. Itu juga jadi menarik, jadi itu membuat kita lebih dynamic, kita bisa lebih bereksplorasi di situ. Walaupun tujuannya tetap menuju ke arah lebih ke energy reduction dan otomatis juga berakibat kepada sustainability juga. Mungkin itu dulu kali ya. Terima kasih.
Ya, silakan Pak.
Oh. Ini. Kalau saya melihat untuk elemen fasad ini memang terkait estetika ya, seperti yang tadi Pak Dion sampaikan. Tapi sebetulnya untuk fasad ini mesti kita melihat dari karbon ini yang embodied atau operational ini saling terkait. Jadi kalau kita melihat dari embodied kan ini dari desain elemen fasad tuh harus sudah dipikirkan dari sedini mungkin bahkan kalau bisa. Itu yang mempengaruhi jejak karbon dari suatu bangunan. Jadi kita kalau dikaitkan dengan estetika, sebagai desainer kita akan tarik-menarik antara tiga elemen kan ya, keindahan, fungsi, atau firmitas gitu. Nah ini akan yang perlu kita sesuaikan dengan konteks masing-masing proyek, baik itu lokasinya, fungsinya, ataupun tipologi lainnya. Ya mungkin untuk pembuka seperti itu dulu Pak.
Mathieu, ada masukan?
Ya, menurut saya 5 ini penting sebenarnya. Kita lihat secara keseluruhan di Jakarta atau di Indonesia sekarang mungkin antara 2 dan 3, 4 dan 5 itu masih agak dalam tanda kutip jauh, tapi emang harus sudah mulai dipikirkan dari sekarang. Yang paling penting sebenarnya dasarnya dulu. Kalau yang nomor 1 kan dasar ya. Dia harus aman, nyaman. Setelah itu kita sebenarnya dalam tanda kutip bebas berbuat ngedesain apapun, termasuk tanpa fasad. Maksudnya ya kalau saya boleh mengutip senior kita ya Yori Antar, dia bilang Indonesia adalah negara tropis, jadi kita perlu sebenarnya fasad yang bernapas. Tapi kalau kemudian konteksnya Jakarta dengan tadi polusi dan lain-lain tadi yang disampaikan, tentunya ada tantangan lagi nih yang mungkin ke arah nomor 5 jadinya. Bagaimana sebenarnya fasad itu juga bisa sebagai saringan yang atau filter gitu ya, supaya orang yang tinggal di dalam bangunan jadi kembali ke basicnya, aman, nyaman, dan sehat. Kalau kami sendiri biasanya mendesain melihat dari aspek selain keamanan, kesehatan, kenyamanan juga tentu dibantu sama konsultan fasad ya, tapi kita lihat juga dari sisi tadi penghematan energinya, terus tantangan yang besar sebenarnya embodied carbon yang sekarang mungkin jadi topik ya, karena banyak material fasad belum diproduksi di Indonesia. Mungkin lanjutannya nanti dibicarakan setelah ini.
Oke. Terima kasih. Betul, saya setuju banget ya Pak Tio bilang bahwa ini semua penting, kelima elemen ini. Cuma memang yang menjadi tantangan bagi praktisi, terutama kita sebagai perencana, tantangan menurut saya yang terbesar, memang sebagai perencana pasti semuanya mau bahwa rancangannya yang secara estetika baik dan menarik. Cuman bagaimana kita mengedukasi kepada investor ataupun klien bahwa dengan kita merancang sesuatu yang lebih sustainable, dengan mungkin dengan second skin, dengan teknik-teknik isolasi bangunan, tentu saja itu kan memberikan dampak penambahan biaya. Nah, penambahan biaya ini yang kita harus edukasi kepada klien bagaimana bahwa dia memberikan keuntungan jangka panjang bagi mereka. Nggak hanya sebagai mengurangi operational carbon, tapi juga secara jangka panjang value bangunannya sendiri itu akan meningkat. Nah, tantangan kita memberikan perhitungan, memberikan keyakinan kepada para klien untuk rela untuk invest di awal. Itu yang buat kita tuh sangat besar. Namun kita harus memulai memberikan edukasi kepada klien maupun shareholder mereka gitu loh, bahwa ini very important for now and for the future.
Terima kasih Pak Iqbal. Itu segue yang bagus untuk ke Pak Hendra sebagai developer.
Baik, saya bicara dari sisi developer. Kelima hal ini penting, gitu ya. Pasti semua developer ingin punya desain yang bagus, efisien, baik secara energi maupun secara emisi gitu ya, dan sustainable juga. Nah, mungkin masukan dari saya mengenai kelima hal ini ialah bagaimana mengefisiensikan material yang akan dipakai nih. Kita tahu setiap material pasti punya limitasi dari produksinya dia dan cara pemasangannya juga. Mungkin ini bisa berhubungan juga dengan low carbon yang memang kita mau capai juga nih. Semakin kita bisa memakai bahan atau material secara efisien dan desainnya bagus, itu akan membuat secara tidak langsung karbonnya akan menurun juga kan. Sustainable tercapai, desain tercapai, low carbonnya tercapai juga, sehingga kami dari developer mengharapkan sih bahwa setiap desain atau desainer mendesain sesuatu tuh yang seefisien mungkin, ya. Material boleh mahal, tapi kalau dipakai secara efisien akan menjadi efisien kan, bukan menjadi costnya lebih tinggi. Mungkin itu yang diharapkan dari developer. Sementara itu gitu, Pak.
Ya. Terima kasih, Pak. Ini coba kalau saya beralih ke contoh slide selanjutnya, saya mau kasih contoh-contoh fasade yang kira-kira dalam wacana saya bisa mencakup dari tahapan 1, 2, 3, 4, dan 5 tadi. Jadi fasad-fasad yang mementingkan proteksi kedaulatan bangunannya, ada pertimbangan energi, emisi karbon, estetik, dan juga positif karena mengundang biodiversity. Kemudian sekarang mau saya tanya ke panelis ini, dari pengalaman Bapak-Bapak, gimana cara yang paling baik untuk kita mengkuantifikasi benefit dari fasad performance? Jadi gimana kita bisa meyakinkan kita sendiri sebagai desainer dan meyakinkan klien kalau fasad yang kita desain itu adalah fasad-fasad yang akan berperforma tinggi, menghasilkan value tambahan untuk bangunan klien, jadi bisa ada hasil rental yield yang lebih tinggi, ada juga benefit positif ke lingkungan dan ke penghuni bangunannya. Dari pengalaman Bapak, kira-kira gimana cara yang paling enak, paling bagus untuk meyakinkan itu? Silakan siapa yang mau duluan.
Ya harusnya memang kuantifikasi itu penting ya, sekalian dari sisi kualitas tadi ya. Jadi tadi sebenarnya menyambung yang disampaikan Pak Hendra, betul sekali bahwa estetik masih jadi salah satu poin utama kalau kita bicara sama klien gitu ya. Apalagi kita bicara umur bangunan. Kalau bangunannya jelek pasti siapapun yang nanti akan menghuni atau mengoperasikan bangunan, pemilik aset pasti ingin mengubahnya. Karena belakangan ini tadi disebut juga pembicara sebelumnya bahwa kita harus lihat ke existing building gitu. Selain dari di luar sisi ini, mungkin Pak Adit bisa nambahkan cagar budayanya. Cagar budaya kan sangat penting, kita harus preservasi lah ya. Tapi ternyata kalau kita bicara emisi karbon, embedded carbon, bangunan existing itu nilainya sangat besar gitu. Tanpa membangun baru, kita refasading. Jadi ini fasad jadi mainstreaming gitu. Saya pernah diundang oleh pemilik aset terbesar di Indonesia, Dirjen Kekayaan Negara. Mereka tanya, kalau IKN jadi pindah ke Nusantara, apa yang kami lakukan dengan aset-aset di Jakarta gitu. Saya bilang ya nggak bisa semua didemolish. Satu, heritage building pasti harus dipertahankan. Yang kedua, bangunan-bangunan yang masih layak bisa di renovasi, di adaptive reuse lah namanya, itu ilmu lama juga. Nah, apa yang harus di-adapt ya teknologi barunya. Tadi juga di pembicara-pembicara sebelumnya ada menampilkan bangunan lama yang diadaptasi dengan teknologi baru gitu ya. Seberapa mahal, seberapa biayanya ya kita harus ngitung. Itu pentingnya kuantifikasi sebenarnya. Di mana kita bisa menghitung manfaat peremajaan bangunan gedung tersebut. Apalagi sekarang ini ya, nggak banyak lagi yang membangun saat sekarang nih marketnya belum sampai ke sana. Mungkin kita mesti lihat juga bagaimana sebenarnya adaptasi terhadap bangunan yang ada, bagaimana meremajakannya atau mempertahankannya supaya dia masih tetap relevan di zaman sekarang. Itu tentu melalui kuantifikasi dan higher performance. Pak Adit mungkin menyambung yang heritage building.
Oke, terima kasih Mas Tio. Nah ya setuju banget ya. Jadi terkait dengan gimana bisa mengangkat ya, jadi dan edukat satu sisi ke klien terkait dengan fasad yang lebih satu sisi menarik, tapi satu sisi bisa terkait dengan mereduksi karbon juga ya. Jadi ada beberapa hal ya, tadi kalau terkait area konservasi, banyak tadi saya juga disebutkan sebenarnya di existing building tuh kita gimana meletakkan sesuatu yang bisa plug in ataupun bisa reversible lah, jadi dan itu konsep secondary skin itu sangat baik ya, jadi dan itu tapi satu sisi juga bisa mengurangi reduksi karbon juga dalam arti mengurangi energi di baliknya gitu ya. Itu satu sisi ya terkait dengan yang cagar budaya, mungkin orang jangan agak menganggapnya itu susah atau gimana, padahal itu suatu tantangan sangat menarik. Kita punya kota tua di Jakarta, punya kota lama di Jakarta. Begitu kita bisa memanfaatkan itu, otomatis ada memakai yang mungkin semacam recycle city ya, dan itu adalah bagian dari sustainability juga gitu. Nah itu juga yang kita berharap pindahnya ke IKN Nusantara itu bukan berarti juga matinya Jakarta. Jakarta tetap Jakarta. Jakarta is a business city. So it will be another part lagi ya terkait itu. Itu satu sisi. Kemudian terkait gimana tadi kan bilang klien gimana gitu ya bisa. Kebetulan yang menarik kita ada beberapa proyek sempat bantu sebagai desain ambit di IKN juga dan juga ada di Jakarta. Di Jakarta tuh sekarang lagi rame juga adalah di PIK 2 gitu ya. Ada beberapa mungkin Mathieu juga bantu ngerjain beberapa klien di sana juga. Itu orientasinya sekarang klien sudah punya pemikiran untuk mengangkat rental mereka itu menggunakan ada rating ya, bisa GBCI, bisa BGH. Kalau di IKN BGH ya, tapi ada juga mereka sekarang minta lead, yang menurut saya agak berat gitu ya. Tapi dan itu akhirnya membuat kita harus bereksplorasi gimana menghadirkan sebuah fasad yang tidak secara estetik, tapi juga memiliki ya keunggulan di rating, satu sisi juga untuk reduksi emisi juga, reduksi energi juga di dalamnya seperti itu. Jadi itu jadi suatu hal yang jadi menarik ya. Jadi karena klien-klien itu udah mulai memahami itu dan mereka pingin, dan itu juga bagian dari satu sisi marketing mereka juga. Mungkin itu dulu ya, monggo yang lain, silakan. Nah.
Saya mungkin tambahkan sedikit dari rekan-rekan mengenai retrofit building ya. Maksudnya kita kan dengan retrofit building kan memang kita sudah menerapkan low embodied carbon ya, karena kita tahu bahwa dalam satu konstruksi karbon emisi yang paling besar itu dari konkrit atau beton sendiri, di mana kandungan semennya kan besar sekali ya di situ ya. Jadi dengan retrofit building, dengan presentasi dari beberapa perusahaan sebelumnya, saya sangat setuju bahwa banyak sekali sekarang teknologi baru yang kita bisa mengurangi mengurangi embodied carbon dengan teknologi yang baru. Dengan teknologi yang baru ini kita sekaligus juga memberikan impact yang besar terhadap operasional karbon. Jadi jika seandainya kita dipilih, kalau seandainya kayak kita semua sebagai perencana dipilih, apakah mau demolish the building atau mau retrofit the building, saya akan sangat setuju kita preserve. Kita bisa menggunakan struktur yang ada, tapi sekaligus mempercantik secara estetika gedung yang itu sehingga memberikan value yang lebih besar kepada ownernya gitu. Ya, itu buat saya sih.
Boleh saya tambahkan, Pak? Selain yang tadi, Pak, mungkin yang harus kita perhatikan sama-sama ialah mengenai waktu pengerjaan juga. Ini kalau saya ngomong dari sisi developer juga gitu ya. Desain gedung yang bagus, tapi kalau pengerjaannya lama atau pakai material yang low carbon, tapi kemudian juga pengerjaannya lama akan bikin secara nggak langsung low carbonnya jadi tinggi juga kan. Tapi kalau kita bisa mendesain sama-sama nih bangunan yang memang secara tadi bukan efisien aja, tapi juga pengerjaannya lebih cepat, itu kan berarti secara nggak langsung mengurangi karbon juga kan. Sehingga membuat low carbon juga. Jadi yang patut kita perhatikan sama-sama waktu mendesain, apakah pengerjaannya nih akan memakan waktu lama atau bisa kita percepat dengan menggunakan bahan-bahan material yang memang dalam tanda kutip itu ready to use, begitu kan? Tinggal plug and play lah kalau zaman sekarang ini kita dengan IT. Nah, itu yang perlu kita perhatikan juga sama-sama. Bagaimana waktu untuk renovasi, waktu untuk pengerjaannya, apakah efisien atau enggak, gitu.
Mungkin saya tambahkan sedikit dari Pak Hendra. Saya sepakat dengan ada banyak aspek yang perlu dipertimbangkan sebelum memutuskan bahwa kita sebaiknya merenovasi atau membangun baru. Salah satunya adalah material lokal. Berdasarkan pengalaman dari salah satu proyek kami, kita mungkin umumnya kita tahu kalau kita memanfaatkan material lokal itu akan mengurangi jejak carbon footprint dan embodied carbon di bangunan itu. Tapi ada salah satu pengalaman di proyek kami di Jayapura, di mana mereka itu mempunyai material lokal pengganti bata merah atau bata ringan, batu tela namanya. Itu sebetulnya kan kalau kita menggunakan material lokal, otomatis jejak karbonnya akan lebih kecil karena mengurangi mobilisasi material dan lain-lain. Tapi pada kenyataannya yang mungkin kadang-kadang kita perlu pikirkan juga adalah bagaimana material lokal itu berdampak ke keseluruhan proyek tersebut. Kalau dalam kasus proyek kami ini, ternyata material lokal ini bebannya sangat besar sekali dan itu akan berdampak ke struktur bangunan. Otomatis volume materialnya jadi bertambah, seperti yang dikatakan tadi. Dengan memasukkan tambahan material tentunya akan menambah jejak karbon yang terkandung di proyek tersebut. Jadi kita perlu melihat dari berbagai sisi dan menurut saya kita perlu melibatkan project stakeholder di suatu proyek sejak dini. Jadi kita bisa paralel berjalan semuanya. Kita mendesain iya, konsultan struktur juga menghitung, quantity surveyor juga berhitung biayanya. Kita perlu akan lebih baik kalau itu semua bisa berjalan beriringan. Seperti itu.
Ya, makasih Pak. Saya mungkin ada pertanyaan tambahan lebih ke Pak Hendra mungkin sebagai developer Pak. Kalau sebagai desainer kan kita mencoba menerapkan sistem fasade yang paling bagus, yang paling efisien. Tapi kan itu kadang-kadang ada konsekuensi di harganya. Walaupun pada nantinya mungkin bisa menghemat operational cost. Jadi dari pengalaman Pak Hendra sebagai developer, pertimbangan antara operational cost dan capital cost itu mana yang lebih penting untuk diterapkan di proyek?
Pertama kita harus membuat perbandingan nih Pak. Kalau pakai material ini, low carbonnya kita dapat, biayanya berapa, kemudian kita bandingkan sama operational cost. Pasti memang yang lebih penting ke depannya operational cost, karena kan gedung itu kan akan dipakai lama kan. Bukan setelah 5 tahun kita demolis ganti baru. Apalagi kalau memang itu bangunan heritage. Jadi yang memang kalau pertanyaannya kembali ditanyakan mana yang lebih penting, pasti operasional yang perlu kita perhatikan. Oleh karena itu setiap kali kalau saya setiap kali ada pengajuan material baru, baik itu arsitektur, struktur, MIP, selalu saya akan minta perbandingannya nih. Kalau pakai material ini efisiensinya di mana sih? Bukan cuma sekedar biaya gitu ya, tapi ya konstruksinya, waktu pengerjaannya, lifetime-nya juga. Nah itu kita perlu perhatikan. Sehingga harusnya kalau developer itu akan melihat operasionalnya. Kalau memang mau pakai material yang costly, tapi kalau secara long term-nya akan mengurangi operasional, kenapa enggak? Misalnya fasadnya kita buat yang mengurangi cahaya yang masuk sehingga panas juga mengurangi gitu ya. Itu kan mengurangi operasional cost-nya dari energi yang kita pakai kan, listrik begitu ya. Otomatis kalau listriknya berkurang, pasti pengeluaran biayanya juga berkurang.
Ya.
Begitu Pak.
Jadi lebih ngelihat ke life cycle cost-nya Pak ya, pendekatannya. Oke. Ini mau saya bawa nyelam lebih jauh nih ke soal carbon. Ini masih ada kaitannya dengan perbandingan antara capital dan operational. Jadi kalau misalkan kita lihat kan sekarang semua negara udah ada komitmen terhadap net zero. Indonesia kita net zero komitmennya 2060 dan kita termasuk salah satu emitter karbon paling besar di dunia. Jadi makanya semua sektor di Indonesia kan sekarang harus melakukan dekarbonisasi. Sekarang yang mau saya jadi pertanyaan ke Bapak ini, seberapa jauh efek yang sudah Bapak rasakan di proyek atau di perusahaan atau di klien terhadap tuntutan untuk mulai menghitung karbon, apakah itu operational carbon atau emisi karbon. Mungkin saya mulai dari Pak Hendra dulu. Dari sebagai developer, udah ada tenant-tenant atau customer di gedung Bapak yang sudah meminta sertifikasi karbon belum?
Kalau yang sekarang sih belum sih. Tapi yang di waktu dulu saya di konsultan itu memang ada beberapa gedung yang minta jadi green building, pasti ada perhitungan karbonnya juga. Cuman saya mau menyoroti satu hal ya dari sisi developer mengenai perlunya insentif sih dari pemerintah gitu ya. Developer tidak akan keberatan pakai material yang bisa bikin karbonnya jadi low, tapi itu kan memerlukan tanda kutip bantuan dari pemerintah atau insentif dari pemerintah. Kalau kita pakai material ini nih, apa sih yang dari pemerintah bisa berikan juga sehingga kita mau pakai material ini. Kalau balik ke pertanyaan, selama ini kita belum menghitung, begitu. Hanya sebatas perhitungan yang tadi saya jelaskan, pakai material ini, kemudian efisiensinya bisa berapa dibandingkan dengan operasional cost ke depan, gitu Pak.
Terima kasih Pak. Dari teman-teman lain udah ada yang mulai merasakan efek tekanan untuk dekarbonisasi ini di proyek atau di apa dari klien?
Sebenarnya ke kita sendiri secara langsung tidak ada. Tapi kita akan sangat senang apabila kita mengetahui bahwa perencanaan kita dari awal mengenai bagaimana mengurangi operational carbon itu terlaksana dengan baik dan ada laporan dari pihak owner bahwa konsumsi pemakaian listrik energinya itu sangat rendah akibat dari perencanaan fasad kita yang baik. Itu yang merupakan benefit bagi kita secara tidak langsung. Nah, balik tadi saya setuju banget bahwa mulai sekarang apa yang kita bisa dengungkan adalah coba kita memberikan pengertian kepada pemerintah untuk lebih memberikan insentif yang signifikan kepada investor atau pemilik developer sehingga mereka willing to invest, to pay di awal dengan misalnya dengan secondary skin, kita tambahkan juga dengan sistem extrusion yang ada thermal break dan dengan low E atau U value yang sangat baik terhadap glazingnya gitu ya, DGU maupun triple. Nah, hal-hal itu kan perlu biaya. Nah, biaya itu jika kita developer terima, dengan investasi sekian, tapi operasional kita akan menghemat signifikan dan dengan hemat signifikan itu dalam artian dapat insentif juga dari pemerintah. Nah, itu akan sangat membantu membuat kita punya negara ini akhirnya bukan lagi menjadi emitter terbesar di karbon, tapi mungkin akan lebih cepat recovery-nya. Gitu.
Baru-baru ini ada di sosial media atau di media, Bu Sri Mulyani menyatakan bahwa Indonesia perlu 3.000 triliun untuk green building, untuk bangun baru, renovasi, dan lain-lain. Dan saya nggak tahu angkanya dari mana, tapi itu signifikan sebenarnya. Dan pemerintah udah recognize bahwa green building itu penting karena secara dunia juga dari COP di Paris, COP keberapa kemarin ya 15 maksudnya di Paris sudah direcognize bahwa bangunan gedung akan kontribusi paling enggak 30%. Nah ini yang kita nggak ngomong gedung sebagai hanya bangunan high rise ya, tapi juga semua termasuk kalau di Indonesia kebanyakan kan pembangunan FLPP, affordable housing. Dan menurut saya existing building tadi dan kemudian kalau kita hubungkan dengan acara kita hari ini, Facade akan jadi sangat signifikan gitu ya. Menurut saya yang harus didorong sekarang ya sebagai dan arsitek juga harus banyak explore gitu ya untuk retrofitting atau adaptive reuse tadi yang saya sampaikan. Dan yang paling penting dari itu adalah fasadnya gitu. Jangan sampai menggunakan bangunan yang, saya nggak ngomong bangunan heritage yang lama kemudian di fasading gitu, recladding, tapi bangunan yang dalam tanda kutip salah kaprah tadi, yang single glazing, kemudian ininya tinggi, pantulan energinya, penggunaan OTTV-nya masih sangat tinggi, itu potensial banyak sekali gitu ya. Kalau dihitung sebenarnya data dari CityBUH ada sekitar 900 bangunan tinggi yang di atas 150 meter di Jakarta yang sudah dibangun gitu ya. Itu data 2-3 tahun yang lalu. Itu yang sebenarnya sangat potensial, apalagi sekarang ini kalau dan kebanyakan tuh bangunan milik swasta ya. Dan bangunan baru. Nah, tantangannya memang dengan menghitung, kalau di GBCI sudah dihitung, di Greenship udah ada perhitungan operational carbon. Jadi sumber listriknya itu juga masih dari PLTU, jadi sangat tinggi ininya, savingnya jadi sangat tinggi, karena emisi karbonnya juga sangat tinggi kalau di Jakarta ya. Jadi kita harus lihat sumbernya. Jadi operational carbon aja ngitungnya, kalau misalnya solar panel tadi biaya PV didorong dan lain-lain, itu akan menurunkan sangat signifikan. Belum lagi kalau sekarang terus terang belum ada perhitungan tentang atau permintaan untuk menghitung tentang embodied carbon atau LCA-nya. Tapi sudah mulai ya, waktu kemarin saya ke Filipina ditanya material supplier, kamu ada nggak labelnya berapa karbon yang emisi karbon yang dihasilkan untuk menghasilkan satu material ini. Jadi udah kayak kalau kita beli makanan di supermarket berapa kalori gitu. Saya rasa ini juga harus sudah mulai didorong gitu ya, bukan jadi peraturan yang ini sticknya ya, tapi tadi saya setuju juga selama ini green building bangunan hijau itu belum ada carrotnya, belum ada insentifnya gitu. Itu yang harus didorong. Kembali ke karbon tadi ya, dari labeling aja sebenarnya dari setiap material, misalnya material kaca, emisi karbon yang dihasilkan per kilogram atau meter persegi atau apa. Kalau itu ada, itu akan sangat mudah menghitung buat kita ya sebagai desainer atau pengguna nanti berapa emisi karbon yang dihasilkan dari desain kita.
Oke, tadi sebenarnya saya sudah sebutin bahwa beberapa klien itu sudah lumayan udah melek lah terkait green. Tapi tadi kan terkait dengan low carbon dalam arti otomatis kan net zero carbon ya, berarti lebih ke situ kan terkait dengan pemakaian energinya yang seimbang sebenarnya, antara yang keluar dan yang masuk. Dan itu yang menarik ya sebenarnya. Terus terang yang paling penting juga sebenarnya nggak hanya tadi ada insentif teman-teman bilang juga, tapi menurut saya pembelajaran juga. Itu nggak hanya ke klien dan tapi ke kita juga ya, karena misalnya kemarin kami bantuin walaupun hanya sebagai design and build dalam arti detail engineering dari sebuah desain, itu di IKN tuh harusnya semuanya udah pasti harus ada BGH, tapi mungkin hanya masih ngejar rating. Tapi jangan sampai kerja ratingnya bagus tapi energinya boros. Nah itu yang kami sempat khawatir waktu itu. Nah itu yang pemahaman itu yang mungkin belum yang perlu kita tingkatkan menurut saya sih. Jadi awareness-nya gitu ya. Terus karena terus terang kebetulan saya pernah lihat diajak Prof JW di mungkin teman-teman yang di sini pernah ke SDE for US di Singapura, ya itu contoh yang sangat baik. Tidak mahal sebenarnya ternyata untuk menghadap net zero, tapi dengan pendekatan pasif design dan saya bilangnya sangat kreatif ya saya bilangnya. Dan itu net zero, dan tadi Mas Dion juga bilang itu salah satu paling baik di Singapura ya gitu ya. Nah itu yang harusnya kita bisa pakai gitu, di mana di sana pemakaian energinya dengan hybrid coolingnya juga sangat menarik gitu ya. Kayak gitu itu perlu ditingkatkan. Jadi juga satu sisi juga tadi teman juga bilang nggak hanya soal inisiatif, terus tadi saya juga pembelajaran, tapi juga gimana teman-teman di sini yang terkait dengan yang penyedia material juga mulai juga berpikir untuk membangun pabrik di sini otomatis ya. Kan tadi juga Mas juga bilang gimana di Papua, karena kita repotnya di Nusantara kita ini archipelago ya, jadi lumayan jauh ya, kita lebih dekat ke Singapura dibanding kita ke Jayapura gitu misalnya. Tapi gimana kalau kita punya pabriknya di sini, kalau nggak import itu jauh lebih bagus sekali. Dan itu pasti mengurangi karbon dong otomatis gitu. Mungkin itu dulu ya, terima kasih.
Mungkin saya tambahkan kalau dorongan dari pemberi tugas untuk membuat bangunan yang bisa decarbonize sebetulnya mungkin secara langsung tidak selalu ada. Jadi kalau dari pengalaman kami biasanya dorongan ini justru muncul sebagai salah satunya gimmick marketing juga ya. Oh ini bangunan kami sudah ada green labelnya, begitulah istilahnya. Memang tidak buruk sebetulnya karena setidaknya mereka ada awareness untuk mengejar sustainability dengan tersertifikasi green. Tapi memang alangkah lebih baiknya kalau bisa lebih jauh daripada itu. But it's a start. Kalau dari kaitannya dengan insentif, saya setuju dengan Bapak-Bapak, memang kecenderungannya persepsi dari pemberi tugas adalah, oh kalau green itu jangan-jangan mahal nih. Nah itu dengan kondisi ekonomi seperti saat ini, budget akan jadi constraint yang mungkin perlu diperhitungkan. Kalau dengan adanya insentif dan kebijakan dari pemerintah itu akan sangat membantu untuk mendorong decarbonizing ini.
Ya, makasih Pak. Mungkin pertanyaannya sebelum saya pindah ke topik berikutnya, saya ada pertanyaan ke Pak Tio sebagai salah satu founder dari GBCI Pak. Gimana pandangan dari GBCI sekarang mengenai perkembangan evolusi desain fasade yang kita udah ada di Indonesia ini? Apakah sudah cukup progresif, sudah cukup melihat ke sisi energi yang harusnya kita pertimbangkan atau belum? Kalau misalkan belum, kira-kira dari pihak GBCI pandangannya seperti apa yang bisa kita push ke depannya? Kebijakan apa yang harusnya ada dari pemerintah, entah itu dari sisi dari perdagangannya, dari sertifikasi material, dari kewajiban dari pemerintah supaya bangunan lebih hemat energi atau lebih ramah lingkungan. Gimana Pak Tio?
Ya, salah satu misi green building kan adalah transformasi. Alat rating itu sebenarnya dipakai sebagai alat komunikasi yang tadi saya sebut. Sudah ada sebenarnya untuk operational carbon sudah ada kalau rating itu kan rewards point-nya gitu ya. Dari Green Building Council sendiri selama ini selalu mendorong passive design tadi yang disampaikan oleh Pak Wery dan Pak Adit. Dan kita terus mendorong karena dengan adanya alat komunikasi melalui rating system tadi itu selalu kita perbarui. Jadi sekarang udah mau masuk ke Green Ship 2.0. Di mana-mana juga sama, Green Mark, LEED, dan lain-lain karena kita satu organisasi yang sama lah tujuannya dalam payung World GBC. Intinya adalah kami mendorong dari dua sisi ya, desain kalau hubungannya sama fasad tentu passive design itu sangat penting. Kemudian desain aktifnya setelah itu ada BIPV, solar PV yang di roof. Kemudian juga bagaimana biodiversity tadi disampaikan. Yang semuanya harus hati-hati tadi Pak Tim juga dari Mainhat udah menyampaikan kalau kita taruh pohon di atas konsekuensinya berat gitu kan. Jadi itu juga kembali ke embodied carbonnya. Jadi sebenarnya yang kita perlukan sekarang sebenarnya kayak worksheet, kalkulator gitu ya, kayak Excel-nya apa-apa. Untuk ngelihat kalau pakai konkret, pakai tanaman, ngurangin operational carbon, menyerap, regeneratif, restoratif gitu ya. Tapi penaltinya di mana? Karena dengan isunya makin luas ini selain operational, kalau kemarin kan operational kita bisa hitung penghematannya dan lain-lain. Tapi ternyata di penaltinya di embodied carbonnya misalnya. Tapi kemudian lifetime buildingnya bisa berapa lama? Itu kan jadi satu life cycle assess ini. Kita lagi kerjasama juga dengan lembaga LCA bagaimana sebenarnya kita ngitung total building lifetime tersebut.
Saya boleh tambahin sedikit?
Jangan Pak.
Mungkin selain dari regulasi dan pemerintah suggestion dari pemerintah, mungkin dari kita juga berencana sesekali mungkin kita bisa masukkan spesifikasi bahwa material yang kita gunakan itu acknowledged by cradle to cradle atau LEED atau BREEAM gitu ya, di mana akhirnya membuat sang pelaksana Beberapa material itu memang sudah harus ikutin sertifikasi daripada sustainable material gitu ya. Mungkin itu yang kita bisa tambahin ya. Dan saya kira konsep cradle to cradle itu kan sangat baik untuk keseluruhan dari extraction raw material sampai ke life cycle-nya gitu ya.
Ya, makasih Pak. Menyambung cradle to cradle tadi, saya mau mulai menyentuh ke embodied carbon. Saya akan skip beberapa slide dengan cepat ya. Ini untuk carbon kan kita melihatnya biasa dari skop emisi 1, emisi 2, dan emisi 3. Untuk energy, operational carbon itu biasanya kita ada di skop 2, sedangkan untuk embodied carbon itu jatuhnya kita ada di skop 3. Jadi itu nggak secara langsung akan dikuantifikasi, tapi akan berpengaruh terhadap emisi carbon dari developernya. Lalu di emisi carbon scope 3 itu biasanya embodied carbon ada di kategori nomor 2 untuk capital carbon. Dan di situ ini yang agak ngejelimet dalam perhitungan ya. Untuk emisi carbon, untuk embodied carbon itu dibagi lagi dari kategori 2 scope 3 dibagi lagi dari kategori A, B, C, dan D. Kategori A itu biasanya yang paling sering kita pergunakan untuk penghitungan embodied carbon dari product stage ke consumption stage dan hampir ke use stage. Untuk perbandingannya kan kita harus mempertimbangkan tadi both operational carbon dan embodied carbon. Sekarang yang mau saya angkat ini untuk embodied carbon ya. Untuk embodied carbonnya untuk fasade bangunan biasanya ada metodologi penghitungan yang sedikit berbeda dari operational carbon. Untuk rating luar negeri, mereka biasanya nge-push embodied carbon udah mulai cukup kenceng sekarang nih. Itu udah ada metodologi yang cukup robust, udah beberapa tahun dikembangkan. Pertanyaan saya mau mulai dari Pak Tio sebagai GBCI Pak. Apakah sudah ada perencanaan gimana Greenship nantinya akan mulai mengintegrasikan embodied carbon supaya penilaian Greenship itu nggak cuma ada di operational carbon juga, tapi kita mulai menyentuh ke embodied carbon.
Kenapa pertanyaannya susah? Susah-susah ke saya. Memang arahnya ke situ. Memang kalau mau jawab singkat sih belum ya, supaya cukup waktunya untuk yang lain. Tapi ini yang sebenarnya harus kita adopsi gitu ya. Tadi saya sampaikan kita sudah diskusi juga dengan lembaga LCA, nggak hanya tentang untuk building material, tapi juga selama dari waste-nya apa pengaruhnya ke building gitu ya. Yang nantinya kalau penghitungan karbon ya jatuhnya ke skop 2, skop 3 tadi dan ini yang memang harus didorong, nggak hanya prakteknya tapi juga sebenarnya pengetahuannya, karena terus terang banyak hal-hal yang kita perlu pelajari untuk bisa menerapkan pengetahuan ini. Kita yang sekarang di yang tadi 5 tahap itu aja masih antara tahap 2 dan 3. Nah sekarang kita harus lompat sampai ke regenerative economy. Jadi menurut saya tentu masalah selain technical gitu ya, sosialisasi dan pentingnya dan bagaimana nanti kuantifikasinya, cost dan lain-lain itu harus kita lihat sama-sama dan kita sosialisasikan semua bisa diterapkan dengan baik. Terima kasih.
Oke, nambahin aja sedikit, tapi intinya sebenarnya tadi saya juga udah sampaikan, itu kan larinya ke antara jenis materialnya juga, tapi juga proses. Nah jenis material juga makanya penting buat teman-teman di sini yang posisi factory itu penting gitu ya. Jadi kalau semakin dekat semakin bagus, delivery cepat, tapi bukan hanya sekedar prosesnya dalam membuatnya tidak energi yang berlebihan. Tapi kalau tetap di luar dari kawasan kita ya sama aja gitu sebenarnya. Itu satu sisi, dan kemudian selain prosesnya ternyata juga terkait embodied carbon ini juga proses konstruksi. Nah ini yang juga makanya penting dari tadi ada soal awareness dan pembelajaran. Tadi juga disampaikan Mas Tio, nggak hanya ke klien, ke kami perencana, tapi juga ke kontraktor. Dan kalau kami perhatikan sih sekarang sudah semakin baik kalau saya perhatikan. Jadi itu gampang sudah ngelihatnya secara pas konstruksinya kelihatan lebih clean. dan jelas, walaupun saya masih belum tahu dibuang kemana gitu. Tapi yang harusnya saling bisa di recycling itu lebih bagus, dan itu bagian dari mengarah ke sana. Dan menurut saya sih Indonesia bukan terdepan, tapi mungkin menjadi lebih mudah untuk berbelajar dan nanti bisa jadi terdepan. Itu aja. Terima kasih. Ada yang mau
Saya mau angkat sedikit dari slide di sini. Ini lagi-lagi ke mencoba mencari balance yang paling bagus antara capital carbon dan operational carbon. Untuk operational carbon biasanya untuk mengurangi energi kita OTTV kita perkecil dengan adanya shading devices, dengan adanya naungan. Tapi naungan itu biasanya kita bahannya dari aluminium. Dan kalau ngeliat dari embodied carbonnya, aluminium itu justru yang salah satu yang paling tinggi, 600 kg per meter persegi. Jadi untuk operational carbon lebih sedikit, embodied carbonnya bisa lebih banyak. Jadi ada balance yang harus kita strike. Jadi ada material-material yang mungkin bisa digunakan yang lebih akan lebih efisien, lebih bagus daripada aluminium. Yang jadi pertanyaan saya sekarang dari pengalaman Bapak-Bapak sebagai desainer, material apa yang menurut Bapak-Bapak lebih ideal untuk digunakan sebagai material fasade bangunan yang lebih ramah lingkungan? Apakah ada pengalaman proyek yang menggunakan material-material itu juga?
Saya kira gini, embodied carbon untuk Indonesia yang paling tepat sebenarnya dari engineer wood ya, atau cross laminated timber. Itu kan kita sekarang banyak sekali beberapa perusahaan yang sudah mulai memproduksi itu. Dan kita tahu bahwa itu kan bisa dapat dari waste ataupun sustainable resources ya. Jadi dari hutan yang memang sudah dilindungi, sudah di-preserve untuk ditanam kembali secara sustainable. Jadi untuk Indonesia saya kira yang paling cocok adalah kayu ataupun bambu gitu ya. Dan kita memang beberapa kota di Indonesia sudah mengaplikasikan itu untuk mengurangi embodied carbon.
Ya waktu itu kita sempat mendesain satu masjid yang tadi nggak pakai fasadnya bolong lah ya, lebih konsentrasi ke atapnya, shadingnya, pakai kayu yang ada dan itu daerah bencana gitu, kayu kelapa yang diolah dan rough gitu ya. Tapi kalau untuk bangunan-bangunan modern memang banyak arahnya ke sustainable timber gitu ya, artinya kayu-kayu yang dibudidaya kemudian diolah jadi bahan bangunan yang kuat gitu. Banyak macam-macam sekarang material-material baru yang pakai natural based solution gitu ya. Kami juga pernah mendesain satu building yang sebenarnya secara operational carbon rendah gitu, termasuk tidak menggunakan BMU karena cuma 20 lantai, orang bisa naik, bisa turun untuk membersihkan bangunannya. Dengan menggunakan dengan ngelihat dari regulasi bahwa kita bisa overstack 1,2 meter itu menghemat banyak sekali, dan kemudian juga memberikan shading yang baik gitu ya. Juga waktu pernah kerja dengan Pak Dion juga untuk satu bangunan yang lain dengan shading yang sebenarnya ukurannya tidak terlalu besar, jadi materialnya bisa dihemat, operational carbonnya turun, embodied carbonnya sendiri karena materialnya tidak banyak juga bisa dikurangi dengan material yang konvensional gitu ya, belum material yang dengan teknologi baru atau CLT dan lain-lain tadi.
Iya, nambahkan aja, tapi emang konsep shading itu sangat penting ya di tropis karena terkait iklim. Jadi secara basis desain yang menarik, shading nggak harus atap miring ya, tapi juga bisa bentukan cantilever, dan itu tinggal mencari material yang pas. Satu sisi juga tadi disampaikan juga ide bagus dengan wood engineering, tapi juga sekarang wood engineering bukan nggak hanya pakai sisa kayu, tapi sekarang ada sisa gabah, saya lupa namanya, tapi itu sangat menarik sekali dan katanya bahkan diproduksinya di sini gitu ya, dan itu tapi sayang masih lagi-lagi biayanya soal itu juga menarik. Jadi itu bisa mengkombinasikan tadi, dan satu sisi juga mungkin bisa kita pakai adalah lokal material yang mungkin kalau keramik kan juga dianggap tinggi ya prosesnya, tapi kalau yang sifatnya batu lokal atau kerawangan apa bahasa Inggris? Itu juga bisa kita bikin satu sisi see-through, bisa jadi real facade juga gitu ya. Itu kan di-create ya, dan sangat lokal banget gitu. Dan sekarang sangat beragam.
Itu aja sih mungkin terkait material. Terima kasih.
Mungkin saya tambahin sedikit, kalau bicara material apa yang paling cocok, nggak ada, menurut saya nggak ada yang one material fits for all gitu. Itu tergantung lagi konteksnya, lokasi bangunannya, kemudian fungsinya. Kita bisa memanfaatkan sumber daya alam apa aja yang ada di sini. Cuma memang tantangannya adalah bagaimana R&D dari material-material lokal itu. Karena biasanya kalau yang available di daerah itu belum tentu standarnya sudah sesuai. Bisa jadi karena belum tersertifikasi dan lain-lain. Jadi tantangannya lebih ke situ, dan selain itu juga persepsi owner atas material tertentu yang biasanya, oh kalau kayu atau batu tuh kayaknya lebih cocok untuk resort. Nah, persepsi atau stigma seperti itu yang biasanya jadi challenge untuk kita mengeksplorasi penggunaan material tertentu di luar dari pakem yang umumnya digunakan. Kira-kira seperti itu.
Tambahan sedikit. Jadi selain material, kita perlu sama-sama mendiskusikan juga dengan supplier nih. Bagaimana dia cara pemasangannya. Supaya, balik lagi nih, supaya dia efisien, kemudian long lasting juga, sehingga nggak perlu banyak keluar biaya maintenance. Nah itu yang perlu kita gali lebih dalam sama suppliernya, gimana sih cara pasangnya yang supaya bagus, efisien, bisa bertahan lama, dan nggak perlu sering maintenance. Begitu Pak.
Makasih Pak. Ini kita udah kehabisan waktu nih, jadi sempat ada, do we have time to ask one question from the audience? Ya. Jadi terima kasih Bapak-Bapak. Kita kalau diterusin waktunya nggak akan cukup nih. Jadi untuk menutup, kira-kira ada pertanyaan dari audiens nggak? Ada yang, silakan Pak. Sembari coba saya tampilkan contoh bangunan yang kemarin barusan kita kerjain. Ini semuanya laminated timber untuk fasade dan strukturnya. Silakan Pak.
Mohon izin duduk saja boleh Pak?
Silakan.
Makasih. Pertama-tama saya salut sama panitia karena usahanya bagus sekali. Kemudian juga biayanya terjangkau Pak. Nama saya Kamarudzaman. Saya itu sama dengan Bapak, arsitek yang kerja di developer Pak. Sehingga pikiran kita sama gitu. Nah saya melihatnya apa yang Bapak sampaikan itu bagus semua Pak. Kagum saya Pak. Karena saya kebetulan arsitek senior, lulusnya tahun 80-an gitu. Sehingga banyak ilmu-ilmu yang saya dapat dari bapak-bapak. Nah sekarang itu saya berpikirnya bagaimana sekarang kan topiknya di pemerintahan Pemprov DKI Jakarta. Sekarang lagi hangat itu masalah polusi. Nah mungkin barangkali kita sebagai arsitek maupun sebagai tenaga ahli di sini ya, artinya ahli itu yang punya pendidikan gitu ya. Bagaimana kita bisa memberikan kontribusi untuk mengatasi polusi. Kita juga udah tahu ada ketentuan dari Pergub DKI ya, ada namanya gedung hijau. Kemudian ada satu lagi yang tahun 2022 baru keluar ya, itu kita harus mengoptimalkan gedung hijau, satu lagi apa ya, mirip-mirip lah itu Pak, itu beda 2 tahun gitu. Nah barangkali saya ingin pendapat Bapak ya, bagaimana caranya kita mencoba menggabungkan fasad yang bisa mengatasi masalah polusi. Karena saya lihat di TV atau di media sosial, pemerintah DKI itu menganjurkan bangunan tinggi menggelontorkan air dari atas gitu. Jadi bagi saya itu tidak akademik dan kasihan gitu. Jadi kalau orang yang di bawah itu, kita lagi di bawah ada air turun gitu. Jadi barangkali kita bisa bersama-sama memberikan kontribusi kepada Pemprov DKI. Karena saya lihat PJ Gubernurnya ini mau menerima Pak, kalau dari Bapak itu memang sudah ahlinya gitu. Demikian Pak dari saya, terima kasih. Mohon maaf kalau ada kata-kata yang salah Pak.
Terima kasih Pak. Coba dari Bapak-Bapak ada yang mau menjawab?
Ya, yang susah-susah biar saya dulu. Ini efek jangka panjang sih Pak. Cuman kita bisa nyalahin juga masalah iklim ya, karena perubahan iklim yang selalu sudah diingatkan oleh Green Building Council juga ya, dan tanggung jawab kita sebagai arsitek untuk mengurangi dampaknya. Yang terkait dengan arsitek sebenarnya dua sumber polusi utama tuh dua sebenarnya. Satu, penggunaan kendaraan bermotor transportasi. Yang kedua PLTU. PLTU siapa sih yang pakai? Ya kita juga gitu loh, manusia juga. PLTU bisa dikonsumsi industri, itu juga sumber polusi. Dikonsumsi juga adalah gedung-gedung. Waktu pandemi kan tetap kualitas udara di Jakarta, terutama saya ngomong Jakarta dulu dah konteksnya. Karena ada 16 PLTU di sekitar Jakarta. Kemudian yang kedua, transportasi. Bagaimana sebenarnya mengurangi secara signifikan ya dengan adanya kebetulan kami banyak terlibat di proyek-proyek MRT yang mendorong orang untuk jalan kaki. Sekarang seperti contohnya di Sarinah, karyanya karya air mas, tapi kami yang terlibat di pembuatan trotoarnya, proyek kecil banget tapi ininya signifikan. Nah buat arsitek atau buat owner apa sebenarnya membuka ground floor-nya, membuka lantai dasarnya supaya mendorong orang lebih mudah untuk jalan kaki. Tadi saya lupa slide-nya siapa ya, Mathieu kalau nggak salah ya, dari DP Facade, memperlihatkan foto di mana tadi, di Metropolitan, Wisma Metropolitan. Kalau dulu orang mau nyebrang jalan itu naik mobil Pak, tahun 90-an gitu ya. Maksud saya lulusan 90-an lah, nggak beda jauh dari Bapak. 90-an tuh masih bisa setengah jam muter Bundaran HI. Sekarang orang dengan nyaman bisa naik MRT ke sana, bisa nyebrang gitu, pedestriannya juga lebar. Banyak yang diimprove dan jangan sampai kota-kota lain besar, Surabaya, Medan, Bandung, mencontoh Jakarta sebagai barometer. Kita harus bikin pola pikir yang beda gitu, membuka ground floor, mengurangi transportasi dengan kendaraan pribadi, perbanyak kendaraan umum yang pakai terutama pakai energi bersih. Kemudian pertanyaannya kenapa Bali bisa udaranya dalam tanda kutip bersih, karena dia mencanangkan tahun 2018 sumber energi bersih gitu ya. Jadi di situ nggak dibangun PLTU, walaupun PLTU-nya di Jawa, ditransmisinya ke Pulau Bali. Tapi di situ sama sekali sebenarnya mereka berusaha mengurangi. Ini efek jangka panjang sih Pak. Kalau dari arsitek tadi tantangannya di fasad, kalau ada bisa fasad yang memfilter tadi dari pakai membran, pakai kaca atau teknologi yang lain, itu akan sangat baik.
Oke, karena saya angkatannya sama. Anak 80 akhir. Gini, yang menarik itu juga bicara polusi nggak hanya melulu buildings ya, tadi udah disampaikan. Jadi benar kalau transportasi itu membantu sekali. Dulu saya pernah di sekitar Sudirman, gimana mulai sejak ada Transjakarta saja itu udah mulai nggak pakai mobil lagi gitu ya, pakai busway gitu istilahnya dulu. Tapi balik lagi ke masalah ini adalah masalah fasad yang secondary skin dengan yang bisa menyerap. Jadi sebenarnya green wall itu sangat bagus. Tapi yang menarik bukan harus green wall yang ada di pasar. Banyak macam strategi sebenarnya. Seperti yang sempat saya lihat di SDE 4 di Singapura itu tanaman rambat sebenarnya. Tapi itu salah satu upaya untuk mengurangi itu. Jadi kita berharap itu bisa menjadi salah satu strategi ya. Jadi mencari material maupun juga ruang-ruang terbuka. Ruang-ruang terbuka diperbanyak. Sekarang Tamrin Sudirman memiliki pedestrian yang cukup besar, menjadi boulevard terpanjang dan mungkin termegah di Asia Tenggara minimal. Itu jadi salah satu strategi. Jadi penambahan vegetasi juga sangat penting gitu ya. Jadi tidak hanya secara di ruang luar, tapi juga di fasad tadi. Itu aja sih. Terima kasih.
Oke.
Terima kasih Bapak-Bapak untuk sharing sessionnya. I think we need to break for lunch.
Yes.
I'm really sorry, my apology on that one. But I would like to thank everyone, the speakers for this session. Welcome back, ladies and gentlemen. I hope everyone have a good break and a good lunch. We are ready to start, so please take your seat. I'm here to introduce our next speaker, Satria Ramadhana. He is the Senior Facade Consultant from Paul Adam Facades and Building Facade Group Indonesia. Pak Satria will be touching on the topic of improving acoustic performance on building facade with the right selection of glass. Please join me on the stage, Pak Satria.
Okay, good afternoon, ladies and gentlemen. Because I saw that the audience is 95% Indonesian. Maybe today in this presentation I would like to use bahasa. Is I think more familiar later on to the audience. Thank you. Baiklah, selamat siang para hadirin sekalian yang sudah berkenan hadir di acara ini. Firstly, thanks a lot also to Zak. He's already invited me and asked me to be a speaker in this session. Pada saat ini, pada momen ini saya akan membawakan sebuah topik yang memang topik ini sedikit menarik dan juga suatu hal yang menjadi hot topic di dunia konstruksi di Indonesia, terutama yaitu mengenai acoustic performance yang nantinya akan menjadi related terhadap kenyamanan dari suatu bangunan. Baiklah, topik pada hari ini yang saya akan bawakan adalah meningkatkan kinerja dari akustik fasad bangunan melalui pemilihan kaca yang tepat. Pada topik ini kita bagi menjadi tiga sub-topik yang diantaranya adalah definisi dari suara dan juga kebisingan, dan keduanya adalah kaitan antara fasad bangunan dengan proteksi akustik, dan yang terakhir adalah mengenai sistem fasad pada bangunan. Dengan berkembangnya perkembangan zaman pada masing-masing era dan juga perkembangan teknologi saat ini, banyak dari perkembangan teknologi tersebut bisa menjadi trigger sebagai polusi suara. Contohnya gambar yang di atas itu nomor 1, 2, dan 3, di mana perkembangan banyak sekali kendaraan di kota-kota besar sehingga menyebabkan heavy traffic, lalu kebisingan pada lifestyle, di mana banyak sih di kota-kota besar sekarang ruang-ruang terbuka ataupun jalan-jalan utama, tempat-tempat utama itu dijadikan suatu tempat seperti panggung dan lain-lain, hingar-bingar, sehingga suaranya itu dapat mengganggu di area di sekitarnya. Dan kemudian diantaranya lagi adalah advance teknologi, di mana banyak pesawat-pesawat terbang itu menggunakan teknologi-teknologi yang menghasilkan suara yang begitu kencang, yang melebihi dari atau akan melebihi dari frekuensi suara yang dapat didengar oleh manusia. Nah, dari perkembangan teknologi tersebut itu menyebabkan selain polusi suara, itu menyebabkan terhadap manusianya sendiri, si pendengarnya sendiri, menjadi seperti hilang dari fokus, lalu kemudian susah untuk tidur karena ribut dan lain-lain, lalu kadang-kadang membuat kecemasan. Nah, dari dua faktor tersebut akhirnya cemas. Dari cemas akhirnya membuat menjadi stres. Seperti itu. Nah, bagaimana sih definisi antara suara dan kebisingan? Pada dasarnya suara itu merupakan suatu getaran. Getaran itu menyebar sehingga membuat sebuah gelombang, dan gelombang itu akan travel terhadap si pendengarnya atau si penerima. Nah, bagaimana dengan noise? Noise sebetulnya suara juga, tapi merupakan suara yang tidak diinginkan sebetulnya, yang dapat mengganggu dari si pendengarnya tersebut. Nah, ini adalah salah satu contoh suara, di mana suara itu dapat dibedakan menjadi suara yang enak didengar atau suara, kalau di bahasa Inggris itu sound ya, ada perbedaan sound dan noise. Nah, kalau di kita kan ada suara dan kebisingan, tapi kebisingan itu merupakan suara juga. Nah, perbedaannya adalah pada gelombang yang dihasilkan. Gelombang yang dihasilkan di sini dari sumber terhadap penerima itu dia cenderung sloping. Jadi antara puncak-puncak dari gelombang itu sangat jauh. Ada perbedaan jauh di situ. Nah, bagaimana dengan noise atau kebisingan? Kebisingan ini gelombangnya itu ketat, sangat ketat sekali. Sehingga antara satu puncak dengan puncak lain itu begitu ketat. Nah, disitulah timbul getaran dan frekuensi yang dihasilkan akan tinggi. Nah, bagaimana kebisingan itu akan menjadi masalah atau suara masalah? Yang pertama adalah masalah kebisingan itu, noise itu bermula dari sumber. Nah, sumbernya itu memiliki frekuensi yang sangat tinggi. Lalu kemudian noise itu ditransmisikan melalui media. Nah, medianya itu bisa saja media udara, air, atau media-media yang lainnya yang merupakan suatu konduktor dari sebuah getaran. Nah, kemudian yang terakhir adalah di mana noise itu dianggap sebagai masalah ketika suara yang begitu tinggi itu menjadi gangguan bagi si penerimanya. Nah, di sini saya tampilkan beberapa level noise yang ini kemudian memang saya diambil dari dari suatu database di sini. Nah, di sini ditampilkan value tingkat dari gelombang kebisingan. Yang pertama yaitu dari yang paling bawah adalah untuk office noise, itu biasanya 60 desibel. Lalu untuk yang heavy traffic itu bisa dari 90 bisa sampai 100 desibel. Tapi di sini masih 90 desibel. Lalu yang paling tinggi adalah untuk space shuttle itu 188 desibel, di mana itu suaranya itu sangat berbahaya. Nah, untuk yang di sini saya memberikan contoh untuk comfortability dari suatu bangunan. Saya ambil contoh adalah residensial, di mana sebetulnya pengaruh comfortability itu dipengaruhi oleh lingkungan sekitarnya, baik lingkungan luar, lingkungan dalam, maupun yang di dalam unit itu sendiri. Contoh lingkungan luar bangunan itu ada traffic jam atau kemacetan, kemudian untuk yang di dalam ruangan itu sendiri ada air conditioning, kemudian untuk di dalam inside suatu bangunan sendiri ada tetangganya atau neighbor, yaitu sebagai internal environmental cultures dan juga faktor-faktor lainnya yang menyebabkan kenyamanan dari suatu area. Nah, bagaimana dengan standar pemerintah, aturan pemerintah? Di Indonesia, saya ambil dari satu contoh, saya ambil dari satu tabel nomor 9, dari halaman 9, SNI 036386 tahun 2000. Nah, di sini disebutkan, untuk rumah tinggal, yaitu tingkat bunyi, maksimum itu untuk saya ambil kamar tidur adalah 30-35 desibel, lalu untuk hotel dan motel, untuk ruang tidurnya adalah 30-35 desibel, lalu untuk hostel, dan apartemen dan asrama itu 45-55 desibel. Itu yang diizinkan. Nah, dikarenakan fasad bangunan sekarang ini 90% itu menggunakan kaca. Nah, bagaimana kaitannya kaca terhadap proteksi terhadap akustik tersebut? Nah, kita lihat di sini ada tabel. Di sini kita lihat ada tabel adalah kombinasi dari insulated dan laminated glass. Ini diambil dari, saya ambil ini data dari database glass manual tahun 90 untuk flat glass, ya. Nah, di sini kita lihat monolithic glass dengan ketebalan 6 dan 12 mili itu mempunyai perbedaan STC value. Yang 6 mili itu 31 desibel, sedangkan yang 12 mili adalah 36 desibel. Begitupun insulated glass, semakin ketebalan kaca semakin tinggi, maka STC value-nya akan semakin tinggi juga. Begitupun dengan gap space di antara kedua kaca inner pane dan outer pane, semakin besar maka proteksi atau resist terhadap suara yang masuk itu akan semakin tinggi. Nah, bagaimana dengan laminated glass? Tentunya laminated glass mempunyai nilai STC yang lebih baik dari insulated glass. Kita lihat di sini. Bagaimana 12, 1,5 PVB, dan 6 mm outside pane-nya dia mempunyai 41 desibel, berbeda dengan yang dengan interlayer yang lebih tipis. Nah, bagaimana dengan double laminated glass atau laminated insulated glass? Dia mempunyai nilai STC yang lebih tinggi. Seperti itu. Nah, lalu ini adalah grafik yang sama diambil dari manual book tadi. Ini dapat terlihat bahwa menggunakan kaca yang tipis, gelombang dari sumber terhadap penerima itu hampir sama, gelombang yang dihasilkannya. Lalu bagaimana dengan yang kaca yang lebih tebal? Dengan menggunakan monolithic glass, basically tidak ada sedikit perbedaan, sangat sedikit perbedaan gelombang yang diterima oleh si penerima dari sumber tersebut. Sehingga proteksi terhadap akustiknya tidak bagus. Nah, bagaimana dengan insulated glass? Nah, di sini saya ambil insulated glass itu dengan perbedaan antara inner pane dengan outer pane, ketebalan dari si kacanya itu sama. Nah, di sini dapat dilihat memang ada sedikit perubahan pada slope-nya, pada slope dari gelombang tersebut, tapi dia berkurang, lebih kecil. Nah, di sini bagaimana dengan salah satunya itu menggunakan kaca yang lebih tebal. Nah, dengan menggunakan kaca yang lebih tebal, sebetulnya itu akan membantu untuk apa? Untuk menahan suara ya ke dalam environment di dalam ruangan tersebut. Nah, bagaimana kita coba dengan memperbesar dari airspace dari insulated glass, di sini dapat terlihat gelombangnya akan semakin kecil. Nah, bagaimana dengan laminated glass? Nah, laminated glass sebetulnya interlayer yang ada pada laminated glass itu dapat bersifat sebagai acoustical interlayer, di mana dia akan menahan suara dari luar ke dalam, sehingga apa? Gelombang yang dihasilkan dan masuk ke si penerima dari gelombang tersebut akan semakin kecil. Begitupun dengan insulating, ini akan lebih bagus hasilnya. Lalu bagaimana dengan double laminated glass? Ya, itu tentunya kita akan consider bahwa suara yang masuk ke dalam itu sangat kecil sekali. Nah, ini adalah grafik yang kita dapat, kurva yang kita lihat, di mana yang 12 mili itu nilai STC-nya lebih bagus daripada yang lebih tipis, dan kemudian untuk yang asimetrik, di mana asymmetric double glazing itu di mana antara inner pane dengan outer pane itu ada perbedaan ketebalan. Nah, di sini dapat kita lihat bahwa grafik yang dihasilkan itu semakin bagus. Walaupun pada titik akhirnya itu sama, tetapi rata-rata yang didapat itu lebih baik. Nah, bagaimana dengan memperbesar gap antara airspace pada insulated glass? Di sini dengan memperbesar itu akan semakin bagus, seperti yang ada pada garis warna pink. Juga laminated glass seperti itu. Nah, ini untuk yang insulated glass versus thicker glass, itu dapat dilihat grafiknya. Dan bagaimana juga yang terakhir, itu grafik nomor 4, di mana menggunakan dari normal air dan menggunakan gas lainnya, selain gas udara biasa. Seperti itu, dia akan lebih bagus secara rata-rata. Nah, hubungan antara kaca dan reduksi suara, yaitu yang pertama adalah menggunakan kaca yang lebih tebal. Lalu menggunakan kaca yang laminated glass. Lalu di dalamnya kita menggunakan acoustic interlayer, yang pada sebetulnya dengan menggunakan interlayer biasa juga sudah bagus, tapi dengan acoustic interlayer akan lebih bagus sebetulnya. Lalu menggunakan kaca yang tidak sama ketebalannya atau not symmetrical glass combination di situ. Lalu memperbesar menaikkan jarak si insulation atau gap pada insulation glass. Lalu yang kemudian kita menggunakan gas pada area airspace dari insulated glass. Nah, faktor-faktor yang tidak berpengaruh terhadap performa akustik adalah ya tentunya warna kaca sangat tidak berpengaruh, lalu coating, reflektif atau low E juga itu tidak berpengaruh terhadap proteksi akustik atau meningkatkan akustik performance. Kemudian posisi dari kaca itu juga tidak berpengaruh. Heat treating atau heat tempering atau tempering proses itu juga tidak berpengaruh terhadap acoustical performance. Untuk anneal glass dari berbagai atau raw glass material dari beberapa supplier juga itu tidak berpengaruh antara supplier satu dan yang lainnya. Seperti itu. Nah, bagaimana dengan sistem fasad? Ini hal yang menarik. Nah, di sini kita lihat ada 1, 2, 3 contoh sistem fasad yang ini memang kita develop, yang saya rasa dan kita rasa ini adalah salah satu solusi terbaik atau penggunaan sistem fasad terbaik untuk meningkatkan performance akustiknya. Di mana di sini kita menggunakan kaca double laminated, di mana inner pane-nya menggunakan kaca monolithic glass, lalu yang outer pane-nya kita menggunakan kaca laminated glass. Di mana di sini ketika ada sumber suara masuk ke dalam itu sudah tertahan oleh yang pertama adalah oleh laminated glass dan interlayernya tersebut. Lalu ketika masuk ke dalam airspace, gelombang yang dihasilkan akan lebih berkurang di situ, sehingga akhirnya ketika finalnya ketika ada gelombang masuk ke dalam ruangan atau ke si penerima itu akan lebih kecil sekali. Nah, lalu yang kedua, detail yang kedua di sini dilihat bahwa bagaimana kita membuat detailing fasad di area partisi. Nah, di area partisi tersebut aluminium frame kita tutup atau selubungi dengan insulation, di mana di dalamnya ada aspek insulation ataupun ada fireboard. Nah, di mana sebetulnya untuk sebagai highlight aja, fireboard itu ide dari awal atau fungsi dari awal itu adalah sebagai untuk fire rated. Tetapi dengan waktu yang sama, dia akan bekerja sebagai acoustical protection. Nah, begitupun sama detail yang ketiga, halnya sama dengan detail yang kedua. Nah, bagaimana dengan horizontal protection? Nah, di sini kita punya 2 insulation. Yang pertama thermal insulation, yang kedua adalah fire barrier. Nah, kembali saya highlight, thermal insulation berfungsi sebagai thermal. Itu fungsi awalnya. Dan fungsi yang kedua, fire barrier sebagai fungsi awalnya adalah sebagai fire protection. Nah, tetapi di waktu yang sama, dia akan berfungsi sebagai acoustical protection juga. Seperti itu. Nah, ketika kita bicara, kita desain fasad, sistem bangunan, sistem fasadnya bagus dan lain-lain, tetapi itu tidak menjamin, bukan tidak menjamin, kita tidak tahu apakah itu berfungsi dengan baik atau tidak. Untuk make sure bahwa sistem kita itu bagus secara performa akustiknya, maka kita rekomendasikan sistem tersebut untuk dilakukan tes. Nah, ini salah satu tesnya yang dilakukan, salah satu contohnya adalah di mana ini untuk testing fasad ya. Di mana di situ ada noise source room, di mana itu sebagai sumbernya, lalu di situ ada fasad sebagai test sampelnya, lalu ada receiving room dan kemudian ada control room. Nah, control room di sini akan mengontrol berapa desibel yang akan digunakan pada ketika tes tersebut. Nah, tujuan utama sebetulnya dari ini untuk dilakukannya testing ini adalah yang pertama adalah apakah kita bisa mencapai target dari regulasi yang sudah dipaparkan tadi dari SNI nomor 3 tahun 2000 tersebut. Lalu selain pengujian itu adalah untuk memvalidasi apakah ada pilihan alternatif tidak selain ini. Misalkan ketika dites ternyata hasilnya lebih bagus sekali. Nah, kita bisa VI enggak supaya bisa mengurangi itu. Nah, itu salah satu di antaranya kenapa kita melakukan tes dari fasad. Tes akustik di fasad ya. Lalu acuan standar yang digunakan dalam testing tersebut kita menggunakan ASTM E90 part 4, lalu kita menggunakan ASTM E413 part 4, atau kita melakukan IN ISO 10848 part 3, lalu IN ISO 140 part 1. Inilah acuan standar pengetesan dari akustik untuk fasad. Nah, ini adalah salah satu contoh hasil dari pengetesan. Ini adalah salah satu contoh grafik yang kita dapatkan ketika kita melakukan testing fasad. Kebetulan ini salah satu proyek kita juga dari Paul Adam Facade dan BFG. Ini ada di Indonesia dan kita tes ini di Singapura. Ini adalah tes yang dihasilkan bahwa sistem fasad kita itu dapat menghasilkan 37 desibel. Nah, ini adalah salah satu contoh bagaimana kita melakukan tes. Ini jika kita lihat dari eksternal fasad, di sini ada source dan di situ ada fasad, ada permukaan luar fasad. Lalu yang kedua adalah ada internal face-nya. Kesimpulan dari ini mungkin agak cepat ya karena saya cuma punya waktu 20 sampai 25 menit, nggak bisa menerangkan lebih banyak. Kita ambil saja kesimpulan dari slide-slide yang sebelumnya tadi, bahwa untuk meningkatkan performance akustik dari fasad, yang pertama adalah digunakannya kaca yang lebih tebal, atau kaca tersebut dikomunikasikan atau menggunakan kaca yang asimetrik. Lalu dalam pengkondisian menggunakan kombinasi ketebalan kaca yang berbeda, yang tadi saya sebutkan seperti yang tadi ada asimetrik. Lalu yang ketiga adalah proses sealingnya seperti apa, proses penyegelan atau sealingnya seperti apa. Karena apapun juga, ketika kualitas dari insulationnya bagus, sesuatunya bagus, tetapi proses sealingnya jelek, tetap kaca itu suara atau itu akan tembus ke dalam. Lalu bagaimana dengan yang lainnya adalah untuk mendapatkan performance STC 40 itu akan mudah sebetulnya. Nah, tetapi 45 akan sedikit sulit. Lalu untuk yang STC 45 mungkin kita harus menggunakan double layer atau double skin facade. Itu akan lebih efektif untuk dapat menggunakan STC 45. Nah, mungkin ada salah satu yang ke-8, tidak saya cantumkan di sini, adalah untuk mereduksi suara yang masuk ke dalam dari luar, itu sebetulnya jangan dilihat dari fasad itu sendiri. Karena fasad itu sendiri mempunyai limitasi dia untuk menahan suara. Tetapi kita harus melihat bahan-bahan atau material-material di sekitarnya. Contoh misalkan kita menggunakan karton, itu sangat efektif juga untuk menahan suara dari luar ke dalam. Ataupun misalkan kita mempunyai lemari-lemari di sekitar, terus ada buku-buku di sekitar, itu sebetulnya dapat berpengaruh juga untuk mereduksi suara ke dalam ruangan tersebut. Baiklah, terima kasih. Sekian presentasi dari saya. Selamat siang. Mungkin ada pertanyaan di sini? Masih ada 2 menit. We still have 2 minutes, right? So is there any question? Kalau enggak ya, terima kasih. Selamat siang. Ya.
Our next speaker is Dr. Chengde Huang. He is the Technical Director of CSG. He'll be touching the topic in application of high-performance glass to reduce carbon emission. Round big applause, welcome for Dr. Huang.
Good afternoon, everybody. I'm talking about application of a high-performance glass to reduce the carbon emission in 3 parts. China says the two common goals, the peak carbon emission 2030 and carbon neutrality 2060. As the statistical data show that, in China, the whole cycle carbon emission of buildings accounts for over 50% of the total emission of China. Production of building materials accounts for 28%. The building construction accounts for about 1%. And building operation accounts for about 22%. So lower the carbon emission of buildings is crucial to two common goals. To do this, China has implemented new code, building code called the General Code for Energy Efficiency and Renewable Energy Application in Buildings. In this new code, besides the higher energy efficiency requirement, there's stipulated specific requirement on the carbon emission. In 2019, China implemented a national code called Standard for Building Carbon Emission Calculation in 2019. In this code, the detailed calculation procedures are specified and the necessary basic data is listed in the standard. Now, as the leading low-E glass manufacturer in China, CSG has been promoting market across China from north to south for high-performance glass for buildings to reduce the carbon emission. As everybody knows, in different climate zones, you need different glass performance to do the best to reduce the carbon emission during operation. For example, in Beijing, in the hot summer days, it could get about 43 degrees. But in the winter, you could get about minus 10 degrees, something like that. So in summer and in winters, need different. For some time in Beijing, the triple ceramic glass is good enough to prevent the thermal heat, some air from coming inside. But in the winter, we need an additional coating to lower the U values for the winter time to save the energy. But in the South China cities like Guangzhou, Shenzhen, because it's got a warmer winter, so triple ceramic glass alone is good enough for energy efficiency of buildings, because in the winter the U value is not so important, but in the summer times you need the high performance glass to prevent the thermal heat, some air from coming inside. So triple ceramic alone could do the best good job to reduce any carbon emission buildings in southern China cities. This here are some typical glass performance data for like in Beijing and northern China. We apply the triple ceramic coatings on the second surface and apply additional interior surface low coatings on the number 4 surface. In this way, you can, for the in the summer. Actually, right now in the when we're doing projects, always specify glass performance by G value, shading coefficient. But actually, the G or shading coefficient is not precise enough. Many times you use G or shading coefficient could get misleading, get the wrong decisions. So we define a new term called GIR. GIR different from the G. The G accounts for the total energy, including the ultraviolet, visible, and the solar air. GIR only accounts for the air, solar air, how much the solar air is coming inside, because solar air is the energy constantly increase, not the visible light. Visible light is we need for daylight, and the visible light does not cause much, temporary increase. So we define new term GIR. With triple ceramic coatings, you can get a GIR on the 3%. That means only 3% of solar air could come inside. You get a cool inside, This typical glass is used for typically in Beijing projects. You can see that we use triple ceramic coating to lower the solar air, the transmittance, and we apply additional coating, interior coating called BW88 on the number 4 surface to lower U values. In this way, you can get the U value about 1.1. That's for double glazing. Of course, for some projects need a high requirement, could use the triple glazing. With triple glazing, we can even use the triple glazing with 3 coatings. In that case, we can lower U value to about 0.6. This 3 glass, typical glasses, just the triple ceramic glass for the southern China cities. So you get a hot summer and a warm winter. So triple ceramic alone is good enough. So you can see the data. No matter the visible light transmittance, no matter the color, no matter the brightness, you could get the GIR. That means total transmittance of the solar air only about 3%. So for a triple ceramic glass, actually when you consider the cool of the rooms inside and consider the air conditioners, you do not need to consider the G value. Actually, the G value only means that the visible light. You can say the higher visible light, the higher G values, but it does not mean you get a higher G values. It's hot inside. Actually, it's cool because you can GR. All of the GR is about 3%. That means only about 3% of solar heat comes inside. Because you know, when we're doing projects, like many years ago, you know, when do like many people want to skylight, they specify very low G values. For example, I made some many projects actually because I worked in this area for more than 20 years. And some projects with skylight, they need the G values below 0.1%. Below 0.1% does not mean it's not hot, but this means that the visible, not much visible light. That's a problem. So for triple Severely gas, actually you can get you can choose the visible light transmit according to requirement. Because the higher visible light does not mean the heat. The only visible light comes including back outside. Just for day night. And across the world, actually, right now in many other codes, you can see something here, discrepancies, because in some of the codes, the national codes, even national codes, they call the near zero or zero energy buildings, consumption buildings. But in that kind of code, they specify glass requirement for like the tropical, the weather condition like here. It's hot in the summer, but it's not cold, not cold in the winter. It's a warmer winter. In that kind of code, they always specify G values, like for example, lower than 0.15. If for G values below 0.15, that means in the window the daylight is not enough, and the inside is not bright. You probably need the electricity lamps, but the electricity lamps consumes energy, consumes electricity. That causes carbon emission. Why we need why we do not use triple Severely glass to let the visible sunlight comes inside the free and low cost, and you could save energy inside. So the G values, nowadays if G values is not really precise, not really. We need to consider more, what kind of energy we need, what kind of cost temperature increase. So G values always get confused, probably get misleading, leads into wrong decisions. We roughly calculated for carbon emission for the high performance for different regions. Roughly speaking, compared for the clear glass AGU, clear glass AGU means low coatings. For double Severely coatings, the additional reduction of carbon emission with per square meters of glass, the glass on the window per year. Double Severely coatings could reduce 25 to 35 kilograms of carbon emission. For triple Severely, could get about 30 or 40, about 30 or 40 is the carbon emissions. So triple Severely coatings is the best right now commercially available in the world market. It's the best triple Severely. This is just sure of glass samples against some plans and colors. Just to show you the transmitting. I mean, where our glass is very clear. You see the outside colors and very natural colors. And for the spandrel, we use the frit to achieve a perfect match between the spandrel and the vision glass. You can see here that this was a spandrel, this is a vision. You can see this is a very perfect match. We just apply the frit on the number 3 surface of the AGU to lower the the light behind the spandrel, so make it a perfect match. And we also do the BIP glass, for spandrel or even for vision glass. We can change the visible transmittance, the visible light transmittance according to requirement. And this is just a few projects we have done with the BIP glass. And then because of a very short time, I just show you some of the projects we've done. This one's in Beijing. triple Savory plus the interior surface layer coatings. It's good in summer and it's also good in the winter times. This is another one. This is different colors and different appearance, different look. This is one triple Savory coatings, green colors. From outside, it's say green. You can see the spandrel and the visions are a perfect match. And from inside out, it's clear. Only outside is colored green because we use the layer coatings to make our colors. It's not tinted colors. This one is light blue. This one neutral colors. It's gray and neutral colors. So you have many different colors according to project requirement because we sell actually the triple Savory glass across the world in different regions. So different projects need different colors, different brightness. Every day you play with the colors. This is another one. And also on the years we do projects, we also made some jumbo size IGUs. You here just list of the summer projects we have done with IGU height over 10 meters, width about 3 meters. This is just a few examples here. You can see the glass. This glass is about 11 meters. This one is, I think this one is in Abu Dhabi, in UAE, the project. You could see the image, reflect image. It's very clear. So because of our short time, that's all of my talk. Thank you.
Thank you, Dr. Huang. Joining me on stage next is Sumit Banerjee, Sales and Marketing Manager, High Performance Product from Kurare. He'll be touching on the subject inspiring laminated glass application with advanced interlayers.
Hello. Hello, good afternoon, everyone. Myself, Sumit Banerjee. Thanks for the introduction, for a very nice introduction. And it's for the first time I'm in Indonesia. I'm based out of Mumbai, India. Not a very different place than Jakarta, so I can easily say that I'm feeling at home here in many ways. So thanks, Zach, to give us an opportunity to present about the inspiring laminated glass applications with advanced interlayers. And this is going to be the outline of my presentation today. I'll have a little bit of an introduction of what are the products we are dealing with, structural glass applications, forced entry and bullet resistance BRG applications, and I'll touch upon Kurare sustainability goals, but this is something which is a subject which has been talked about a lot since morning, and we are on the similar ground. So I think that's a common frame. A little bit of our introduction. We in Kurare are the interlayer manufacturer, the leading interlayer manufacturers, which can be used for any kind of laminated glasses application possible, be it safety, be it related to decorative, be it acoustic, structural and security, which includes a lot of products where we are really specialized with. Specialized applications like certain applications where you need to block UV radiation, where you need to allow 100% UV radiation, all sort of applications. We do have the products for that. We keep on developing new products. We have we have a very huge share of all the specialized laminated glasses where it comes to automotive application and transportation applications. We are the one who are working very closely with companies like Tesla, Mercedes, and all the benchmarking companies in the world. Recycle and sustainability, we are developing new products like Duracide G and Trossifoil Renew, which is the last one, which I'm going to talk about it in the later slides. Moving on. So today we are going to first discuss about the structural and the security applications of our products, and the last one will be recycle and sustainability. Moving further, glass is a fantastic material, need not to say that, because that's the reason we are here for, and everybody is here because of the glass and the glass facade application. It looks beautiful. It makes our urban design looks much amazing, much clean, much neat. The skylines have changed over the years because of the use of the glass. So glass is something which we are not going to, we are just going to love, and we are here there for that. But as you can see, sometimes it breaks. We know that the glass breaks. The glass breakage can happen. It's a fragile material at the end of the day. But in Kurare, we have categorized the safety glass. We are especially talking about the safety and the structural glass. And we have categorized based on the three segments. One is annealed glass, the other one is tempered glass, and the last one is laminated glass. The tempered glass and the annealed glass and the laminated glass has been classified or has been categorized based on to mitigate the risk when the glass really fails, the glass breaks, and the glass shards fall on somebody to create an injury. So when we see an annealed glass, the annealed glasses are the glasses which breaks into bigger shards. When it fails, it can really hurt someone. The tempered glasses were formerly known as the safety glass. They're still in couple of codes, they are called safety glasses. These glasses can be heat tempered glass or heat strengthened glass or a fully tempered glass. They break into the patterns which are like small shards, but even if they fall from a certain height, they can gain a kinetic energy to injure somebody very easily. The laminated glasses, the last one may crack under pressure, but tend to remain integral adhering to the plastic vinyl interlayer, which is actually kind of bonding that. So laminated safety glass among the three can be easily said that the most common or the most efficient safety glasses. Moving further, what is a laminated glass? A laminated glass is nothing but it is a sandwich of a glass, an interlayer, and a glass, possibly hot rolled, hot tempered, vacuum bag tempered, or they have been joined together with different means and ways. And the glass retention, the basic function of a laminated glass is to retain the glass if the glass breakage happens, if the glass shards fall, or if the glass pieces fall on someone. So that's the basic purpose of a laminated glass. Now, what is a structural laminated glass? We are talking about a structural laminated glass. Structural laminated glasses are the interlayers which can perform in a way which can hold the glass, which can make the glass more safe and structurally strong. So something which makes the glass strong and safe, the interlayer, is called a structural glass. There are basically two types of interlayers. The polyvinyl butyl, which is known as PVB. Our brand is Tossifol PVB. It's already mentioned here. And the second one is Ionomer or Ionoplast, which is very, very famously known as Sentry Glass or Sentry Glass Extra. There is nothing like SGP. We don't say that SGP, it's not a trademark product or it's not a registered product, SGP. So please mention Sentry Glass whenever you have to mention. So Sentry Glass interlayers, what is different with Sentry Glass interlayers? Sentry Glass interlayers are 100 times more stronger and 5 times more tear resistant than the normal PVB, that is normal polyvinyl butyl. And it functions well at the elevated temperatures. So when you're using a structural interlayer at certain applications, you are actually, reinforcing the glass, reinforcing the laminated glass, and at the end of the day, making it more strong and vivid for various applications like bigger glass panels, like curved glasses, like glass bridges, the canopy applications, which can be used as bigger glass panels by use of the structural interlayer. Moving on, when to use, what to use. So I have just made a category of the structural interlayers we have. So we can offer two structural interlayers. That is, one is Ionoplast, that is Sentry Glass, and the second one is Tossifol Extra Stiff PVB. The second one, the base product is PVB. The first one is Ionoplast. Now, talking about Ionoplast, that is Sentry Glass. It's the structural pros breakage strength is 100 times. It's 100 times higher than the normal PVB, even at elevated temperatures. The basic measure for this is Young's modulus of any product at a particular temperature under a certain amount of load. So Sentry Glass can easily take temperatures, design temperatures of 50 degrees and above. Very easily it can take, and it can still perform even at those elevated temperatures equally good. Excellent exposed open edge durability. So Sentry Glass is an interlayer which is non-hygroscopic in nature. It can be used in open edge applications. It can be used for applications which are minimally supported. It can be used with applications where you need not to cover the edges of the glass with any kind of product to look at aesthetically beautiful. And sealant compatibility is best with Sentry Glass because Sentry Glass is an interlayer which does not have the plasticizers, and plasticizers and sealants are like life-threatening enemies in glass industry. So of course, Sentry Glass actually provides a good sealant compatibility. Transparency and clarity. The yellowness index of Sentry Glass is the best in the world. It's less than 1.5. So it has got it's the most clear interlayer in the world. So in case you're planning to use any extra clear glass or a low iron glass, this is the product of your choice. Now we come to the extra stiff PVB. Now extra stiff PVB is an intermediate product which is between PVB and Sentry Glass. And you can very easily say the design temperatures are up to only 30 degrees centigrade. So it has a design limitation that you can be used for interior applications which are temperature controlled. It can't be used in open edge application. We don't recommend at this moment. We are working on some new products. Very soon we will be coming up with an ES which can be open edge, which can be used in open edge applications as well. But as of now, it cannot be used in open edge application. It's the second best choice after Sentry Glass because it is a low cost option, and there can be some cost benefit analysis which can be done for using this kind of products. Yeah, these are a few examples of structural of the structural interlayers being used in certain applications. This is one of the very old application of which is there at the Apple Store in New York. This is again on the top NYC, New York, USA. You can see it's almost more than 3 meters of the glass span, and it's a freestanding just because it is laminated with Sentry glass, 2.28 thick. This person is there for the reference. This is the most common and the most famous project of ours, that is Grand Canyon Skywalk. At a time, 120 people can even stand on the glass surface, even if all the glass surfaces are broken. This is a multi-layer laminated project, and even the railings are, we can see, even the, we have done with, the railings are with PVB, which is Trossifol B200, and the glass floor is done with Sentry glass, with the use of Sentry glass, multi-layers. This is from my place, Mumbai. This is a very beautiful bar. Again, freestanding open edge application in a place called like Mumbai, which is very high at humidity, which is very high at salt content. Moving forward, now this is a skydeck application of Los Angeles. This is a small video which can be seen. Yeah. There are no sound here. So yeah, even I felt like going to LA because of this. Not only because of this, but the fun part was that was used with an extra clear glass so that you can have a proper clear visibility. It was designed against the load so that a lot of glasses are not being used, minimal length, minimum use of the glass so that you can have the clear visibility as well as structural strength. So it was designed. This is an amazing project of ours, which is like almost a 400-meter long glass bridge. You can see, I mean, again, on one of the mega projects in China. This is a beautiful project from China. You can see the kind of testings they have done at that point in time, the laminated glasses. One of my favorite projects, that is Mahanakan project and the Skywalk in Bangkok. I have been there very recently and just an amazing place to be. Must visit, the Pixel Tower. This is one of the very recent projects, again in New York City. It's an observatory lab, and it looks beautiful in the evenings. Yeah. So, sorry, it's 15 minutes only. We have to be a little quick. I can have a lot of pictures, but I have limited that. Now we go to the forced entry and the bullet-resistant glass applications. Now, unfortunately, in last two decades, we have seen that terrorism, war, these kind of conflicts have increased over the world, and the easiest breakages of any kind of blast or bullet applications are the places with the glass, because glass has got the minimum resistance towards bullets and all that. Not only terrorism, but you can see the cases of the riots, people getting very angry these days for whatever reason, but they really, whenever there is some conflict, they start breaking and building the projects. So you can see these are the reasons that, I mean, this has been classified between forced entry, burglar resistant, and ballistic applications. You can see the security hazards from the man-made threats have been categorized into three categories. One is the forced entry, which is robbery, theft to property, riots, terrorism, residential, commercial, escape from prisons. Even the prisons are now these days using glasses. So yeah, escape from prison is also there. Displays, material damage and theft. Big firearm attack. You know what big firearm attack is? Use of any kind of armors. Bomb blast explosion. You can see that's the one which happened in Lebanon. There was no attack, but they have kept the explosive material. They could not handle it properly, and that's the cause of it. So the purpose of having a glass or a safety glass is basically to mitigate the risk which can be caused due to these kind of applications. So there are certain codes which has been designed by Europe and US codes. The European code is EN 356, and it's the category of the threats are between P1A till P8B. P1A to P5B is a low threat, which can be more like an anti-vandal, whereas the high security one is above P6B to P5B. US is using 1233 ASTM-F, and it's not only the glass which can actually stop the system, so stop any kind of threat. So the system has to also be decided, and that is there. You can see there are the US codes and the US codes, and the European codes are already mentioned here. not only these they have actually categorized based on the different kind of impacts. There are blunt impacts which can be used by sledgehammers, pipes, extinguisher, propane burners. So they have designed the criteria or the passing criteria of something like a contraband when it's like 3.1 kind of a diameter rod should not pass from a particular set of the glass, or in the body no opening that allows the passage of a 203 by 203 kind of a object. So these are the categories you can see. This is again an example of a forced entry. Yeah, so this again happens in New York. Everything happens in New York, it looks like. So so yeah, this happens in New York, and yeah, they have faced something like this. Anyways, moving further. So this is a testing with the ballistic codes. These are new ballistic codes which have been designed. It's very sad to know that this code has been designed keeping the school threats in mind in US these days. So there are a lot of new codes under discussion and under for that. Yeah. So this chart actually represents the kind of the EN standards, which is BR1 to BR7. The categories has been designed based on the kind of ammunition being used to create that threat. You can get these details in our website. All the glass constructions are also there, which can be tested accordingly. Similarly, in US, they use National Institute of Justice, that is NIJ level threats, and the UL level threats. Further. So what is the advantage with curare products or the trossifoil products? Because the traditional products, with the traditional solutions, are very thick. They are not very durable. They have got scratch issues and all like these kind of stuff. So with curare products, you can actually avoid that. We have a product which is called CPET, which can be used as an anti-spall or a no-spall application, and you can't scratch it because they are coated, and it has got a very long-lasting life. Just to highlight that how much of a weight we can save for a certain application versus the traditional. So we are very happy to help you with the glass combinations. In case if you need, please reach us. We'll be able to help you with the glass combinations. This slide, yeah, this is again a bullet testing slide, but this is more like a anti-spall presentation. I mean, the anti-spall is basically a film which is at the end of the glass. Because of the bullet penetration, that glass shard can fall on you. But just because we are having a no spall application with just 2 minutes more, you want more? So, anyways, so spall shield is a product which actually mitigates the risk of the falling glass shards. So we have done these testings. I'll have to flip through, unfortunately. Yeah, now we can see the basic results of the test is that even polycarbonate, Sentry Glass SG Extra, and Sentry Glass, they all perform almost similar to each other when it comes to the bullet penetration. So all this precisely qualifies for those kind of applications. I will be very quick with the sustainability goals. We all know that the temperatures are increasing, the sea level is rising, and all that. And the primary reason of the increase of the carbon footprints across the globe is again US and China play the major role. You can see they are the most one who are contributing on the CO2 emissions. So curare sustainability goals are also based on this. My existing emissions are approximately 3,230 kilotons per year, whereas what we target to reduce it by 30% by 2030, and we are taking measures to get net zero carbon emissions by 2050. These the primary criteria are the scope of the byproducts, the scope of in-house power generation, and the purchase of energy. These are the criteria we are working on. Apart from that, we have a lot of consultants on board who are actually trying to help us to design how we can recycle the used laminated glass. We can take the glasses, we can take the glass to reuse, we can actually take the interlayer to reuse in future as well. So that's all from my side. I mean, this is all the same thing which I've just spoke about. And yeah, this is what we are existingly working on, which I'm actually talking. We are trying to remove the interlayers from the laminated glass and try to recycle. So reduce, reuse, and I think recycle. That was something which I heard today morning, and that's something which got stuck to me, but that's exactly what we are doing. Thank you for your time. Thank you for your patience. I took a little bit of additional time. Thank you. Please visit our booth in case if you have any questions. We'll be happy to help you. Thank you so much.
Is everyone still with me? I'm very glad that we still have a full room, very close to 3 p.m. in the afternoon. We started at, 9? So while my colleague Shraddha is preparing for the next presentation, so throughout the day, we heard from 20 plus speakers. They've gone through a lot of interesting projects, a lot of interesting development. We learned about a lot of new technology, new materials available to adorn our building, our facade. And of course, sustainability is always take a center stage of any discussion, any projects, any regulation is being put together. So, but then like, what's next? That's always the question, right? So what's next is a presentation coming from Jayrold. I don't know if you remember me. We've done a lot of webinar in the past. Of course, I do remember. I'm moderating like two, 3 or 4 webinar with Jayrold during the pandemic. And then I'm glad to finally meet you in person now in Jakarta.
Thank you.
We good? Yeah. Okay, so without further ado, I welcome Jayrold Bautista, Associate Tech Services and Development Scientist for Dow Asia Pacific.
Thank you very much. Oh, sorry, no, it's here. All right, hey, good afternoon, everyone. I know it's that time of the day where everyone really feels tired, but I do hope you can spare me some of your energy today. Thank you very much for that introduction, and yeah, I think it's a good time again to see everyone. It's the screen for the last time I was here was back in 2019, and then COVID hit, and everything was done via the Zoom webinars. And it's good to see faces again. It's good to see everyone here again. Today, my presentation is going to be something about, I hope we can all relate. It's going to be about the seismic performance of silicon bonded facade. So in Jakarta or in Indonesia in general, I know earthquakes are not alien to you. You know that. I think we all have our fair share of our earthquake experience. I'm from the Philippines, and we have a lot of that. So we're better than you guys because we even have typhoons, right? I had my fair share of one of the strongest earthquakes in the Philippines. Back in 1990, wow, I'm old. Back in 1990, we experienced one of the strongest earthquake in the Philippines, 7.7, and my place was literally just very near where the epicenter happened. So that was, I will always have a fresh recollection of that. And you can all agree, seismic events, earthquakes are terrifying. And in this presentation, I hope I can give light on how do facades with silicon bonding actually work during those seismic events. Silicons, that's what bonds your glass to the frame for your structural glazing sealants. Silicons have very good movement capability. That's because of the polymer. I mean, the picture that you can see on this side, that's the science around it. But basically, what it's just trying to say is it has very good movement capabilities. And movement capabilities are very important when it comes to handling seismic loads and seismic movements. And typically, the critical ones that you'll have will be when your curtain wall or your facade will move swaying this way, just this way. And the other one is racking. There's a little bit of rotation. That's what you're going to have. You'll have other movements wherein it's going to move out of plane, but these in-plane movements are the most critical ones when it comes to earthquake loads for your facade. Now, there were studies done before already. So as you can see, this was back in 2011. This was published, but the study was much earlier than that. And we've done some studies. This study done by Dow, and what we have here is a mock-up where you can see there is a camera at the bottom of that video wherein we check movements, the sway condition, we have the racking condition with the vertical slip, and then also just a racking condition wherein you're not allowing the panel to rotate. So typically in our seismic, our facade design, this is the condition that you'll have, and you'll have a facade design that you may allow to rotate, or sometimes you may not allow to rotate. So that's the camera over there. So what is happening there? That's what's happening there. That's how that corner there is actually moving when there's earthquake. So it doesn't seem a lot, or you probably are not looking at it, because that would be weird, that if there's an earthquake and you're observing a facade panel, an actual earthquake, and you're looking at the facade panel, but that's how it looks like. That's how much movement you may have on your facade. So you should have, your system should be able to take care of that, especially your silicon, or else you may have a glass fallout. That's what we're trying to avoid, a glass fallout. After that study, Next studies were done. So the advent of the use of computer models help us predict what may happen in a seismic event. It's really expensive to do mock-ups just to think of what's going to happen or see what's going to happen on a facade. So we try to do some computer models. Fortunately, computers are getting advanced. We're able to do that now, and we're able to have better models for our sealants to put them into the computer so that we will be able to see, even just from that simulation, where are the critical areas. These were the different studies here that was done. So there was a small scale testing. There's a hyperelastic material modeling to get that the constants for your computer. And then we had the large scale testing. And now we're at the failure analysis stage. And then later on, the data that we're going to get there, we're again going to put that into the computer, refine our data. Now, so the next slide will show the results of a study or a current research that Dow is also involved. It is done by just other entities here, TU Delft, Sapienza, Dow, Perma Silisa Group, and this initiative by the European government, seismic safety and energy efficiency. So it's a series of studies, and we've done the 1, 2, 3. There, we are already on number 4, and I'm going to share with you what's happening on number 4, or the preliminary results that we get on that failure analysis or the damage mechanisms of facade systems. This was the study, so there were computer models done first before we do the actual mock-up, so that is going to be, we know where we are going to be looking at when we do the mock-up itself. There were 2 panels investigated, one a little bit smaller, one a little bit larger, but they're both the same width. And then the aspect ratios that you see here and the dimensions that you see, that's the sealant. That's the sealant bite and the glue line. So 9 mm by 9 mm, 20 mm by 9 mm, and then 27 by 9 mm. Then, of course, we're going to be using a frame. This is a unitized panel that we're looking at here. And then this is the test plan in terms of what kind of loading are we going to put into the mock-up. So there's a time history. This is based on previous big earthquakes. There are 3, Friuli, Umbria Marche, and then the Christchurch earthquake. Then we have the crescendo sequence, wherein it's a small movement first, and then increasing over time. And then we have the quasi-static or the monotonic sequence, just one movement, but going there little by little. This is the result of that in terms of how did we put that into the computer. So there are some caveats here, or there are some simplifications because we just want to concentrate on the silicon sealants themselves. So as you can see, there are 2 cases. One wherein we're allowing the rotation of the panel, the other one where we are not allowing the rotation of that panel in our computer models. This is the result. So you can see, you can see some gradients here, but I want you to focus on the most right here, on the rightmost part of this screen on relative to when you're looking at it. If your panel is not allowed to move, the sealant will have a strain of 175%. That's a very big strain. Okay? But if you allow your panel, or you design your panel that it is rotating, the sealant strain is very small, 7%. That's a huge difference. So what does that mean for your projects? Hopefully your projects were designed to allow the panels to move or to have some rotations, to have some flexibility in them. So this is a detailed drawing. Based on that, we realized that these are the critical sizes of the panel. The smaller one is what we're going to do as an actual panel. And then we have all these different sizes of the sealant, the 27 by 9, 9 by 9. Those are the different panels, or the different bite sizes. So those are the different configuration. That's the actual test. This is what we're trying to do. Sequence number 1, there's a Friuli earthquake, Christchurch earthquake, then we have the crescendo sequence as well. And then if failure did not happen, we're going to do a study again. So what we found in this flexible frame, 9x9 sealant, there's no damage at all in the sealant. Even if we push it to the very big movement, no damage to the sealant at all. So what did we do? There's no damage. Let's just induce damage. So what we did is we cut the sealant. So as you can see from here, we want to understand crack propagation. If there's, let's just say, a scenario wherein there's a crack in the sealant because of this, what will happen to the crack? And this is what we found out. So as you can see, this is the sequence again. We continue it. We cut the silicon 15 mm, then we make it move. 15 mm again, we make it move. 15 mm again, we make the panel move again. And these are the results. Okay? Failure only occurred after 80% of the sealant was cut. And that is something reassuring because we were worried that once you have a crack on the sealant and the earthquake continues, it's just gonna go. It will not really go. Instead, for us to be able to increase that crack or to make it propagate, we actually have to do it ourselves. We have to cut it ourselves. And it only happened that there's a failure when 80% was cut, and that's the only time that we see some dangers on our panels. So that's reassuring in terms of what silicon bonded facades can actually do or how they perform during earthquake. Then we have a fixed frame. Fixed frame is we're not allowing some rotation because the critical ones is the rotation. So we try to see what's happening here. So we have a crescendo. Crescendo is we up to 72 mm movement horizontal on the panel, and up to 72 mm, nothing is happening, meaning, it's good. That's boring, right? It's good. Nothing is happening. The sealant is not damaged. Your glass is not falling off. That's reassuring. Then we do it up to 100 mm. There's also nothing to report. No damage, nothing. Next, 130. That's the only time that we saw some damage to the sealant at around 130 mm drift amplitude. So what we can see here, this is what happened. There's some detachment on the panel itself. And this is, if let's say you imagine that's the panel, the legend, the colors here will tell you what happened to that sealant at that monotonic 130 mm movement for fixed panels, right? Not the one where you have some flexibility. Next, we do the fixed frame 20x9 sealant, a different aspect ratio. So we do first the crescendo up to 72 mm, again, increasing movement up to 72 mm, no damage observed. But when we do it, 200 mm movement, 200 mm, that's 20 centimeters, that's a lot of movement. We can see that there's a loss of weather tightness, but the structural sealant is still intact. Then next, we will do this 1 and 2 until we see some damage. And we found some damage at around 200 mm, as you can see from this one. That's what happened to that panel. So there's the video. It's going to dislodge like that because of that movement of that lower, that corner, upper left corner. So we achieved failure by doing that monotonic sequence direction, but it's at a very high displacement. Then we look at the fixed frame. As you can see, this is how the damage looks like when we try to deglaze those panels themselves. And we see what happened to the structural sealant that bonds the glass to the frame. And test number 5 is, again, fixed frame, large glass, 27 by 9 sealant, 27 mm by 9 sealant. And then the crescendo up to 72, nothing happened. But around 100 mm, time history movement, we have superficial rupture. Superficial, you can just see it. If you look at it, visual, you can see something, but we haven't deglazed it, so we haven't seen what's the behavior or what's the damage pattern looks like. Then at monotonic 225, no further progression of that crack was observed, but there's a lot of frame deformation. All right, I have 1 minute, and this is my conclusion. The conclusion is very simple. There's a significant influence of the frame design on the sealant behavior during seismic performance. If you have rigid frames, frames that are not allowed to actually rotate, What will dominate the failure? The silicon sealants. But if your frames are designed to rotate or is allowed to have that movement, which hopefully your designs are, it's all about gonna be the frame. The frame will fail first before the silicon sealant. Most of the designs, hopefully most of our designs here have that kind of rotation to allow for the seismic movements. Typically, curtain wall should have that. They should absorb that movement in the bracket design, some of those flexibility on the frame itself. And if you've done some performance mock-up of your sealants, of your facade, that should be a part of that performance facade. Crack propagation occurs at drip larger than code requirements. So the sealant will fail way beyond what code requires, and sealant damage, even though you have some crack, it will not occur on the glass fallout right away. That's it. There's some work to be done, but this seems to be very promising. And once we're ready to share again those other results, maybe it's in the next Zak. Thank you very much.
Okay, we are actually in our final session, and it will be a panel discussion. I'm inviting Ibu Dinar Ari, Secretary of Jakarta Chapter, Indonesia Institute of Architects, to come on stage to join me in a panel discussion on facade regulation in Jakarta, best practices and implementation strategies.
Good afternoon, everyone. Hello. Are you still on your spirits? I know this is very hard, this is the final session, but this is the very excited session actually, because we would like to discuss about the regulation about facade. As you can see in the rundown, now we will discuss about the facade regulation in Jakarta, best practices and implementation strategies. So it will be very interesting because I would like to invite some of the, pakar fasad, pakar di bidang designer also, and then juga beberapa asosiasi yang sungguh memperhatikan betapa pentingnya fasad. So everyone already following all the day sessions. It's about, do you remember how many sessions that you already, can you? 10, 12, 20? Still counting out? Or, well, some of you already follow this session from the morning, and then some of you I saw, well, you are coming late as me also. So it's no problem because now we will discuss it. So let me introduce our first panelist, Ibu Doti Windayani. Let's give applause for her. She's the chairperson of the Jakarta Chapter Indonesian Institute of Architects, and also she's the managing director of Quadratura Indonesia. And then the second panelist is Mr. Frans Suryadi, but unfortunately he cannot join us today, but Ibu Putri will represent Pak Frans. So please join us and have a seat. And then the third panelist is Bapak Budi Sumaatmaja. Please join us. He is the President Director of Anggara Architim. And then also Bapak Muhammad Denny Desvianto, Project Director of PW Architect, please join us. And then also Bapak Aryo Angkoso, Secretary General Peravi, Indonesia Facade Association, and Senior Facade Consultant from Manhart Facade Technology. Please have a seat. So we need 2 more panelists. Hopefully they will going to join us soon. So, how are you, Ibu Doti, Ibu Putri, Pak Aryo?
I'm fine.
Okay.
Nice
So,
to meet you here.
Yes, please allow me to continue in bahasa. Bapak Ibu, teman-teman sejawat, pada sore hari ini kita akan diskusi yang menarik mengenai peraturan fasad. Kalau tadi kita sudah mendapatkan insight beberapa, bahkan banyak sekali input tentang fasad ya dari pagi sampai siang sore hari ini. Nah sekarang kita justru akan membicarakan tracknya, gitu ya. Bagaimana sih implementasinya dari semua informasi, dari semua pengetahuan, dari semua kemajuan teknologi yang kita dapatkan dan kita implementasikan selama ini. Di Jakarta rasanya belum pernah ada aturannya, setuju? Nah, kita akan diskusi pada sore hari ini, setuju ya, Ibu Doti ya, Bu Putri ya, Pak Aryo ya. Seru nih, karena hari ini adalah kick off-nya sebetulnya ya. Jadi bukan berarti apa yang kita diskusikan pada hari ini menjadi final pada hari ini, tapi menjadi semacam trigger, first step gitu ya, untuk menuju suatu regulasi yang compact, yang juga bisa terintegrasi dan sinergi dengan regulasi yang lainnya. Begitu ya Bu Doti, Pak Aryo ya. Karena regulasi fasad tentu tidak bisa berdiri sendiri karena implementasinya di dalam manajemen project itu stakeholdernya banyak banget gitu. Nah menarik pada sore hari ini kalau saya mungkin meminta Bu Doti dulu nih yang sudah pertama kali menginisiasi ide. Jadi Bapak Ibu, teman-teman sejawat, ide pertamanya ini sebetulnya justru dari Ketua IAI Jakarta. Cuman kita ingin tahu kan, apa sih yang membuat beliau sampai segitu merasa ini perlu dilakukan. Silahkan Bu Doti.
Tes. Jadi Bapak Ibu jangan takut dulu ya. jangan dibikin tambah
Mereka
kompleks.
bukan takut, Bapak Ibu nggak takut Mbak Doti. Justru penasaran.
Ya, jadi kita melihatnya begini. Jadi waktu itu kita berdiskusi ya dengan Peravi. Gitu. Di Indonesia itu sepertinya belum ada peraturan yang mengatur tentang fasad. Gitu. Padahal pertumbuhan bangunan ya, terutama bangunan tinggi di Indonesia khususnya di Jakarta itu cukup tinggi. Sementara kadang-kadang kalau kita lihat bangunannya, itu safe atau enggak ya gitu. Jadi itu apa panduannya? Belum ada. Jadi kita mengajak rekan-rekan semua itu untuk bisa kita diskusikan yuk, kita bikin kajian gitu dengan Peravi untuk istilahnya menyusun ya, paling enggak panduan teknis ya, syarat minimum untuk fasad, terutama berkaitan dengan kenyamanan, keamanan, keselamatan ya. Jadi pada dasarnya di Indonesia itu, apalagi sekarang gempa semakin sering ya berjalan, ada banyak risiko ya gitu. Ada seismic issues ya, yang kedalaman gempanya sekarang semakin rendah begitu, dan dampak perubahan lempeng bumi juga bergerak. Jadi itu ada risiko yang sangat besar. Tadi sempat disampaikan oleh Jayrold juga. Kemudian juga angin gitu. Juga lainnya itu adalah kebakaran itu pasti. Tapi juga ada isu juga human error karena detailing kita di fasad kurang benar gitu, berisiko kepada keamanannya penghuni. Itu banyak terjadi ya gitu. Kemudian kita punya hal baru ya, yang sustainability issues, yes, gitu-gitu. Jadi kita punya masalah istilahnya harus bersama-sama mengembangkan bahwa bangunan kita tuh sustainable melalui fasad ya, comfort juga, terus sustainable by buildingnya itu sendiri, energy efisiensi, terus yang terbaru energy farming. Tadi Bu Daliana mungkin pagi sudah menyampaikan itu juga punya social impact juga fasad, terus kemudian city image ya. Juga kemarin sempat Pak Kadis menanyakan city lighting improving our quality of city kan begitu juga. Jadi banyak hal yang isunya perlu kita kembangkan bersama dan tentunya itu dari hulu ke hilir ya. Dari misalnya desainer, pengembang ini ya karena itu ada cost issue di sana, kemudian desainer, tapi juga industri manufaktur di sini. Gitu. Perkembangan teknologi juga method of construction. Jadi itu perlu dibahas semua pihak sebelum kita bawa ke regulator gitu. Jadi ini adalah kerjasama bersama yang mungkin perlu juga mendapat masukan dari rekan-rekan sekalian. Mungkin begitu Bu.
Oke, luar biasa ya Bu Doti ini kayaknya nggak pernah tidur. Jadi yang dipikirin banyak gitu. Tadi kalau dari pertama membuka inisiasinya kenapa mulai ada ide, terus lama-lama kalau di listing mungkin beliau sudah menyebut 15 item keprihatinan gitu ya. Luar biasa, jangan-jangan nanti habis ini Bu Doti lemparin ke floor, terus kita semua yang nggak bisa tidur ya. Jadi begini, sore hari ini kita memang akan menjaring pendapat dari Bapak Ibu teman-teman sejawat semua gitu ya. Jadi bukan kita-kita ini nih yang ada di depan yang nanti akan memfinalize, begitu ya? Setuju ya? Justru kita ingin tahu gitu ya, dari teman-teman sejawat, dari para produsen, kemudian juga dari pemerhati, kemudian juga mungkin nanti ada kalangan akademisi gitu ya, yang akan kita ajak bersama-sama memikirkan ini kurang lebih. Tapi kebetulan hari ini kita ada perwakilan dari para desainer, Pak Denny dan Pak Budi, lalu ada dari developer, properti, Ibu Putri, dan Pak Aryo dari Asosiasi Facade. Nah, izinkan saya memandu sedikit ya, kita akan mendengarkan juga. Kalau dari sisi Pak Budi dulu deh, yang sudah begitu malang melintang di dunia tools gitu ya. Nah kalau tadi keprihatinannya Bu Doti gitu ya, diimplementasikan dalam satu susunan regulasi, kalau para desainer pandangannya gimana sih Pak? Jangan-jangan nanti malah mencekam ide-ide kreatif. Nah, kita ingin mendengarkan juga nih dari Pak Budi.
Halo, ya maaf saya tadi agak sedikit terlambat. Menurut saya pertama kecenderungan desain, terutama desain bangunan sekarang ini lebih kompleks dan lebih banyak variasinya. Bentuk maupun penampilan dari bangunan tersebut konsekuensinya langsung ke fasad. Pengertian fasad ini sebenarnya kalau bagi saya bukan hanya selubung bangunan tapi sampai ke keseluruhan bangunan sampai ke bagian atapnya gitu. Juga tampilan fasad ini mewakili bentuk bukan hanya sebagai fungsinya tapi juga kualitas dari bangunan itu sendiri. Dan dia juga bisa memperlihatkan aktivitas apa yang ada di dalam bangunan maupun juga terhadap lingkungannya. Jadi dampak fasad ini luar biasa. Jadi tidak hanya dia di lingkungan sekitar perimeter dari bangunan, tapi juga ke sekelilingnya bahkan ke skala yang lebih luas. Perkotaan dibentuk oleh suatu lingkungan massa bangunan, jalan, open space, dan juga benda-benda di sekitar itu memiliki suatu kesatuan sehingga ada satu karakter dari perkotaan itu sendiri. Nah, konsekuensinya adalah kalau misalnya dalam kompleksitas dari desain tadi, sekarang kita mengenal istilahnya secondary skin. Secondary skin ini tidak hanya dari material yang biasa seperti kaca maupun metal panel dan lain sebagainya, tapi juga sekarang sudah mulai ada landscape, pohon tinggi yang tadinya kita lihat di tanah sekarang sudah di atas bangunan, bahkan di lantai kesekian begitu. Seperti yang di Milan misalnya atau di tempat yang lain. Itu juga membuat satu konsep yang sangat berbeda dengan yang biasanya. Kemudian juga penerapan dari BIPV atau Building Integrated Photovoltaic sumber energi terbarukan yang sudah mulai diterapkan di bagian dari fasad. Ini juga konsekuensinya akan berbeda dengan yang biasanya. Kemudian jangan lupa bangunan 3 lantai, kita tidak bicara hanya bangunan tinggi, tapi bangunan 3 lantai, 4 lantai. Seringkali di fungsi tertentu ada atrium yang cukup besar, cukup luas. Konsekuensinya biasanya dengan skylight, ada banyak bidang kaca di atapnya, dan juga ada bidang kaca yang sampai sebegitu besarnya di hadapan atrium itu sendiri, satu sisi atrium, dengan kaca yang cukup luas. Gitu. Konsekuensi sekali lagi ke masalah teknisnya nanti bagaimana installation dan sebagainya. Kemudian juga perawatan dan perbaikan pada long run-nya ada jangka panjangnya itu juga membawa konsekuensi bagaimana yang paling baik gitu ya kondisinya. Risiko dari kaca ini, pemasangan kaca ini sendiri. Tahun 95-96 saya ngalamin sendiri ada satu bangunan di Jakarta, 32 lantai, cukup tinggi, di mana bangunan itu cukup sangat penting ya pada saat itu sampai dengan sekarang. Itu begitu selesai construction, kaca dan panel granit jatuh ke bawah. Jadi itu untungnya tidak ada korban. Jadi bayangkan sebegitu riskannya kalau tidak hati-hati dalam apakah itu installation-nya maupun detailing dari desainnya sendiri. Itu jatuh betul-betul kaca dan panel-panel yang ada granitnya itu jatuh ke bawah. Itu saya lihat sendiri. Kemudian risiko yang lain adalah kebakaran. Salah satu bangunan yang kemudian kita in charge di dalam desainnya terbakar. Kenapa? Karena ternyata panelnya itu tidak sesuai dengan spek fire retardant yang kita persyaratkan. Itu sampai menjalar ke lantai-lantai yang di atasnya. Itu tahun 2016. Nah, jadi tahun 95, 2016 ada terjadi begitu. Kemudian kita semua tahu bahwa ada Grenfell Tower di London, itu juga terbakar, the whole tower, gara-gara ada, bukan gara-gara fasadnya, tapi awalnya dari dapur, ada api, sumber api, kemudian menjalar ke fasad, kebetulan fasadnya juga tidak memenuhi persyaratan, di mana bagian tengahnya itu tidak fire retardant, dan akhirnya malah meneruskan lidah apinya langsung ke lantai-lantai berikut, sehingga the whole building jadi on fire gitu ya. Kemudian di sisi yang lain, jadi dengan konsekuensi itu maka perlu ada satu arah bagaimana menjaga fasad tadi kondisinya dengan satu proses testing dan evaluation dari segi weather resistance, dari segi kebocoran udara, kebocoran air pada saat hujan, kemudian structural integrity pada saat ada gempa. Kita sangat dipengaruhi oleh angin dan gempa ya kalau di fasad di Indonesia ini. Kemudian fire resistance, dan juga satu lagi yang cukup penting adalah sound reduction. Jadi ada satu persyaratan sound di tempat atau di lokasi tertentu. Nah, kemudian kita bicara sustainability. Persyaratan sampai hari ini, persyaratan yang berlaku di Jakarta adalah Pergub, yang terakhir ada Pergub tahun nomor 60 tahun 22. Kemudian SNI yang mempersyaratkan, kalau Pergub hanya 45 watt per meter persegi. Tapi SNI 35 watt per meter persegi. Even ketat sekali. Jadi sekarang memang ada dua standar. Jadi bagaimana nih, standar yang mana yang harus diikuti? Ya, harusnya yang paling baik ya, artinya mungkin yang 35, tapi harus ada satu standar yang langsung terkait dengan fasad. Kenapa? Karena itu berkaitan dengan OTTV. OTTV adalah kriteria radiasi terhadap ruang dalam dari matahari ke ruang dalam. Kenapa? Karena loading atau energi dari pendingin di dalam bangunan itu adalah yang terbesar dari semua komponen di dalam bangunan kalau dibandingkan. Sehingga begitu pentingnya peranan OTTV untuk mengontrol energi efisiensi di dalam bangunan. Gitu. Kemudian sekarang ada Pergub nomor 135 di Jakarta ya, Pergub 135 tahun 2022 yang memperkenankan adanya vertical garden dan juga roof garden. Ini sangat baik dari segi sustainability. Jadi kita akan mengurangi heat island, bahkan kita juga memberikan sumbangan untuk mengurangi emisi karbon. Nah, ini tapi di sisi yang lebih teknis, bagaimana persyaratannya? Bisa jadi baik dari sisi yang lain, tapi pada saat penerapannya malah kalau tidak ada satu guidance ya, yang mengikat, itu malah menjadi sesuatu yang tidak menyumbangkan sumbangan yang baik. Kemudian ya pada akhirnya kita akan melihat bahwa dampak fasad itu ada negatif dan positifnya pada saat yang sama. Kaca dulu waktu tahun-tahun mungkin 90-an gitu ya, selalu kita diingatkan kalau desain kaca harus reflektifnya itu ada sekian persen, kalau nggak salah nggak lebih dari 15% kalau nggak salah. Nah itu dibatasi sekali, tapi sekian persen itu dasarnya apa? Itu masih belum terlalu jelas. Saya kira itu harus ada. Itu kan berdampak langsung dengan kebangunan atau lingkungan sekitarnya. Ya silau dan juga akhirnya akan mempertinggi heat island daripada gedung itu sendiri. Tapi sisi yang lain yang sekarang sudah mulai ada dan sudah mulai diterapkan adalah BIPV. Jadi bangunan yang memproduksi energi untuk kebutuhannya sendiri. Jadi dengan panel matahari yang diterapkan di spandrel fasadnya akan meningkatkan atau menciptakan energi untuk bangunan sendiri. Jadi satu masalah bisa dampak plus dan minus sekaligus. Kira-kira gitu.
Luar biasa Pak Budi. Jadi sebetulnya diskusi kita selesai karena Pak Budi udah nyebutin semua item. Gimana? Pak Aryo langsung dibungkus aja kali ya?
Kita tutup bisa Bu.
Iya kan ya?
Ya, Pak Budi memang sudah mewakili banyak
Sampai
keprihatinan kita
mitigasi
semua ya.
resiko, sharing ya, tadi
Iya.
kecelakaan-kecelakaan, kemudian kekhawatiran, lalu nanti tadi ya concern pada urban, pada landscape dan seterusnya gitu. Apa kita selesai? Enggak dong ya, belum ya. Kita masih mau mendengarkan nih Pak Denny seperti apa sih. Pak Denny ini juga praktisi, juga hafal peraturan saya rasa ya, asesor. Bapak Ibu ada yang pernah diasesori sama beliau? Mudah-mudahan di approach hari ini supaya lulus ya. Silakan Pak Denny, berbagi sedikit dengan kita.
Terima kasih. Maaf tadi saya telat sama Pak Budi. Lagi janjian tadi Pak ya. Ini benar tadi Mbak Dinar.
Janjian gak ngajak-ngajak ya.
Saya pas dengerin Pak Budi jelasin, saya bilang sama Pak Aryo, saya ngomong apa? Udah semuanya udah Pak Budi. Oke, jadi kalau saya melihatnya kenapa perlu peraturan fasad lebih kepada keselamatan ya, faktor keselamatan. Tadi Pak Budi cerita bahwa tahun 95 ya Pak ya, pernah ada kejadian. Nah di kami tuh saya pernah mengalami, jadi sedang ada klien ya, ada klien sedang menyelesaikan proyeknya, terus klien tersebut meminta dikunjungi proyeknya yang lain. Dan itu ada kejadian di mana fasadnya tapi di crown, area crownnya itu jatuh gitu loh. Dan kalau Pak Budi bilang tadi tidak ada korban, di proyek yang saya review itu kebetulan ada korban gitu. Nah itu begitu saya cek ke atas memang mungkin nggak tahu ya, karena pada saat itu mungkin fasad itu belum terlalu apa ya, orang tuh masih melihatnya ya kulit aja gitu, apa kosmetik ya. Jadi bukan menjadi sesuatu yang merupakan unsur penunjang atau unsur yang penting dalam sebuah kesatuan sebuah bangunan gitu ya. Dan itu setelah itu saya akhirnya mulai mempelajari sedikit lah fasad, terus kenalan sama beberapa konsultan fasad, salah satunya Pak Timothy di situ. Dan
Gimana
ada
Pak Timothy? Oh ada.
Terus ada beberapa juga aplikator fasad yang akhirnya banyak belajar begitu mengenai fasad. Terus makin ke sini ternyata masalah fasad itu tidak hanya kulitnya jatuh gitu ya, tapi ada banyak lagi kejadian dan di antaranya yang paling sering, yang paling berbahaya menurut saya itu kebakaran. Karena di Indonesia sendiri kan contoh yang akhirnya memicu peraturan lain ketat itu kebakaran gedung Kosgoro ya. Habis itu ada kebakaran lagi di daerah dekat Mall Taman Anggrek itu.
Iya.
Terus ada kebakaran lagi yang belum lama ini kebetulan gedung tempat
nanti
kantornya.
kita minta sharingnya dari Bu Doti ya.
Dan itu sebenarnya kalau yang di tempatnya gedung tempat kantornya Bu Doti itu ternyata masalahnya bukan di fasadnya sebenarnya, tapi kegiatan apa yang berlangsung di dekat fasad gitu loh. Yang kebetulan itu kurang diperhatikan faktor keamanannya, jadi merambat kemana-mana. Dan tadi juga ada kita bicaranya kalau peraturan ya tidak bisa cuman satu sisi gitu, dibahasnya satu sisi ya, tapi perlu diperhatikan lain. Tadi pas lagi diskusi yang sebelumnya itu kan membahas mengenai sustainability, salah satunya adalah second skin gitu ya. Second skin saya sangat setuju dengan second skin karena baik ya sebenarnya untuk bisa mereduksi panas, jadi mengurangi energi yang dikeluarkan di dalam bangunan. Tapi ternyata ada efek lain. Efek lainnya yaitu bisa menjadi terowongan api. Jadi pada saat ada terjadi terbakar di bawah, terus ada second skin, kalau kita tidak mendesain yang tepat second skinnya itu bisa jadi terowongan api, itu cepat banget apinya ke atas gitu loh. Dan itu sumber masalah juga ya, karena yang terdampak bukan hanya yang di dalam bangunan, tapi yang di luar bangunan juga terdampak gitu loh. Jadi banyak. Nah, tapi di sini saya mau coba ini kenapa perlu peraturan, itu kan seolah-olah hanya bangunan tinggi. Ternyata bangunan low rise juga penting gitu kita bicara masalah fasad ya. Jadi banyak hal-hal yang terlupakan karena orang mikirnya cuman bangunan 3 lantai, 4 lantai, fasad nggak penting. Tapi dia nempelin batu di situ di fasadnya gitu. Nempelin batu yang kita nggak tahu gimana installmentnya bisa kering, bisa basah gitu kan. Nah itu bisa menjadi objek bukan objek ya, menjadi subjek yang menyebabkan orang terdampak gitu loh. Tiba-tiba orang lagi lewat, terus installmentnya nggak bener, apalagi pasangan basah gitu ya, tuh kena kepala kan, selesai kan gitu kan. Jadi jadi apa namanya banyak yang perlu diperhatikan. Tapi tadi saya sempat menanyakan sebelum di sini ya, harusnya kita ngundang ini nih regulator nih di sini.
Iya, harusnya.
Iya, regulator biar
Iya.
apa namanya ada perhatian ya dari pihak pemerintah bahwa fasad ini juga merupakan sesuatu yang perlu diatur ya, diatur jadi tidak sembarang orang membuat bangunan indah memang karena fasad itu kan selubung ya kita bicara. Jadi itu yang pertama kali dilihat kalau orang tuh kan kulit ininya ya gitu ya. Kalau bagus terus apa namanya secara tata kota juga enak dilihat. Terus nah itu kan juga jangan cuma enak dilihat gitu loh, tapi juga apa namanya bagi orang yang berada di sekitarnya atau orang yang ada di dalam bangunan tersebut bisa terjamin tidak terdampak oleh tanda kutip keindahan itu gitu loh. Jadi banyak memang yang harus diperhatikan dan tadi Pak Budi bilang tidak bisa hanya satu peraturan fasad aja gitu karena itu terdampak dengan ininya banyak ya relasinya banyak kayak tadi Pak Budi bilang ada Pergub 60 yang sebelumnya Pergub 38 Pak ya, itu kan juga fasad tuh sebenarnya ngatur, ada SNI juga, terus ada Permen 26 juga bagaimana orang akses masuk ke dalam, kalau di Jakarta sih peraturannya udah cukup lengkap, ada Pergub 200, ada Pergub 72 ya, jadi istilahnya banyak lah. Tapi untuk fasad sendiri installment itu belum ada gitu, bagaimana cara menginstall fasad yang benar, bagaimana kita mesti juga lihat reflected ininya ya, transmitternya itu kan jangan sampai pantulan fasad bisa bikin kebakaran gitu di bawah kayak di Inggris ya. Jadi kejadian karena pantulan fasad matahari sudutnya pas
Pada
gitu
saat
kan.
very hot summer dia ternyata menghantar panas.
Nah, jadi banyak yang mesti diatur sebenarnya. Tapi bukan berarti itu menjadi hambatan untuk para arsitek atau konsultan fasad atau siapapun atau bahkan developer sendiri untuk berkreasi. Karena kadang-kadang aturan tuh orang banyak melihat aturan ini mengekang gitu. Kalau saya bilangnya justru itu tantangan gitu loh. Bagaimana kita mensiasati aturan itu menjadi sesuatu yang menjadi nilai lebih dari bangunan kita. Itu kalau menurut saya sih seperti itu ya.
Luar biasa Pak Denny ya. Memang beliau ini ahli banget soal peraturan, apa aja diatur. Saya nggak tahu kalau di kantor ngatur juga nggak, saya nggak tahu ya. Nanti saya mau tanya beberapa stafnya yang ada di sini. Baik, tadi ini sudah 2 desainer ya memberikan pandangan-pandangan implementasi pada proses perencanaan dan perancangan. Ada satu yang mesti kita tanya juga. Tadi sorry ya Pak Denny ya, memang catatan penting nih Pak Aryo buat kita ya bahwa nanti pertemuan berikutnya, diskusi berikutnya kita undang regulator.
Setuju Bu.
Ya, tapi hari ini kita kick off dulu kan?
Jadi memang hari ini kita kick off dulu. Dan kenapa kita kick off-nya di Zak? Karena memang kita semua di sini adalah yang pemerhati fasad, yang bergerak di fasad dan sangat berpengaruh terhadap regulasi
Sebentar,
fasad.
saya tanya dulu. Pak Aryo kok begitu yakin bahwa di sini semua orang tuh pemerhati fasad dari mana Pak? Apakah wajah-wajahnya itu flat?
Sangat familiar, sangat fasad minded.
Sangat fasad ya?
Yang jelas kalau nggak aware dengan fasad nggak akan hadir hari ini.
Pasti aware gitu ya. Oke, satu lagi Pak Aryo ya, sebelum nanti Pak Aryo menyampaikan progresnya gitu ya. Saya mau tanya Bu Putri dulu nih dari developer gitu ya, dari properti nih, sisi properti. Kira-kira nih peraturan-peraturan ini kan pasti Bu Putri dalam mengimplementasikan yang sekarang nih bangunan yang kita tempati nih hari ini yang bagus banget. Di sebelah juga bagus ya, AstraLand luar biasa. Nanti Bapak Ibu ada kunjungan kita ke AstraLand kapan Bu Duti? 22 ya, ada international conference di AstraLand loh, kita jadi endorse. Nanti Bapak Ibu bisa melihat ya bagaimana AstraLand membangun sebuah bangunan tinggi di Jakarta yang menjadi landmark. Nah saya mau tanya sama Bu Putri, implementasi nih peraturan nanti kalau diterapkan, kira-kira dari developer gimana sih? Kan tentu ada sisi finance-nya ya, jangan sampai nanti form follow finance gitu kan, nanti arsiteknya sedih ya. Silakan Bu Putri, mungkin ada pendapat-pendapat. Oke.
Oke, Bapak Ibu semoga belum bosan ya ngeliat saya dari jam 9.
Enggak, kalau sekarang Bu Putri cerita, bukan jadi host.
Oke, dari sisi developer mungkin saya melihat bukan dari sisi technical atau juga saya sendiri arsitek, tapi untuk masalah teknis dan perancangan saya serahkan kepada expertnya Ibu Doti, Pak Budi, Pak Denny. Kemudian dari sisi regulasi banyak teman-teman lain yang akan menjalankan dengan baik. Tapi dari sisi developer saya rasa regulasi juga bisa membantu mendorong pertumbuhan nilai ekonomi bangunan tersebut. Menara Astra adalah masterpiece-nya Astra International. Itu adalah gedung pertama yang kami hadirkan untuk membawa nama Astra International, untuk mengharumkan nama bangsa Indonesia. Dan waktu itu melalui Menara Astra kita juga kick off Astra Property sebagai lini bisnis ke-7 Astra International. Jadi pada saat proses perencanaan dan juga proses konstruksi semuanya tuh benar-benar dilihatin dari hulu sampai hilir. Dan cerita-cerita yang saya dapetin dari Pak Frans, direktur saya yang mestinya ada di sini tapi saya gantikan, itu luar biasa. Pertumbuhan nilai ekonomi bangunan pastinya akan membantu banyak orang. Bukan hanya pemilik gedung, tapi juga yang akan datang dan menyewa gedung tersebut. Dan juga akan mengangkat kawasan sekitarnya. Nah, pada saat semua itu terjadi, insentifnya untuk pemerintah daerah sebetulnya bentuknya adalah PBB. Rela dong kita bayar PBB mahal, karena dengan regulasi yang ada, kita pun sebagai pemilik gedung itu dapat cuan. Nah, saya share sedikit di Menara Astra pada saat EU, European Union menjajaki untuk menyewa space kami, yang datang dengan persyaratan itu bukan kita, bukan kami sebagai pemilik gedung, tapi mereka sebagai penyewa. Jadi mereka datang ke kita dengan form dan mereka tanya apakah kita bisa memenuhi requirement yang mereka cari. Dan requirement itu amat sangat tinggi karena di Eropa they've done sustainable design for decades. Nah, karena cita-cita pada saat itu Presiden Direktur AI Internasional Pak Priyono untuk memberikan yang terbaik untuk Indonesia, jadi kita dapat certified platinum dari BCA. Dan dengan mudahnya EU bought that.
Wow.
Jadi mereka merasa comfortable untuk move in bersama kita karena kita bisa memberikan apa yang mereka cari. Coba bayangkan kalau gedung-gedung lain di Jakarta atau di Indonesia melalui regulasi ini bisa memberikan juga yang terbaik. Jadi kami sebagai pengembang mendukung adanya regulasi yang bisa memitigasi safety, comfort, dan of course karakteristik visual dari Jakarta. Siapa sih yang nggak mau punya kota cantik?
Pasti semua mau sih Bu Putri.
Yes.
Iya, dan
Jadi
semua juga pengen kebagian cuan juga.
Ya, jadi saya berharap teman-teman regulator, Bapak Ibu expert yang ada di sini bisa saling membantu supaya untuk mendukung pertumbuhan nilai perekonomian bangunan melalui regulasi ini.
Luar biasa, terima kasih banget insight-nya Bu Putri ya. Ini menyemangati Pak Aryo, bukan saya yang semangat, Pak Aryo sebenarnya.
Iya, kita yang jadi semangat bekerja buat
Iya betul ya, semoga ini tetap nanti goal jadi gitu ya,
Siap.
dibantu sama teman-teman yang hadir di sini tentu ya Pak ya.
Iya, siap.
Luar biasa Bu Putri ya, jadi tentu perlu ya, ternyata peraturan itu perlu banget supaya memenuhi standar gitu ya. Terus nanti kliennya tentu bukan saja lokal tapi juga dari abroad ya gitu ya. Terus kita bisa meyakinkan bahwa Indonesia bangunannya standar gitu ya. Safety, comfort gitu ya. Apa yang lo butuh gue ada gitu ya. Bahasanya gitu.
Ya,
Oke, keren banget ini ya dari 3 narasumber kita nih panelis ya. Dari Bu Putri, Pak Budi, Pak Denny menyambut idenya Bu Doti luar biasa. Tapi kita mesti nunggu nih Pak Aryo, Bu Doti nih. Karena dari semua ini ternyata diam-diam Pak Aryo kerja ya sama timnya supaya bisa presentasi sore ini.
Iya.
Silakan Pak Aryo.
Iya, terima kasih Bu Dinalari. Jadi memang tadi kita sangat didorong dari IAI Jakarta, Bu Doti, dan sebelumnya juga dari Pak Denny juga sudah menginisiasi. Jadi kita ingin ada suatu peraturan fasad yang bisa diikuti semua pihak di sini. Jadi mungkin yang disampaikan dari Pak Budi maupun Pak Denny tadi tentang masalah-masalah yang ada di fasad, saya yakin itu semua masalah kita bersama ya. Maksudnya di sini ada yang dari kontraktor, dari konsultan. Biasanya kalau ada masalah yang dipersalahkan kontraktornya ya Mas. Salah pasang gitu ya. Padahal kalau kita ditanya di sini pasti kita semua juga akan ingin memasang dengan benar, dengan menggunakan material yang baik, yang sesuai dengan kualitas. Tapi kalau kita pasang dengan kualitas yang terlalu tinggi, sementara kontraktor lain masangnya yang murah-murah, berarti kan kontraktornya juga nggak akan dapat proyek gitu kan. Ini mungkin jeritan hati para kontraktor. Gitu.
Kontraktornya udah pada pulang kok.
Udah pada pulang ya Bapak ya. Jadi kita, nah, jadi maksudnya kita perlu ada suatu standarisasi, regulasi yang jadi acuan semua pihak. Dan akan kami sampaikan di sini masih draft. Seperti tadi disampaikan oleh Bu Dinarari, kita masih akan ada langkah-langkah selanjutnya. Termasuk tadi kita akan mengundang dari regulasi dari pemerintah untuk juga mewujudkan, mendetailkan peraturan ini selanjutnya bagaimana. Mungkin sebagai bocoran aja nanti di bulan Oktober kami juga akan mengadakan semacam workshop yang lebih detail, bagaimana nanti juga termasuk dengan regulator dan semua stakeholder yang ada. Begitu.
Siap, kami siap diundang. Teman-teman siap diundang ya?
Harus siap, karena ini tanggung jawab kita semuanya.
Loh sebentar kok diem semua ya? Kali pada males mikir udah sore. Langsung aja Pak Aryo disampaikan.
Jadi mungkin saya mulai apa yang telah kami lakukan selama ini. Jadi kami dari Pravi kita mencoba menginisiasi karena selama ini banyak yang ingin mempunyai peraturan tapi harus ada yang mulai jadi mengerjakannya. Jadi kami mencoba mendorong biar ini bisa terlaksana. Jadi memang yang akan kami sampaikan sini belum mencakup semuanya, tapi ini baru langkah awal. Boleh kami bilang sebagai main opener dulu agar ini bisa dilanjutkan ke langkah-langkah berikutnya. Jadi untuk batasan yang untuk draft peraturan yang kami lakukan sekarang ini memang masih terbatas pada gedung yang diuji dalam perizinan bangunan gedung. Jadi memang tidak mencakup untuk semuanya. Salah satu pertimbangan yang lain juga memang seperti disampaikan tadi oleh Bu Putri, tim developer juga pasti ada kepentingan. Kita juga tidak ingin karena nanti ada peraturan fasad sehingga efeknya nanti developer akan komplain, akan jadi high cost, harganya juga lebih tinggi, itu juga kita akan hindari. Kita ingin semuanya menjadi memberi kebaikan buat semuanya. Kemudian gedung yang digunakan adalah gedung umum, termasuk dalamnya gedung komersial, gedung non komersial, rumah ibadah maupun rumah sosial. Misalnya saja dan juga parameter berikutnya gedung dengan ketinggian 30 meter atau 8 lantai. Walaupun ini tidak memungkinkan bahwa gedung yang di bawah 30 meter harus juga mengikuti peraturan. Misalnya saja rumah ibadah, kita lihat banyak skylight yang sangat perlu kita pertimbangkan faktor safety-nya, walaupun dia tidak mencapai 30 meter. Jadi ini juga jadi pertimbangan kita. Dan yang draft yang kita sekarang persiapkan ini adalah untuk gedung baru. Jadi belum mencakup gedung-gedung yang sudah dibangun. Jadi jangan khawatir Bapak Ibu ya, gedung-gedung yang sudah ada itu sementara ini tidak berlaku dengan draft yang kami coba propose ini. Kemudian tadi kriteria itu adalah gedung baru dan kriteria yang kita akan utamakan di draft ini adalah untuk kenyamanan dan keamanan, safety and comfort. Jadi tadi Pak Budi sudah detailkan sekali kenapa itu harus nyaman dan juga aman. Jadi sebenarnya background-nya tadi ini adalah untuk menjawab kerisauan dari kita semua. Kemudian nanti selanjutnya kita mungkin 3 tahun ke depan, target kita bangunan yang sudah berdiri kita juga akan melakukan assessment dan bisa berlakukan juga dengan peraturan yang kemudian hari. Jadi ini keselamatan dan kenyamanan. Kemudian ya tentunya kalau fasad kita semua tahu faktor pertama yaitu masalah struktur atau keamanan. Dari SNI kita sudah ada bagaimana cara perhitungan beban angin, tapi memang selama ini belum diimplikasikan di semua pihak. Kita tahu SNI kita sebenarnya ada, walaupun cara perhitungan ini mengambil langsung dari SCE dari Amerika. Tapi sebenarnya step-stepnya sudah ada. Dan untuk kecepatan angin kita memang belum ada di Indonesia petanya, tapi kita ada dari region Asia Pacific region, di mana kita bisa menggunakan 32 meter per detik untuk kecepatan angin perhitungan. Kemudian kenapa kita mendorong ini? Agar kita semua harus bisa melakukan perhitungan, karena standarnya sudah ada, tapi saat ini tidak semua bangunan atau tidak semua fasad kontraktor melakukan perhitungan sesuai dengan SNI yang ada. Dan untuk bangunan yang dari 30 meter ke atas, kita untuk desain wind load-nya harus minimum 0,8 kPa. Sebenarnya ini kenapa 0,8 kPa? Karena kalau kita hitung pun kalau dengan bangunan yang 30 meter, dia akan hasilnya sekitar 0,8 kilopascal atau 800 kg per meter persegi. Jadi memang karena dari pengalaman kami tidak semuanya mungkin mampu atau tidak mau menghitung. Jadi ingin mengambil angka yang sudah ada saja. Nah kalau seperti itu minimum adalah angka ini 0,8 kPa. Dan juga tentunya harus memperhitungkan semua proyeksi horizontal dengan lebih dari 300 mm harus didesain. Kemudian dalam kita merumuskan regulasi ini, selain kita mengacu pada peraturan yang sudah ada SNI, kita juga mencoba membandingkan negara-negara tetangga kita yang iklimnya sama, juga kebutuhannya sama, jadi dia ada di Singapura maupun di Malaysia. Sehingga dengan adanya perbandingan ini, apa yang kita akan lakukan di Indonesia, ini sebenarnya kita bisa pertanggungjawabkan memang sudah sesuai dengan kebutuhan di region kita. Jadi contohnya dari sisi desain wind load, ini kalau kita acu ke Singapura, mereka sudah ada menghitungkan wind load dan dead load-nya, begitupun juga kalau dengan di Malaysia. Sementara kalau di Malaysia wind load minimumnya pun sudah ada. Kemudian dari peraturan ini yang akan kita atur, sementara ini material utama fasad memang yang banyak digunakan adalah baja, aluminium maupun kaca. Jadi sementara ini di awal item-item inilah yang akan kita masukkan ke peraturan untuk material baja, maksimum defleksinya, aluminium dan kaca. Ini tidak menutup kemungkinan memang kemarin kita ada pertanyaan bagaimana kalau material misalnya JRC atau stone atau yang lain, itu mungkin akan next step-nya. Tapi kita harus mulai dengan suatu langkah, suatu ukuran yang bisa kita mulai nanti untuk jadikan desain fasad. Kemudian ini juga untuk tadi kita bandingkan tadi defleksi yang ada di Indonesia, kemudian juga Singapura, di Malaysia, dan akhirnya dari kami akan mempropos maksimum defleksi yang ada. Kalau misalnya untuk aluminium kita propos sekarang L dibagi 175, jadi kalau tinggi bentang dibagi 175 itulah maksimum defleksinya. Ini sekedar contoh saja apa yang kami ingin infokan, bagaimana kami merumuskan peraturan ini dengan memperbandingkan dengan negara Singapura, Malaysia, dan juga sejarahnya, dan kita juga refer ke peraturan yang lain sesuai kebutuhan. Kemudian juga kaca, di mana kita tadi Bu Loti sudah menyampaikan juga masalah safety. Kita sangat concern masalah safety, terutama kita menghindari kaca pecah sendiri. Kita sering menemukan di banyak gedung kaca pecah sendiri yang akhirnya sangat merugikan karena operasional gedung akan terhambat. Sebenarnya tadi Pak Budi sempat cerita ada yang kacanya jatuh. Di luar itu kita sebenarnya tahu banyak kejadian-kejadian yang diselesaikan di bawah tangan tidak sampai terekspos, tapi sebenarnya itu sering sekali terjadi. Hampir di setiap bangunan sebenarnya ada, tapi memang ini kita untuk menghindari masalah-masalah tadi agar tidak salah desain. Sebenarnya kalau banyak cerita dari teman-teman juga dari kontraktor, mereka ingin menyarankan kepada pihak pemberi tugas, pihak pemilik gedung harus minum kaca misalnya heat strengthen, karena dari segi kekuatan atau bangunan yang mengarah ke barat atau timur pada suatu sore hari dia akan menyerap panas, sehingga ada resiko thermal stress di kacanya sangat tinggi, dia bisa pecah sendiri. Sebenarnya hal itu sudah sangat diketahui oleh banyak orang, tapi dengan cost mungkin yang dianggap ini sebagai cost, bukan sebagai safety, itu yang di sini dihindari. Sebenarnya semuanya ingin menggunakan kaca misalnya dengan heat strengthen yang surface stress-nya lebih tinggi, lebih kuat. Tapi karena terbentur, karena tadi ada cost, sehingga dihindari. Sebenarnya owner pun ingin menggunakan kaca yang lebih baik, tapi kalau tidak ada peraturan, pasti inginnya lebih murah. Jadi karena itu kita perlu adanya suatu standar yang diacu bersama. Jadi mungkin saya tadi belum menyampaikan, sebenarnya di tim Pravi ini kita terdiri dari banyak pihak yang merumuskan peraturan ini. Jadi ada dari pihak arsitek, dari teman-teman dari arsitek, ada juga dari perwakilan developer, ada perwakilan dari fasad kontraktor, dari konsultan fasad, dan juga ada dari beberapa supplier, termasuk jadi dari asosiasi kaca lembaran juga ada. Jadi banyak pihak yang memberikan masukan dan juga ingin merumuskan peraturan ini, termasuk dari sisi material kaca. Kemudian tadi juga disinggung masalah keselamatan, bagaimana fasad harus fire safety, beberapa kejadian sudah disebutkan. Nah, kita coba merumuskan bagaimana fasad yang aman. Yang paling kami kejar sekarang ini adalah 2 hour fire rated yang harus dicapai di fasad. Karena ini memang isunya bila 2 hour fire rated berarti materialnya harus dipakai yang grade, misalnya kalau aluminium composite panel grade A1, A2 atau B, dan itu biasanya dipandang sebagai cost. Padahal sebenarnya ini penting banget. Kalau seperti tadi yang kejadian-kejadian dibentukkan, kalau tidak mencapai fire rated 2 jam ketika suatu kejadian, maka ini akan masalahnya cukup besar. Kemudian kenyamanan visual, tadi juga Pak Budi sudah singgung, kita ingin agar bukan hanya pengguna gedung yang selamat atau merasa nyaman dengan fasad, tapi juga lingkungan sekitarnya. Jadi itu salah satu tadi yang di-highlight dari Bu Doti, waktu keselamatan juga, kenapa kita pakai kaca yang heat strengthen, kita bukan hanya, jadi bila kaca itu tidak boleh sampai jatuh, pecah. Karena kalau dia kacanya sampai pecah jatuh akan membahayakan lingkungan sekitarnya. Jadi pada saat kita merumuskan regulasi ini kita bukan hanya memikirkan yang ada di dalam gedung, tapi juga lingkungannya juga harus aman, harus selamat. Dan juga harus nyaman. Salah satu untuk nyaman agar tidak silau ketika panas. Karena yang kita sering terjadi kalau bangunannya sangat reflektif, ketika kena sinar matahari sore ataupun pagi, atau yang sering dikomplain bila ada gedung di pinggir jalan layang, mobil lewat di sampingnya, pengendaranya akan sangat silau melihat gedung tersebut. Sehingga ini juga akan sangat membahayakan. Sehingga kita membatasi refleksi dari material bangunan itu 24%. Ini bukan hanya kaca tapi seluruh material. Karena material di fasad itu bisa jadi dia skylight, atap kaca, maupun juga aluminium panel, ataupun juga sekarang material lain juga banyak yang bersifat glossy. Ini yang harus diatur. Dan kita juga lihat sebenarnya kalau di negara-negara lain sudah maju dan sudah diatur. Singapura misalnya tadi refleksi material dari material maksimum 20%, sementara Malaysia 25%, dan Indonesia 24%. Angka 24% ini sebenarnya pernah muncul di peraturan yang sebelumnya, tapi di peraturan sekarang justru angka 24%-nya dihapus, hanya ditulis tidak mengganggu kenyamanan sekitarnya. Jadi kita propose ini tetap ada, karena ini penting untuk menjadi ukuran semua pihak. Karena kalau aturannya abu-abu, ini akan menjadi celah buat tidak diikuti. Ya, jadi itu yang bisa saya sampaikan. Sekali lagi ini masih draft. Kenapa kita sampaikan di sini? Tadi saya sudah sampaikan, Bapak Ibu semua punya concern yang sama, punya pengalaman, malah mungkin punya knowledge atau yang lebih banyak. Kita perlu banyak masukan dari Bapak Ibu, dan selanjutnya kita juga, ini masih roadmap kami, awalnya kita masih batasi seperti ini, tapi kalau tidak ada kita tidak mulai sesuatu yang jelas, kita nggak akan pernah jalan. Jadi ini memang baru awal. Jadi mohon keterlibatan Bapak Ibu semuanya, kalau bisa sekarang disampaikan silakan, kalaupun nanti kita ada sesi-sesi berikutnya mohon untuk mengikuti dan memberi kontribusinya. Terima kasih.
Luar biasa Pak Aryo, terima kasih, kita berikan tepuk tangan Pak Aryo and team yang sudah mencoba meletakkan step pertama untuk didiskusikan. Begitu ya Pak Aryo, luar biasa. Salam buat semua teman-teman yang sudah bekerja keras. Baik, tadi saya di awal menjanjikan bahwa kita akan menjaring pendapat dari teman-teman ya. Maka saya buka, mungkin dari, ya silakan Pak, saya kenal sekali Pak Kamaruzaman Onaning, silakan menyampaikan, mungkin bisa dibantu mic-nya. Iya, di tengah Pak.
Terima kasih atas kesempatan yang diberikan.
Silakan Pak.
Diskusi mengenai fasad ini menarik sekali Pak. Karena kita semasa pandemi itu kan proyek nggak ada yang jalan. Jadi kita ngelihatnya Zoom. Zoom-nya itu webinarnya Facade. Saya lihat webinar Facade itu lebih banyak daripada webinarnya IAI gitu. Sehingga kita mulai cinta sama Facade.
Bu Doti.
Enggak apa-apa, ini kan diskusi.
Iya.
Sehingga kita jadi cinta dengan Facade.
Oh,
nah, kemudian di dalam perkembangannya tadi, Bapak sebutkan ada konsep ya. Kalau bicara konsep itu kepada regulator Pak ya, yang pengambil keputusan, saran saya itu Bapak sebutkan dulu definisi fasad itu apa. Kemudian ruang lingkupnya apa, tujuannya apa, fungsinya apa, dan manfaat. Kalau kan nanti regulator itu meraba-raba fasad itu apa gitu. Kalau dia salah raba kita semua susah. Kalau saya lihat tadi Bapak bilang definisi fasad itu material, beda Pak. Jadi yang disebut fasad itu materialnya apa saja. Itu yang Bapak bilang udah betul, beton, kayu, macam-macam. Nah kemudian yang kedua, jangan sampai regulator itu membatasi tentang desain Pak. Bapak bayangkan kalau muka kita sama semua kan nggak indah gitu ya. Bapak kan sebelah kanan ganteng semua, sebelah kiri cantik semua gitu. Jadi fasad itu adalah keindahan ya. Keindahan berdasarkan fungsi gitu. Jadi kalau kita ke pesta perkawinan kan muka kita beda nih. Kalau kita main tenis, kalau kita main golf gitu kan beda-beda. Jadi itu semua fasad. Nah fasad itu mengatakan fungsi gitu ya. Nah itu mungkin perlu ditambahkan Pak. Karena ketika ada kasus, seperti siapa yang bilang tadi, kalau terjadi apa-apa kontraktor yang disalahin. Bapak yang bilang tadi kalau nggak salah. Nah itu bahaya. Jadi bagaimana dari segi profesional, aspek legal itu kita mesti menjadi hal yang utama. Jadi kalau kita masuk pengadilan, definisi fasad itu apa? Nah sehingga kalau ada yang penuntut, jaksa, polisi itu kita tahu, oh fasad itu ini, kalau di luar ini bukan fasad gitu. Nah sehingga kita semua aman. Kita kan semua di sini profesional kan, bukan pemegang saham gitu. Kecuali Astra, dia pemegang saham langsung. Bisa menentukan. Nah kemudian juga, tadi kan disampaikan juga tadi ya, Bapak bilang tadi ada 3 tahun dicek ulang ya kalau nggak salah ya. Nah barangkali pemeriksaan fasad itu jangan ditetapkan dari segi tampilan Pak ya. Mungkin dari segi konstruksi ya. Karena kalau tampilan itu, kita itu kalau developer ya, kalau jualan gedung itu tergantung pembelinya. Saya pernah punya hotel, ya bangunan lah, nggak boleh sebut nama. Saya punya bangunan di Menteng 10 lantai. Seketika dibeli oleh orang Malaysia, dia minta dirubah fasadnya. Jadi jangan tetapkan fasad itu sebagai apa. Jadi bisnis itu ya siapa yang nguntungin. Kalau istilah Ibu Astra tadi kan cuan ya. Sepanjang kita cuan kita jual gitu. Sepanjang belum cuan kita sewakan gitu. Jadi kita bermainnya seperti itu kalau kita developer gitu. Nah kalau yang lain-lain saya pikir tekankan yang masalah teknik Pak ya. Jadi fasad itu kan bukan struktur dia. Kalau bukan struktur apa jadi? Tidak mungkin fasad kita setebal struktur beton kan. Nah itu barangkali teknis pemasangan, kualitas, material. Kalau Bapak tadi kan udah pasti fasadnya itu baja gitu. Tetapi 5 tahun ke depan mungkin anak-anak muda sekarang ini bisa menemukan Pak material yang bagus untuk fasad gitu. Jadi per definisi jangan kaku Pak. Nanti kalau Bapak kasih ke regulator, dia pakai kalimat itu harus baja. Padahal mungkin 5 tahun lagi itu anak kita udah menemukan, oh, ada Pak yang lebih bagus Pak, lebih murah, lebih cepat gitu. Bongkar pasangnya lebih cepat. Jadi bisa ditentukan materialnya sesuai material yang ada di pasaran. Dan telah dites secara SNI maupun main-main dan lain-lainnya itu memenuhi persyaratan. Saya pikir itu dulu Pak, nanti kelamaan yang lain juga bosen. Demikian dari saya.
Terima kasih Pak Kamaruzzaman, tepuk tangan. Luar biasa masukannya. Saya yakin Pak Aryo dan tim sudah mencatat dengan baik ya.
Siap.
Karena memang penting juga sih apa terminologi dipastikan dan dideskripsikan. Terima kasih banyak. Mungkin ada yang lain? Silahkan. Mas Raffi ya, silahkan.
Halo, selamat siang.
Boleh berdiri mungkin supaya
iya.
kelihatan posisinya di pojok.
Baik, selamat siang Bapak Ibu yang saya hormati. Perkenalkan saya Raffi. Sebenarnya ini bahasan yang sangat menarik ya, tapi mungkin desas-desusnya kalau izinkan saya untuk bertanya, sebenarnya keprihatinan ini saya punya keyakinan bahwa kita yang melaksanakan itu lebih memiliki keprihatinan. Kadang-kadang seperti yang tadi di seminar dikatakan, kadang-kadang justru kita harus mengedukasi klien kita yang mungkin tidak memiliki knowledge sedalam dan sedetail ini, sedetail kita. Nah, namun seringkali yang terjadi akhirnya itu kembali lagi ke regulator, dan regulator ini mungkin tidak memiliki keprihatinan yang mendalam juga seperti halnya kita. Gitu. Sehingga kasus-kasus yang terjadi seringkali menyakitkan. Jadi mungkin pertanyaannya adalah lebih kepada ketika memang ada regulasi ini, seberapa kuat hal ini bisa dipertanggungjawabkan secara bersama gitu. Karena saya punya kasus, mungkin ini juga boleh kasus yang menjadi masukan dan input ya Bapak dan Ibu Doti khususnya sebagai arsitek. Karena buat saya sangat sedih gitu ketika ada bangunan yang secara fungsi perkotaan itu untuk kantor dan fasilitas. Tapi dijadikan bangunan parkir. Yang mana bangunan ini saya yakin kalau kita nilai secara arsiteknya, arsitektur itu kan harus melihat sisi bangunan dan sekelilingnya. Di mana sekelilingnya itu merupakan bangunan perumahan. Tapi bangunan ini yang tadinya fungsinya kantor malah dijadikan gedung parkir. Yang mana badan jalannya hanya 5 meter. Sehingga kita bisa tahu asap kendaraan itu ketika ada terjadi cross ventilation itu bagaimana kondisinya. Nah jadi kalau bicara tentang fasad jadi menarik. Kalau tadi kita bicara fungsi fondasi utama fasad sebagai proteksi, kadang-kadang buat orang-orang yang tidak kecenderungannya tidak memiliki kekhawatiran atau tidak mengerti ini menjadi bahaya. Dia tidak memproteksi kepentingannya untuk orang lain. Jadi kalau misalnya memang ada seperti itu, sebenarnya kan fasad bisa menjadi jawaban justru gitu. Bahwa fasadnya harus solid nih. Karena kalau tidak nanti rumah-rumah yang sudah didesain dengan baik untuk cross ventilation justru malah akan terbunuh secara perlahan. Nah itu kan hal yang menurut saya sebenarnya nih pembiaran ini terhadap developer maupun terhadap klien yang lagi menjalankan ini kan secara nggak langsung lagi membunuh nih sebenarnya. Membunuh 5 atau berapa keluarga yang ada di depan. Tapi regulator yang dihubungi itu tidak ada keprihatinannya gitu. Nah, jadi kalau menurut saya kalau kita lagi bicara regulasi ini ya baliknya ke tadi Bu, ketika memang ada regulasinya itu keprihatinannya bisa sedalam apa dan harapan kita tentunya sebagai semua pihak yang akhirnya disertifikasikan ada action yang kita juga bisa turut mendapatkan manfaatnya. Mungkin sekian, terima kasih.
Terima kasih. Kita berikan tepuk tangan untuk Mas Raffi nih, arsitek muda yang punya keprihatinan mendalam. Saya rasa kita nggak bisa menjawab itu karena kita masih pada step awal. Tadi seperti yang Pak Aryo sampaikan, kita akan mengundang regulator di workshop-workshop berikutnya. Jadi nanti mungkin Pak Aryo akan menjaring peminat untuk gabung dalam forum group discussion gitu ya. Pak Aryo nanti silakan dihubungi aja atau yang mau bergabung langsung menghubungi Pak Aryo pada sore hari ini yang punya keprihatinan karena jujur aja waktu kita tidak banyak, kita sudah hampir di penghujung dan ini adalah acara pamungkas ngobrol-ngobrol bergizi di sore hari yang mudah-mudahan nanti bisa menjadi insight, inspirasi buat kita semua untuk semakin memperhatikan desain kita, keselamatan, comfort gitu ya, terutama untuk fasad begitu ya. Betul. Karena memang ini trending topik hari ini fasad. Biarpun regulasi fasad nantinya kalau sudah lahir dan disahkan tidak akan berdiri sendiri ya Pak Denny, Pak Budi ya. Dari developer juga punya regulasi sendiri yang harus sinergi gitu ya diimplementasikan bersama. Baik, terima kasih banyak. Saya mengucapkan terima kasih kepada semua rekan-rekan yang ada di sini, Bu Doti, Ibu Putri mewakili AstraLand, Pak Budi, Pak Denny, Pak Aryo. Terima kasih juga untuk semua teman-teman yang sudah berbagi pendapat, inspirasi dengan kita semua. Mudah-mudahan ada dari teman-teman nanti yang bergabung dalam forum group discussion dan aktif ya menyumbangkan.
Kita sangat terbuka sekali Bu.
Iya, luar biasa.
Kita butuh
Pak Aryo
masukan dari
sudah.
Bapak Ibu semuanya.
Pak Aryo mau membagikan nomor telepon? Oh enggak ya?
Kayaknya udah tahu Bu.
Mau
Nanti
membagikan
ditulis di
tanda
belakang.
tangan. Baik, terima kasih banyak atas kesempatan yang diberikan kepada kami. Kita akan jumpa di kesempatan berikutnya. Saya kembalikan kepada Ibu Putri. Terima kasih banyak. Kami undur diri.
Okay, so we arrive here at the end of our event. We are still very excited to see this room full of people, but I would like to invite Ibu Doti Windayani to give her closing remarks.
Selamat sore, mudah-mudahan belum bosan ya. Ya, good afternoon. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, shalom, Om Swastiastu, salam kebajikan, rahayu. Today we have gained insightful design and technical insight from experts. Facade play an important role in several aspects, ensuring the comfort of indoor air quality, enhancing energy efficiency, mitigating the urban heat island effect, contributing to the city image through building shapes and lighting, exploring future possibilities for energy farming, and ecological issues like our participants to the community. And additionally, Daliana has explored on the extent impact of socio-cultural aspects. Addressing this issue requires a regulatory framework that ensure life safety and promote sustainability. Technology sharing events like today's should be supported by all of us, professional, designers, engineers, academics, manufacturers, construction industry, developers, and regulators. Our collective goal is to enhance our knowledge of design, material innovation, construction methods, maintenance and operation, and the most important driver is cost. Facade contribute 20% of the building cost. I would like to express my deepest appreciation to Zak Facades for organizing this successful event. We hope for the opportunity to collaborate with you again next year, hopefully. And I also want to thank you to all supporting partners, Rafi, and all sponsors, speakers, and participants. Thank you, and we'll look forward to seeing you next year. Salam Lestari.
Good evening, everyone. Just closing things for the evening. Thank you so much, everybody, for your time. Really appreciate that you all could join us. Just wanted to point out that we have recorded today's event, and we will send you a YouTube link to refer all the presentations and sessions once again on your email in about 1 week's time. And a special thanks to Parafi and IAI from us Zak organizers for helping us organize a successful event. And thank you to all our sponsors and partners. And so we have snacks and tea, coffee ready and served for you guys. So please help yourselves. And thank you so much for joining once again.